And again, I don't know if I've set up the latency properly. It might be a kind of low latency again. Yeah, it is taking a while to start here, so I think I might have screwed up the settings there. Oh, maybe not. It has started, so yeah. If I just put my hand there and move it, let's just do a quick test of what that latency is. I reckon it's about 20 seconds. No, it's going to be a bit like, yeah, about 20 to 30 seconds. So yeah, sorry about that. Because I think if you set it on ultra low latency, it is about 5 seconds, and you can't change it once you've set up the streams. I don't want to change all of the links and everything like that. So
Okay.
we're just gonna have to live with it, I'm afraid. Okay, so thank you all those who are sticking with me. It's the final leg of the marathon, if you will. Let's do it. Let's just get straight into it. So,
Yeah.
so differentiate 2x
Well,
plus.
while you're doing this one, I'm going to do some waffle. So we'll let you crack on with that. So jazzedly, no, you didn't miss any Fourier transforms, and I think there's only one chance of a paper that has Fourier transforms, and that is later. But I think even on that one, it might not be guaranteed. So sorry, not a vintage night for Fourier transform fans. But yeah. But welcome back to part 3. Thank you everybody who made it over from part 2. We are carrying on doing 24 maths exams in 24 hours. This is paper number 17, and we're on we're getting on towards the end of hour 16. So we're doing good. This is the old specification of English A levels, so this dates back to the start of the last decade, and it's core 3, so it's an exam you would have taken either in the January of your final year of school or the June of your final year of school. So it's really an exam for 17 and 18-year-olds, kind of like a university entrance exam. Our English university entrance offers are usually based on A-level results, and it's all core of pure maths, which in practice means a lot of calculus and trig. As we can see, we're just doing a lovely trigonometry and iteration question.
So change of sign there. Yeah. So yeah. Yeah, it's a lot of calculus, especially in core 3 as well. I think this is where the calculus really steps up a gear. As we've seen, we've done calculus of logs, we've done quotient rule. So use this iterative formula. I mean, can you think of anything more boring?
Oh yeah,
So 0.8. They don't do much of this anymore. So arc sine. Oh no, it's root of. So let's get this right. Root of arc sine 1 minus 0.5 that. Did I plug in 0.8? Just going to double check that. So 0.8 equals, and then that equals. Yes. So x1 is 0.80219. x2 is 0.80133. x3 is 0.80167. And then show that alpha equals that to 5 decimal places. Well, what does it want us to do? Just keep going. Okay, and then we can see that it is converging here. Yeah. So yeah.
It wants. No, it wants you to do the sign flip thing, right? Show that,
Oh God, yeah. So if we
yeah,
did, yeah, if we do f of 0.8015 65 versus f of 0.801575.
yeah, that's what it wants you to do, I think.
Well, I've changed my mind, James, because a minute ago I said, "Can you think of anything more tedious?" And the answer is yes.
Yeah. Well,
Unbelievable.
at least it didn't force you to keep iterating to you.
Well, I did do that.
Yeah.
Uh,
Uh,
so this is negative.
KQ wants to remind you to drink more water. So,
Oh yeah, I'll get on that. Don't worry. I'm not gonna shrivel up. I'm not a big water drinker anyway. It's probably the most water I've ever drank in the past 12 months.
yeah. One of the most shocking things I've ever heard was a podcast with Claudia Winkleman where she claimed that she never drinks water.
I mean, I go quite often without drinking it. Just coffee and lager, what more do you need? So we've got this funny looking function which got like a kind of cusp there. Would you call it a cusp? No, I don't think you call it a cusp. A quarter. Um, so the graph consists of two line segments that meet there. Sketch and separate diagrams that. Um, so, boom, boom. Now, if we do, where's my pencil? So if we shift it -4, then that point there is going to be there, and then we double it. So it's going to be a steep thing like that. And this point here, this is at 6 now. That point R. So let's call it R prime. And then this one's interesting. So we need to reflect it in the y-axis first of all. So I'm going to draw this in like a dotted line. So this is at -4, -3, and then we need to abs it. So up to there. So this is at -4, +3. So I think it's going to look like this.
Yep,
So like a
sweet.
big W.
Spot on.
All right, cool. I remember core 3 being the hardest one actually, but nothing too crazy so far. So f inverse of x. Oh god. So if we do the old y trick, y is equal to 4 minus log x plus 2. Bizarre that they've chosen to use that notation rather than just f of x equals. So if we do 4 minus y, e to the power of that subtract 2, I think that is the, when we rearrange. God, I've really done a lot of steps there. That could very easily be wrong. But I think it's good. So f inverse of x is equal to e to the 4 minus x subtract 2. B, the domain.
Mm. Sorry, keep going.
So the domain is... Oh God, I'm always bad at these. So it's defined for x to be greater than or equal to -1. So it's going from there. So imagine it's going to look something like that. Which I think that covers everything. Oh no, like that, doesn't it? So the inverse is going to look something like that. So I think the domain is positive x.
Mm.
Doesn't feel right though. Doesn't
Nope.
feel right. No, just no, something off about this. What am I not getting here? So x is going to be bigger than. Well, actually, I don't think this graph looks anything like that. So what does it look like? So it's logarithmic, but we make it negative and then we add 4. So I actually think it looks more like that. So that when we flip it, this is minus 1, 4. When we flip it, we need to take it down to 4 minus 1. And then so x is less than or equal to 4.
Yeah, that's what I think as
Yeah,
well.
yeah. So x is. I'm quite bad at those, you know. Um, I think looking at this actually, it can only land 4 or higher. So what that's getting at. So then the domain is that. Okay, yeah. Well, whatever. So C. So g of x is defined like that. Find fg of x. So f of e to the x squared minus 2, which is 4 subtract the log of e to the x squared minus 2 plus 2. Oh, good. So that's just 4 minus x squared, right?
Yeah.
And then the range, oh, for God's sake. So the range of that, so what did we say for f? The range of f is reals, but less than or equal to 4.
No, that's the range of f inverse, right? The range of f.
Oh, yeah. No, yeah, I'm still getting less than or equal to 4. The range of f.
Oh, range of f. Sorry, domain of f. Range of f. Apologies.
That's okay. Oh, but g. I think g. What does g look like? Why am I so bad at this? So g obviously looks something like that, just a bit more extreme. So the range of g is everything higher than minus 2. Strictly greater than negative 2. Yeah, because that always has to be something positive, even if it is very small. So I think the range of g is going to be greater than minus 2. And then if we apply f to that, wait, what am I doing? We've got this is fg here, right? So
Yeah.
fg of x is that. So surely it's just 4 and below.
Yeah.
Yeah. Sorry, just having massive. I really overthink these sometimes. So it's x is reals, but x is less than or equal to 4, because the domain of g is reals. So we're not really. Yeah. So I think this is fine.
Yeah.
Right, thank God for that. So the mass m of a leaf t days after it has been picked from a tree. I mean, they're really making a run, giving iteration a run for its money on the most interesting question in the paper. So when the leaf is picked from the tree, its mass is 7.5. So Tm is equal to 7.5. 4 days later, the mass has become 2.5. So that's like the conditions that we'll need once we've solved this, I think. Find the value of p. Well, P must just be 7.5 because that's when T equals 0. B, and then show that. So M is actually equal to M is equal to 7.5 e to the minus kt, and then using the boundary condition, if you will, 2.5 is equal to 7.5 e to the minus 4t. So a third logged divided by negative 4. Sorry, that's a third in there. So minus a quarter of that. And then if this is equal to t. And then t, if we shove the minus 1 in there, it's going to invert the third into 3. So this is a quarter log 3. And then c, find the value of t when dm by dt is equal to that. Okay. For some reason I thought this was going to come out to be like a differential equation or something. It feels like that sort of question, doesn't it? But it's not. It's just a modeling. Is 0.75 e to the power of sorry, this should have been k up here. It's weird that I did that. E to the minus quarter log 3 lots of t. Right, and then when dm by dt, well, what is dm by dt? We can find it, can't we? So that's 0.75 times minus a quarter log 3 times e to the minus a quarter log 3 of t. And that apparently, so we want the time at which that is equal to minus 0.6 log 3. So if we cancel those log 3's, if we cancel the negative 1's, if we do 0.6, multiply it by 4, divide it by 0.75, then we'll get e to the minus 1 quarter log 3 of t is equal to 16 over 5. So that means that minus 1 quarter log 3 t is equal to log 16 over 5. So t, I don't have a great amount of confidence in this, James, I'll be honest. This has gone weird. Log 16 over 5 divided by minus 0.25 log 3.
Yeah, I think you're okay.
No, it's not. It's not okay. I've got a
Oh
negative
no,
number
it's not
here.
okay. No, what's happened here? I think something. Yeah, no, 0. Flipping heck. Why is it 0.75?
Oh yeah, that's really weird because I started writing 0.75 up here, and I corrected myself, and then all of a sudden, oh God, that's really weird that I've done that. 7.5 all the way through here. So that is going to be wrong, which means that is going to be wrong. Let's just, yeah, okay. Well, thanks for the sanity check there, Jay. Honestly, I don't know what goes through my head sometimes. 0.6 times 4 divided by 7.5. And this is equal to, so that is 8 over 25, which is good. We want that to be small. Because now 8 over 25. So now can I find the, yeah, so instead of 16 over 5 there, I want, yeah, the problem with 16 over 5 is that it's 3 and a bit, which means it's bigger than e, which means its log is positive. With this, the log will be negative, so it's going to come out with a positive answer, because 8 over 25 is smaller than e. So 4.15 I get.
Sweet.
Is that it? Perfect. Days.
Days. Although they don't actually penalise you for not writing that here, which is...
Yeah, well, we're grown-ups now. You know, we don't actually care about that sort of thing.
But yeah,
So,
folks, famously on GCSE exams,
oh yeah, they're a nightmare.
they always penalise you for not writing the unit, which is really painful.
9 times out of 10, they do just give you the units on the answer line now.
Mm.
There's so much to assess the students on that they can't really afford to waste time on that. So prove that. Oh, we've already had a big fat trig identity. We had one a little bit earlier.
I like these though.
I do as well. Although the one that we had earlier was a little bit tricky. So we've got 1 minus cos 2 theta over sine 2 theta. So this is 1 minus cos squared theta minus sine squared theta is equal to, what am I on about? Sine theta cos theta. And then we want it all to boil down to tan theta somehow. So 1 plus sine squared theta, which is of course sine. So this is which is 2 sine squared theta over 2 sine theta cos theta. 2's die, sine theta and sine theta dies. This is sine theta over cos theta. It pretty much writes itself, really. So that was an easy one. I'm glad about that, because sometimes if you don't spot how to do it straight away, there's a funny trick in there. It can be a nightmare. So show that tan 15 is equal to that. Well, set theta equal to 15. And then 2 theta is therefore 30. And we know facts about 30. Because it's not everyone knows sine of 15, but everyone knows sine of 30. Right, James? We all know it?
I certainly do.
Cos 30 over sine 30. Well, I certainly don't. So 30, 60, which way round is it? It's the old 1 root 3 2, isn't it? But it must be
Yeah.
the root 3 is over there and the 1 is there. So sine 30 is a half. Well, actually, we've got to calculate what we're doing. Sine 30 is bloody radians again. So a half. So that's 2. And then cos 30, which is going to be root 3 over 2, over sine 30, which is a half. So this is just going to be root 3. Take root 3 as required. Okay, part 2. Solve that. Oh, and of course, it's not an A-level paper unless it's got these stupid reciprocal trig functions on there. What's your stance on those, James?
On cosec and cot.
Yeah, and all that rubbish.
Um,
I might be making my opinion clear to you here.
I mean, it's pleasingly retro, isn't it? That makes you feel connected to the ancient days of sea navigation and all that kind of thing.
It's just a waste of time.
But no, I mean, if I'm doing, back in the day, I used to just write -1 everywhere.
Yeah. It's a tricky one, this, because it's not actually clear what to do. Oh, it is clear what to do, because another word for tan 4x is cos. Oh, another word for 1 over tan 4x is sine 4x. So actually, this is again this identity up here with theta is equal to 2x. Because 1 over sine 2 theta subtract cos 2 theta over sine 2 theta. So this is all saying that tan of 2x is equal to 1. So that means that 2x is equal to the arctan of 1, which is 45. Now, just be a little bit careful there. We want the... So if we add 180 to that, we get 225. I might just go again, just for the hell of it. 405. No, I'm not going to get any more solutions than... Oh, yeah, I am. 585. I think we get 4 solutions here. Because now when I half all of these, we'll get x is equal to 22.5 112.5. Is this sounding like it's right?
Yep.
202.5. And, I mean, that 504 doesn't look right. 405 plus 180, what did that turn out? That must have been plus...
No, you're all good.
No, 585 at the end there.
Yeah, 505, sorry.
Yeah, just must have miswrote that. And then 290. I could have just found 22.5 and then added 90 to the rest of them. That would have been probably a lot easier. Okay, and then, yeah, so there are 4 solutions there. And no more, because if we add 90 onto that, it bleeds up into 3, yeah, higher than 360. Okay, not bad. Question 7. F of x equals all of that. Show that it actually equals that. So, yep. So let's do 4x minus 5. Obviously, this is x plus 3x minus 3. We're going to need to times that by x plus 3, and then we're going to need to do 2x. We've already got x minus 3, x plus 3. So if we times that by 2x plus 1, then this is all over 2x plus 1, x plus 3, x minus 3. I think that's right, isn't it? Times that one by 2x plus 1. Times this one by x plus 3. Yeah, happy with that. So, 4x squared. Take 5x plus 12x is plus 7x. Take 15. Take 4x squared. Take 2x. Now, this is not looking good at all. Because now I get a 5x. Oh yeah, this is fine. 4x squareds die. I get, so all over blah blah blah. So this is actually 5x, 5 of x minus 3, which is going to cancel with that one there. So we are left with 2x plus 1 over 2x plus 1, x plus 3, all under 5. So that's fine for that one. So easy, yep. 5 marks. And then the curve C has that equation. And point P lies on C. Find an equation to the normal to C at P. 8 marks. Oh boy. Right. So, we need f dash of x. And to differentiate this, it's the old partial fractions game. So, let's do 5 is equal to a 2x plus 1. So I'm doing this as a over 2x, a over x plus 3 plus b over 2x plus 1. So the x plus 3 is there. And then we get 5 is equal to, how much x have I got? I've got 2a plus b, lots of x. And then the numbers on the end, I've got a plus 3b. Now, 2a plus b is equal to 0. A plus 3b.
Why are we doing partial fractions? Can't we just differentiate it? We just multiply it out and differentiate it? Am I being dumb?
No, you're not being dumb. I'm being dumb. I was thinking that we needed to integrate it, but we need to differentiate it. You're absolutely right. So this is just 5 over 2x. Yeah, thanks for putting me on pause there, because I was going going
I
to
say
town.
we're going a long way here for little reward.
Yeah, we're going a long way for absolutely nothing. I mean, I always enjoy doing a partial fractions game, but we don't.
I was gonna say, I was thinking you saw this. Like, oh, I want to do partial fractions
Yeah,
today.
you're not going to stop me. So f of x is 5. Um, blah 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 blah. Let's do it like this: 2x squared plus, and we're going to use the chain rule here as opposed to the quotient rule. Although the quotient rule is pretty much going to be, they're both going to be disgusting to actually do. So minus 5 times all the gubbins to the minus 2 multiplied by the derivative of the gubbins. We get that, don't we? And now let's not waste, so this is f dash of x, and then now let's not waste any time simplifying this. Let's just get that in there. F dash of negative 1. So negative 1 equals minus 5, 4 of that plus 7, all over 2 of that squared plus 7 of that plus 3 squared. Something nice, please. So minus 15 over 4. Not as nice as it could have been. And now that is the gradient of the tangent. So the gradient of the normal will be the negative reciprocal. And we are at P, which means the equation is y plus 5 over 2 is equal to 4/15 of x plus 1. And I don't think I'm going to bother simplifying that. Is that looking right, or does it want us to simplify?
It does not want us to simplify.
Is that fine?
Yeah.
All right, good stuff. So actually, for 8 marks, that was. I think that 8 marks threw me actually, because I thought, okay, we're going to need to do partial fractions, and then it's the integration, and then it's. But actually, that's 4 lines for 8 marks.
Yeah, 3 marks. 3 marks just the differentiation.
Right. Well, what? And then 5 marks for putting it all together in as an equation of a line.
Yeah, 1 whole mark for doing the. Yeah, 1 mark for the substitution. No, 2 marks for getting the substitution right. 1 mark for inverting and
Bizarre.
flipping the sign.
Yeah, you wouldn't get that these days. So, it's this again. So r cos 3x plus alpha. I know there's a couple of shortcuts to doing this, but I always like to go the long way around here. So this is r cos alpha cos 3x. Subtract r sine alpha sine 3x. Therefore, r cos alpha equals 2 and r sine alpha equals 3. And then we get that tan alpha equals 3/2. So alpha is arctan of 1.5, which is 56.3. And then we could do something along the lines of 3 over sine of that to bring in r. However, that doesn't look good. But also,
right.
see, I do know the shortcut here is 2 squared plus 3 squared is r, isn't it?
I will say as well, like it surely wants us in radians here, right? Because it's given the range in radians.
Yeah, oh god, yeah, good point, very good point. So shift, yeah, radians there, 0.983. Usually, if you get it wrong on the calculator, it comes out to be a completely illogical answer. But 56.3 is actually incredibly plausible as a number of degrees. So, like, in this context. So, yeah, good spot. And now, if we do 3 divided by the sine of that, that's 3.6. So r is 3.61. which I think must be the same as root 13, right? Yeah, it is. So, it wants us in decimals, so 3.61 cos 3x plus 0.983. That'll do, won't it? Okay, so f of x is equal to e to the 2x cos, this has got product rule written all over it. Show that f dash of x can be written in that form. Oh, yeah. So e to the 2x, and then differentiate that. So we get minus 3 sine 3x plus cos 3x, and then differentiate the first. Okay, and then tidy it up. And hopefully bringing this into play. Yeah, so let's pull the e to the 2x out there. And then what is left is, oh yeah, it's just exactly that. We don't even need to do any work. So it's just 2 cos 3x subtract 3 sine 3x, which is in fact the that is the thing that we had in the first part of the question. So this is 3.61 e to the 2x cos 3x plus 0.983.
Smooth.
So, hence or otherwise, find the smallest positive value of x for which the curve has a turning point. Well, this is f dash of x, by the way. So if so f dash if inverse, what am I about? F dash of x has a turn equals 0 implies that cos of that is 0. Now, obviously it's pi by 2, isn't it? But if we then subtract 0.983, are we still positive? Yes, and then divide by 3. So I'm thinking x is 0.196.
Yeah.
Sorted. End of paper.
Sweet. Nice one.
Pretty smooth, actually. It's going pretty smooth.
Just like the ocean. Just like the ocean under the moon. Very good.
Just like that, yeah. I'm sure that's what we were all thinking.
Yeah, sun's pretty much coming up here as well. We are 17 and a third hours through. We're on to paper 18.
So we're already 20 minutes behind.
Yeah.
We can do Core 4 in less than 40 minutes, can't we?
We're gonna have to go fast.
What, for Core 4?
Well, you tell me, but a lot of integration, isn't it?
It's fine.
Okay.
I'm worried about the papers that we got left, though. Increasingly worried. So, yeah, let's just keep going.
Rock and roll. And again, I'm just going to do some blather while you're doing the first couple of questions.
Yeah, by all means.
Alrighty, folks. Thanks for sticking with us. As I was just saying, we are 17 and a bit hours through, and we're doing paper 18, so maybe slightly off course, but I think we can catch up. Core 4, very heavy on kind of algebra manipulations, and I think lots of integration as well. So Alex can really get that algebraic fluency rolling, can make it all happen. And we are finally getting to do some partial fractions here, so that's nice.
Yeah, at least we're doing that.
So thanks for sticking with us, folks. Of course, this is all in aid of Mind, which is an English, well, British, I think, mental health charity. They're really awesome. Hundreds of thousands of people benefit every year from the sort of pretty wide variety of activities that they undertake, from hotlines to workplace advice and all sorts of other things as well. So, we really appreciate everybody's contributions to that, but also just for the people who are joining us, watching along, it really makes the day. to have so many people with us. So please do ask your questions in the chat and all that kind of thing. It's lovely. While we're working through this paper, which is a core 4, so this would, usually back in the day, you would have been doing this in the final exam session that you ever sat at school or sixth form college. So aged 18, the culmination of a maths A level, really. Yeah. Starting off with a nice partial fractions question.
So, not got a lot of hope that I've done this right. Talk about algebraic fluency. Oh no, I think it's coming together. So 9c is equal to 9, so c is 1. So that will unlock the rest of them. A is 4, B is... let's use this one. So 4 subtract 1, take... So B is 3, I believe. Let's just check that. 2a plus... Yeah, that's good. And then 4 subtract 6 plus 2. Yeah, this looks good to me. Okay, yeah, do we get A is 4, B is 3, C is 1?
Yeah.
Alright, awesome. Yeah, because it just said find the constants. Oh god, I hate these. So find the first 3 non-zero terms of the binomial expansion of that.
Yeah, only the first 3 this time,
please. Only the first 3. Yeah. So yeah, that was funny. The whole bloody thing. So 9 plus 4x squared all to the power of negative 1/2. Now we need it in the form. We need to pull that 9 out. And this is 1. Oh god. Is it seriously that? Right. So it's the third. So what is it? 1 plus negative 1/2. And then whatever your x is. Plus negative 1/2. Negative 3/2 over 2 factorial times 4/9 x squared all squared plus no more because I'm not finding those. Let's just use the calculator here. So obviously this one's minus 1 minus 4 over 18 x squared. And then we've got minus 1 over 2 times minus 3 over 2 times 4 over 9 all squared, and then divide that whole thing by 2. So we get plus 2x to the 4th over 27 at the end there. So 1/3 subtract 4 over 3 times 18, which is 2. So my final answer, 1/3, take 2 over 27 x squared plus 2 over 81 x to the 4th.
Bosh.
Yes. Thank God I wasn't doing that again. Actually turned out to be alright. Okay. A hollow hemispherical bowl is shown in figure 1. Water is flowing into the bowl. When the depth of the water is h, the volume V is given by that I wonder if that's actually accurate. Sure it will be. That's like a segment of a sphere, isn't it? Find in terms of pi dv by dh. Oh right, so right. We're actually given h. So we're actually given v. So dv. Oh, right, let's just tidy that up a little bit first. So we've got pi over 4h squared subtract pi over 3h cubed. I think that's what that's saying, isn't it?
Yeah.
Yeah.
This is exactly what I would do as well, because the temptation. I think weaker candidates are probably reaching for the product rule here, but that's massive overkill.
Oh yeah, I think yeah, that's we don't want to be doing that. 2 pi h over 4, the weaker candidates. I love that. I mean, I've done some pretty weak stuff tonight, to be honest. So dv by, we want to find that when h is 0.1. So pi lots of 0.1 over 2 subtract pi lots of 0.1 squared. So this is when h is 0.1. Into the calculator we go, as they say.
I was going to say that. I was wondering when that catchphrase would come out.
I'm sure it's come out already, but yeah, classic maths teacher that, innit?
It's my favourite.
So pi by 25 is what I get. Pi on 25?
Oh, sorry. Yeah, pi on 25.
Okay, and then water flows into the bowl at that rate. Find the rate of change of h in meters per second when h is 0.1.
Mm. Chain rule.
So it's basically asking us to find dh by dt. Now, there's a very similar question that came up earlier, actually. Now, we have a pretty good grasp of dv by dh.
Yep. And they're giving us, well, I don't want to make it too easy for you.
I think it's that. But the thing I don't like about that is that we're going to have to flip this this thing over. Sorry. Oh, no, but at h equals 1. So this is, so dv by dh is actually just 25 over pi, because we can go straight into the specific case. And then, yeah, the rate of flow there is pi by 800. And then pi's cancel, 25 over 800 is 1 over 40, isn't it? 32, sorry. Yeah, 1 over 32. Okay.
I like that. Nice chain rule question.
Well, there was a fantastic, yeah, it was kind of on my mind actually, because there was a fantastic question on the further maths paper, which was, oh boy, if we have time later, I'll show it to you. I think you would have loved that one. Yeah, very a lot going on. It was to do with like, it's you start off with pure water, and then you add salt water. And it's like there was 3 grams per liter of salt water. So salt water was being added while the whole system was being drained. So it's like,
oh sweet.
So it's like the water is constantly mixing. So it's like how much salt is leaving. Like it's actually really quite involved. Classic further maths. Oh, it's the trapezium rule. I hate this. It's like the worst goddamn. Oh, just it's so bad. I don't want to do it. Oh, and it's not even done the table of bloody values for us either. Oh, for goodness sake.
I know, these are torture, aren't they? They really
Is there anything worse than this?
But this is when you got to remember it's all for a good cause.
Yeah, it is. Oh, this doesn't even look right. No, it does look right. 0.0333
Yeah.
1. And then we do 3. I wonder if anyone opens the paper and it's like, yes, it's a trapezium rule.
Well, again, it's very mechanical, isn't it?
Yeah.
So I suspect if you're not feeling very confident, you're quite happy to see it.
Yeah, I suppose so. Use the trapezium rule. Blah, 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 blah. So, what is So I think we're doing 1, 2, 3, 4 strips. So they're going to have a height of root 2 over 4. And then we add the two last ones plus 2 times the sum of the other ones. I'm just going to go straight into the calculator. So root 2 over 4 on the outside. And then 3.921 plus 2 of 0.03331 plus 0.324 plus 1.3596 equals 2.6.
Oh no, hold on. That seems too big.
2.6 seems too big.
Yeah, it does. What have we done? It's with the trapezium rule, isn't there like on the outside, don't you need a factor of a half? You've doubled everything, right?
Yeah. So we then half that. So yeah, you are right. So 1.3.
Yeah, as I say, it just looked, if it was a triangle, it would be less than 2, right? Less than No, it wouldn't be less than 2, but it would be around. So yeah, that's why my intuition was saying it seems too big.
Right. Yeah. Good intuition there. Okay. Right. Thank God that's over with. So I don't know why it's giving me like no space to work in this question. I'm gonna have to get some paper out here. So use the substitution. I think we can forget about the rest of that and just focus on this. Use the substitution u equals x squared plus 2 to show that the area of R is that. So I'll just remind people we've got y equals x cubed log x squared plus 2. Just begging for a substitution. Now we want to integrate y dx between 0 and root 2. And now it's saying, so u is equal to x squared plus 2. That means that du is equal to 2x dx. Oh yeah, I see what's going to happen here. So when we do, so this is equal to the integral, I'll worry about the limits in a minute, of log u du over 2x. So that, we get the x squared there, because it's just over 2 now. Yeah, that would have been 2x, that would have been x cubed. And now, u minus 2 is equal to x squared. So this whole thing is just a half of the integral of u minus 2 log u du. And then we just need to change the limits. So this is, well, when x equals, oh sorry, we're plugging it into this. Yeah, when x equals 0, we get 2, and then when we get root 2 squared is 2 plus 2 is 4. Oh yeah, it's actually showing us what we're aiming for. So yeah, that's fine. That's as required. And then hence or otherwise, find the exact area. Can you imagine seeing hence or otherwise and opting for the otherwise? Oh, I'm just going to do it a totally different way.
Oh dear.
So half, I'll worry about the limits much later, I think. So this is going to be, this got by parts written all over it. So, what do we want? Oh, terrible notation again here, sorry. And then our dv, ooh, no. Let's do log u there. And then our du is 1 over u. Our dv is u minus 2. V equals u squared over 2 minus 2u. This does not look good. This does not look good. So we have u dv. Oh, this is fine. Yeah, because that's all polynomial stuff now. So this is equal to half of uv, which is log u, times u squared over 2, take 2u. Subtract the integral of that multiplied together. So u over 2 subtract 2 du. I think this is fine. So this is a half log u squared over 2, take 2u, subtract u squared over 4, subtract 2u, and then we'll evaluate that between 4 and 2.
I'm struggling to see how we acquired the half. I'm sorry if I'm being thick.
That
but,
there?
The half that you've got on the outside, how did we acquire that?
It was always there. It's just there. And it came from the fact that it's dx is du over 2x. So it was here, and then we just pulled it out, and it's been along for the ride for the entire time.
Oh yeah, fine.
So
Sorry. Apologies.
No, it's quite alright. So half of oh god, what's the easiest way of doing this now? 4 squared over 2 minus 2 lots of... In fact, let's just do the whole thing. Four equals. So log of that squared over 2 subtract 2. Oh, we can't do that because it'll want it in like log form, won't it? Yeah, the exact area of our... Oh. So, God, it's so much juggling around. What is this, a further math question? Oh. So we get log 0, subtract 4 squared over 4 is 4, subtract 8, and then we subtract all of the with 2, so that's 2. Oh, this isn't good. Something's gone wrong here, James. Oh, this is log u times that. Friggin' hell. I just want this question to end. Half. So log 4 times 4 squared over 2. Take 2, yeah, which we just said is 0. Subtract 4 minus 8. Subtract log 2. 2, yeah, so that's minus 2. Subtract 2 squared over 4 is 1. Subtract 4. So that dies. We've got half of a bunch of stuff. So negative 4 subtract 8. So it's positive 4. Subtract... Oh my god, there's so many bloody minus signs. Why have I set it up like this? Log 2 plus 3. So this is a half. 4 plus 2 log 2 subtract 3. So it's a half brackets 1 plus 2 log 2. Or a half plus log 2. That's what I get. .19. I think that's pretty close to our approximation with the trapezium rule. A half plus log 2, James? You're muted.
Spot on.
Alright, perfect. Thank God for that. That was a lot of work for a question 4. Not even into the friggin' paper yet.
I was going to say we got 4 more questions. See if we can get to them by 6 a.m.
20 minutes. So the gradient of a curve with that equation. Okay, so differentiate this. So this is 1 over y dy by dx is equal to 2x over x plus 2 log x. And we're going to do it at the point where x is equal to 2. So when x is equal to 2, log y is equal to 4 log 2, which is equal to log 16, which means y is equal to 16. So dy by dx is equal to 2 plus 2 log 2, all multiplied by 16. So 32 plus 32 log 2.
Oh, sorry, I'm distracting myself talking to the chat. 32 plus 32 log 2, did you say?
Yeah.
Yeah.
Okay, good. Wow, and look at that for 7 marks. You know, compared to the last question, which was a substitution and then by parts. Oh my god, what's going on here? Parametric equations. I usually enjoy these ones. So, point P.
Oh, yes. Sorry.
You got excited there, did you?
Yeah.
Some parametric stuff.
Oh, did we skip question 6?
Oh yeah. Oh god, yeah, we did. Wow, yeah, thank God for that. Yeah, it's because the paper, because of the double-sided, I just kind of lose where I am. Definitely wasn't trying to cheat there, I promise. So, we've got, some vector equation. I thought this was on core 4, actually. So, L1 and L2 meet and find the position vector. Okay. Oh, I really, really embarrassed myself earlier to the point where I actually regret that this is going on the internet forever, where I made a real proper mess of a linear algebra question on the further maths. Properly bad. Like, truly, I was a little bit mortified by the mess that I made of it. Just brain fart after brain fart, because you know me in linear algebra, we're best of pals, but yeah, I just couldn't get my head around it. So if we add lambda to both sides of that first one, we get 2 mu plus lambda is equal to 11, and then if we add the 3 mu, we get 3 mu plus 2 lambda is equal to 18. So I think we can solve these. 4 mu plus 2 lambda is equal to 22. So subtracting, we get mu is equal to 4. And then that will now unlock lambda, which is equal to 3. And then we verify it with the bottom one. So minus 2 plus 3 of 3, which is 7. Is that the same as 3 plus 4? You bet it is. So there we go. And then we need to actually find the point of intersection. So let's do it with lambda. So we get 3, 3, 7. That's the point of intersection according to me.
Spot on.
B, finds the nearest 0.1 degrees, the acute angle between L1 and L2. Well, again, I think the dot product was supposed to be on the spec at this time, but I'm doing the dot product anyway because, come on.
Yeah, dot product's legal.
We're not about to use the cosine rule on this, are we?
No.
No, absolutely not. So 1 plus 4 plus 9. So we get the old root 14 down there. And then 4 plus 9 plus 1. We get the old root 14 down there. So I'm saying that cos theta is equal to that. So minus 2 take 6 plus 3 is equal to negative 5. So it's going to be the arc cos of negative 5 over 14, which comes out to be, oh, bloody radians again. Every time. I'd swear they put the questions in such a way that you're always in the wrong bloody setting. So 110 degrees. However, we want the acute angle, so we do 180, subtract that, and I think we get 69.1 degrees.
Yeah.
Let's just write it like that. Okay. Show that B lies on L1. Well, lambda equals 1 if it does, because of the first expression. And then we verify with the rest. 3 plus 2 is -1. Sorry, minus 3. Minus 2 plus 3 is 1. So yes, we'll verify that. That's fine. And then D, find the shortest distance from B to the line L2. Right. Let me get another piece of paper. I think I remember the technique for this. So we've basically got L1, L2, and then we've shown that B is somewhere there. The shortest distance from B to L2. Well, if we want to minimize, then we're going to attack and land on L2 at some point C, such that it's meeting L2 at a perpendicular. So I think this is how we do it. Let's let C equal x, y, z, and then we'll explore the properties of C. So B so we know B is 5 minus 1, 1. So how do we get from B to C? It'll be, so BC is the vector x minus 5, y plus 1, z minus 1. And this we are claiming is perpendicular to L2, which means it has a 0 dot product with its direction vector. I don't know if this is how I'm going to do it. So we get, so if we do BC dot 2 minus 3, 1, then we get 2x minus 10. So this must be 0 because the perpendicular at the point of closest approach. Ooh.
Well, Jazzledly wants you to use quaternions. They're not doing that today.
Absolutely not. Although this is what quaternions were made for, right? Plus z minus 1. I'm just a bit concerned about this. So 2x minus 3y, there's something in my stomach that's saying we're not happy. Well, because we've got that, but why are we doing that? Why are we let C be that? Because actually we know that C, because it lies on L2, is actually of the form, what was it, minus 5 plus 2 mu, 15 minus 3 mu. So I've made a meal of another linear algebra question. I insist upon embarrassing myself here. So this is actually 2 minus 5 plus 2 mu. Take 3, 15 minus 3 mu. I hope a group theory question doesn't come up later, because I'm making a mess of all the things that I'm supposed to be good at. You know, take 14, and this should work now. So how much mu have we got? We've got 4 of it there. We've got 9 of it there. We've got 1 of it there. So this gives us the 14 mu. And then we've got minus 10, subtract 4. Oh, just use the goddamn calculator, Alex. What are you doing? So minus 10, take 45, plus 3 is equal to 52. And that's 0. Divide by 14. Oh. I was really hoping that would be... Oh, I've not subtracted that other 14, which is not going to help. Oh, I really didn't want this to be such a freaking horrible number. Is the answer nice? Can you tell me that much?
It's not. No,
okay,
sorry.
okay. No, that's good, because I'm not getting a nice answer here. Take 45 plus 3, take 14 is actually 66 there. So we actually get that mu is equal to 33 on 7, which looks absolutely appalling. So C is actually, so let's do that. Let's divide by minus 14, so we get that in the calculator. Now, negative 5 plus 2 of those is 31 over 7. And then, let's get that back in the calculator. No, 33 divided by 7. 15, take 3 of those. Oh, why are you messing me about now? 33 over 7, 15, take 3 of those is... What is it doing? It was doing this before, actually. I think my calculator is come up with a bit of a glitch, you know. Because there's sometimes it will not give me the fractional form. There you go, 6 over 7. Absolutely bizarre. And then 3 plus 33 over 7 is 54 over 7. It's never... I've had this calculator for about 14 years now, and it's never done this, and now it's happened twice. I suppose we can factor the 7th out. So 3165 times the 7th. Or 31 over 7, 6 over 7, 54 over 7. Is that right?
I don't know. I'm sorry.
Question 6, D.
Yeah,
Oh wait, no, but we want to find the shortest distance. So
yeah.
it's yeah. So we need to just go through and Pythagoras the hell out of this. So
I
31
mean,
over.
I'm going to tell you, you're way off book in terms of the method here. I think it's working, but I haven't I don't know. I can't tell you whether about I haven't can't tell you about the intermediate steps. I think.
Is that 54 there, or is that? Oh, so I'm way off book, am I?
Yeah, yeah.
Yeah, it's 54 there. Well,
I think it is going to work, but my arithmetic is bad at this time in the morning.
plus 54 over 7 all squared. So please be the answer. I get 8.94.
Sorry, pal.
Oh.
Yeah. I mean, okay.
I mustn't be far off.
If you look at your diagram,
Yeah.
and just remind me what you know on your diagram.
Well, I know that BC is perpendicular to L2,
Yeah.
and we want to find... That's the thing that we want to find. We
And
don't...
I think there's a piece of information you've not included on your diagram, right? Do you want me to just tell you what it is?
Nope.
Okay.
No, because I think I've got it. It's because this isn't the vector that we actually want to find the length of. We want to find the length of this vector here.
Yes, BC. Yeah.
So let's... This is so awkward. I'm starting to hate this question. Because why did they make it 33 over 7? And then subtract 5 from that. So I think the vector that we want to find the length of is this. Minus 4 over 7. Now y is 33 over 7 plus 1 is 13 over 7. And then 3 plus 33 over 7 for z minus 1, 47 over 7. So let's try that. Root of 4 over 7 squared plus 13 over 7 squared plus 47 over 7 squared. 6.99?
Yes.
Yes, thank
Sweet.
God.
So it wanted you to use the angle. You calculated the angle already between L1 and L2.
Oh, of course. We've got that angle. Oh, God, that is so much easier.
Yeah. Yes. Sorry about that. But anyway, let's crack on.
Because
Two more.
because we know P, we know B, we know the length of that, therefore, and then, oh God, it's just basic trigonometry. Oh my God. Well, thanks for having the patience to let me carry out my silly little
I mean,
method
it
here.
worked. You got the right answer, and it's an interesting method for sure. Interesting that we don't need the to calculate the angle, but yeah, we didn't need to do that.
Yeah, well, this is that was the very much a linear algebra approach that I did there,
Yeah,
which
it's
is
good. I like it. I mean,
way too overpowered really for what it needs to be. Right, so Fig 3 shows. Oh, curve C. Oh, it's got integration. You were right about the number of integration questions on this. Jesus. So, shows part of the curve C with parametric equations. The point P lies on C with those coordinates. Okay. Find the value of theta at the point P. Right. Well, x equals root 3. So theta just equals the arctan of root 3, which is 60. Oh, but we're in bloody rate. You see what I mean? The alternator. I swear of it. So pi by 3 there. So theta is pi by 3. And now, show that... Oh, sorry. Line L is a normal to C at P. The normal cuts the x-axis at the point Q. Show that Q has that. So, we need to find dy by dx, which is dy by d theta, cos theta, over dx by d theta, which I believe is sec squared theta. So this is cos... well, I'm kind of... Yeah, it's dy by d theta divided by... Is the derivative of tan theta sec squared theta? I hope I'm right on that. So if we do cos of that and then cube
yes,
it.
the derivative of tan theta is sec squared theta. Yes.
Perfect, perfect. So that the gradient of the tangent there is an eighth, which means the gradient of the normal is -8. That's good. We want a sharp negative gradient. So the equation of the line will be given by y subtract root 3 over 2 is equal to -8x minus root 3. And we want when y is equal to 0. So we could just do 0. So we get -8x plus 8 root 3. So we'll that over there. So 8 root 3 subtract root 3 over 2 is that much root 3. Something gone wrong there. No, and then divide by 8. Is it 15 over 16 root 3?
No, close but no
Oh,
cigar.
for God's sake. I'm ruining everything.
No, it's okay. Let me look at this.
Yeah, I know what I've done. It's 8 root 3 plus root 3 divided by 2. So it's going to be 17. And then divide that by 8. So is it 17 over 16?
Correct.
Alright. Thank God. The finite shaded region S is shown in figure 3 and is bounded by the curve C, the line x equals root 3. The x-axis, the shaded region, is rotated 2 pi radians about the x-axis, right? So this is volume of revolution. For goodness sake. God, you were right about all the integration here. Unbelievable. So we're spinning it like that, aren't we? So what's the formula here? It's pi times the integral of y squared dx. Can you check that for me, please? So find the volume of the solid of revolution, giving your answer in the form that.
Yeah, pi times the integral of y squared dx.
Right. However, we don't have y as a function of x. So we'd better find it. Well, I think I've spotted this now. Yeah. So tan theta y equals. I just put those there, and the goal is to find the integral of y squared dx times by pi. Yeah. So if we know that tan equals sine over cos, then sine over tan is equal to cos. Oh no, this isn't going to help. This is not going to help.
Yeah, you need to pull the paper down slightly. We can't see the top line.
Sorry. Yeah, I thought about dividing because I want to get rid of the sine theta. I want to eliminate theta. It's not clear to me how we're going to do it. Oh well, maybe this. So if I do, this is pi times the integral of sine squared theta dx, but now dx is equal to sec squared theta d theta. So now this is pi times the integral of sine squared theta times d theta over cos squared theta. So this is pi times the integral of tan squared theta d theta.
Yeah, tan squared theta d theta.
Right, question is how the hell do you do that? So let me think about it. We've got, we just need to sort out the limits. Well, I'm just going to remind myself that we've not sorted the limits out because I just want to focus on, I'm just going to actually use the formula book here to see if we've actually got that. Because if we do have that, because tan squared is a bit, it's not pretty, is it?
I'm not sure I agree with you about that.
Okay.
Because there's
No,
a
no,
nice
no, no,
other.
no, 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 no. Okay, I actually know how I might do this. Pi times the integral. So if we called this negative pi over negative sine squared. Oh no, 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 nope. So there's this identity, but we're just making more work for ourselves there. I wanted to try and log it, but that's just, it's going to create more problems.
Yeah, don't log it.
Oh, come on, Alex. How the friggin' hell do you do this? This should be a normal thing that I know how to do, but it's
Yeah. If you don't want to know the answer, don't look in the chat.
tan is just the worst. You never want tan involved. You never, ever, ever, ever want tan involved.
So
So no, don't tell me,
okay,
don't tell me. Do not tell me,
okay.
because
I'm not going to tell you.
it will click.
Yeah,
We can
but
rearrange that.
definitely don't look in the chat because they've had the same thought that I had.
Oh God, of course. Yeah. So sine squared plus cos squared is 1. So if we divide through by, yeah, tan squared equals, sorry, plus 1 is equal to sec squared. Yeah, I knew it was a standard one. So this is the integral of sec squared theta minus 1 d theta.
Yeah,
All right, are you relieved now?
I'm very relieved. I
So
was stressed then.
yeah, I knew I'd get it. So this is now tan theta subtract theta. And now let's actually sort out these limits, because we've gone from arctan of 0, which is 0, and then arctan of root 3, which I think is one of the good ones. Pi by 3? Yeah, pi by 3. So this is pi, lots of tan of that, take that. You see what I mean? Well, no, I suppose this is actually reasonable for the calculator. So if I do tan pi by 3, we get the root 3 back. Subtract, yeah, because it's mixing surds and pi's, which it doesn't like. Subtract tan of 0 is 0. Subtract 0, so that's just 0. So this is pi root 3 subtract pi squared on 3. And that looks suspiciously like the form that we've got here. P equals 1 and Q equals minus a third.
Yes. Sweet.
Again, made a hash of that, really. And is that the end?
No, one more.
No, there's a
Question 8.
question. And look at it. More bloody into... Oh, God, you were right about this core 4. It's insane. I don't remember this at all. I thought you just learned a few little more calculus tricks. But no, you learned the rest of the entire field of calculus in this exam, apparently.
Yeah.
So find that. Well, this is actually a nice one. We can just like chain rule that one, can't we? So this is 4y plus. I mean, it's funny that they're using y to the half divided by a half times 4. So this is root 4y plus 3 all over 2, if you will. And then b, given that y equals 1.5 and x equals negative 2, solve that differential equation. And that's why they were using y. Because the integral of 4y, let's express it in this sort of way, minus 1/2 dy is equal to the integral of x to the minus 2 dx. And now this is root 4y plus 3 all over 2, which is equal to x to the negative 1 divided by negative 1 plus c. I almost forgot a plus c earlier, and the chat never forgave me. So when y equals 1.5, we have, well, that's 9, so root it is 3. So we get 3 over 2. And then minus 1 over negative 2 plus c. So that is just a half. So c is equal to 1. And then express in the form y equals a function of x. So what we've actually got here, we've got 1 minus 1 over x all times by 2 all squared minus 3 divided by 4. Anything that looks remotely like that, because I'm not going to bother simplifying it if I don't have to.
Obviously, we're a bit behind.
Yeah, so it's 4. 1 minus 1 over x all squared. Subtract 3 all over 4. Or
Yeah,
it might be 1 minus 1 over x all squared. Subtract 3/4.
Yeah. Yeah. I think Close enough, I think. Yeah, no, yeah, with that.
Don't say close enough. It's right or it's
No,
wrong.
no. Yeah, with that.
Okay, and that's the end of call 4. Okay, so it took took an extra 10 minutes. But not too bad.
Well, we did it in 50 minutes, which I think is good, honestly.
Yeah, it's good pace for a call 4, really. Shouldn't really complain too much.
So we're catching up.
We are catching up. So let's push forward. We got the old D1. So
No help on this paper, jeez. I don't
yeah,
remember. I did sit this, but I don't remember anything about it.
yeah. I mean, to be honest, I'm not feeling too great about this one.
Okay, here we go. So for those who were not sitting A-level maths, or do you want to talk about this, Ron?
No, it's okay. You go ahead.
All right. So for those who weren't sitting A-level maths back in the noughties, you used to do 6 modules. You had to do core 1, core 2, core 3, and core 4. And then you had some choices, and you could choose between optional modules in statistics, discrete maths, and mechanics. And D1 was the discrete maths module, or decision maths, yeah, that's what they called it. And so what you're going to see in this paper is a lot of algorithms. It's Chinese postman, traveling salesman, all that kind of stuff. Sorting, bubble sorts, binary sorts, all that kind of stuff. So yeah, in a little bit different.
Yeah, a little bit different and a little bit rubbish. It's all right. I've done this for the last couple of years, but for some reason, I don't know. I think I just I did. It's fine. So, a binary search is to be performed on the names in the list above to locate the name Kim. Explain why binary search cannot be performed not in order, because binary search is performed on an ordered list. So using an appropriate algorithm, alter the list so that a binary search can be performed. Right. Well, let's use the quick sort because that is the quickest, we would hope. So J, M, C, B, T, H, K, R, G, F. So we've got 10 names, 1, 2, 3, 4, 5, and that is our pivot there. So then we basically put everything that's after H and everything that's before H. So I think we get the F on this. Well, let's just make them decisions. So J, M, T, K, R, yep. And then we've still got CB and we've got GF on that side now. And then we get our new pivots of G and T. So now we get C, B, F, G, H. So these are all in the right place. And then I think T just goes to the end, right? J, M, K, R, T. So that's in the right place. Okay, and then we pivot here. So C, so B, C, F, G, H, and then pivot there, which is going to push, so it's going to be J, K, M, R. This is looking good now, but I think for completion we should pivot that and then verify that it doesn't change anything. Pivot here, verify, pivot here, verify. So there, BCF, GH, JK, MRT. Okay, now use the binary search algorithm to locate the name Kim. So I think, what do we do? You do 10 plus 1 over 2 is 5.5. So we search the sixth name, and it is wrong. Oh God, how do you do this now? Yes. So I think we haven't discovered it anywhere in this. So we reject from 1 to 6. And then, yeah, we've got position 7 left there. 7 plus 10 over 2, which is 8.5. So we search the ninth, which is too high. I've got no idea whether I'm doing this correct, by the way. And then 7 plus 8 over 2 is 7.5. So we search the eighth, and of course it still isn't right, so we reject that. And then we will say yeah. So it's in the worst possible place really for the binary search, but I suppose that's the whole point of the question. You must make your method clear. Well, I certainly didn't do that, but who's counting? Okay, define the terms tree. So connected graph with no cycles. I think that about covers it. And then a minimum spanning tree, a subgraph, which is a tree with hits every vertex and of smallest weight. I'm not going with like a proper formal definition here, but that's the idea. And then we're going to use Kruskals or prims next. Yeah, use Kruskals algorithm to find a minimum spanning tree for the network shown in figure 1. You must list the arcs. Oh yeah, at Excel they use arc. I'm vertex and edge myself. In the order in which you consider them. In each case, state whether you are adding the arc to your minimum spanning tree. So we find the edge of smallest weight and add it so long as it doesn't create a cycle. So in fact, let's get the highlighter out for this. So we are going to take this, which is AB. So we add that, and then which has, I think, weight 12, is that the smallest? Which is DE. And then 13 it looks like, which is BC. We've got 14 there, but we don't take it because it would form a cycle. We have got a 14 there though, which is BD. And then 15 we reject it because it would create a cycle, and then 17 we reject it because it would create a cycle. 18 we actually have a choice here, so it's dealer's choice. We'll take CF, which is there, and then reject. Okay, draw your minimum spanning tree. I'm not going to draw it, it's there, you can see it. State whether your minimum spanning tree is unique. No, because we could have removed CF and added EF, because we got that choice at the end. So that's fine. Kruskals is always one of the easier ones. Linear programming. Figure 2 shows the constraints of a linear programming problem in X and Y, where R is the feasible region. Write down the inequalities that form the region R. Oh God. Well, this is saying 2x plus 3y is greater than or equal to 12. This one is saying that x is less than or equal to 2y. So that's that one. That's that one. This one, 6x plus 5y is less than or equal to 60. That's that one. And then this one, we're going down. So 2y is less than or equal to 3x. The objective is to maximize 3x plus y. Find the optimal values of x and y. So we basically, oh God, how do you do this now? You do, so let's call it p is equal to 3x plus y. Therefore, y is equal to negative 3x. Ah, yeah, I remember how you do it now. So I need a ruler. So negative 3x and then p is what we want. So if I draw this with a gradient of negative 3, so slide it as far as possible over there, that is the one that we are going to take. So the optimal values of x and y, I think, are about 7.1. And y is equal to 3.6 sort of area. Given that integer values are now required, write down, obtain the optimal value of the objective function. I forgot to do that question. So that's 21.3 plus 3.6, which equals 24.9. Okay, given the integer values of x and y are now required, so we can take x is 7. No, we can't. Ooh, I think that line there, it's either that point or that point. So 3x, I think it's this one. So xy is equal to 6,4. I think you've been muted for a while, James. I haven't heard any of your. I'm hoping I'm getting the right answers here.
I'm letting you concentrate. Yep, spot on.
That's fine.
Oh, it's in the top of your head there for a second.
Oh, sorry, yeah. Oh, matching. Where's Hattie when you need her? So figure 3 shows possible allocations of 5 workers. Yeah, this is the traditional sort of. Figure 4 shows an initial matching. There are 3 possible alternating paths that start with A. One of them is that. So one of them is starting A3. So the other one, I'm just going to draw these. So
Thank you, Michael Searle, for your donation. Much appreciated.
thanks very much. It's been ages since we had a donation, actually. So thank you very much, Michael. And thank you to Kieran for drawing attention to my bald spot. That's absolutely fantastic.
I didn't like to say it.
Yeah, I know. It's pretty bad at the back there. So we could go that way. And then we go down to H. And then up to there. That's one of them. Oh, I don't know. We could go that way and then down to H and then across and then up to there. That's another one. That is the they are alternating paths starting from A. They're not good, but they do exist. Right, so list the improved matching generated using the alternating path. Right, so what's the game here then? Oh God, how do you do? God, yeah, how do you do this algorithm? So, oh no, that I'm thinking of this question. A3, because I know that we're going to have to use this to optimize it. That's always the question. List the improved matching generated by the alternating path A to 3. Right, so A goes to 3. And then we jump to R. and go to 4 and go to C. Then down to 5. What does it mean? I don't know what the question is.
No, I don't know.
Because it isn't. What does it mean? List the improved matching generated by that. But what?
Yeah, I don't know. I'm sorry. My decision maths is not there, I'm afraid.
Maybe we just do the matching algorithm.
It's 1 mark, isn't it? Uh,
I don't know what it's asking. I don't think
this
I
is a
wanted.
dumb
I
this
don't.
is a dumb question. Remind me what alternating path means.
So it's like you go forward along these from left to right, and then you go backwards along the ones that you've already created.
Right.
Um,
Well, is it just saying then like
but what does it
what
want?
is the?
What does it
I
want?
think it just wants the best matching, like because like you those 3 pairs, and then you can put like h to 1. Yeah, because actually you've slightly misdrawn it, I think. Because it's a to 3, r to 4. I think you've put and c to 5. You've put h to 5. But if you put c to 5, then you can put h to 1, and that's like a pretty reasonable matching.
Right.
J
Okay.
and
Yeah. Because the
1.
way I had it drawn, it wasn't actually possible to do the matching.
Yeah.
I mean, it still isn't
No,
possible.
it's not possible. Yeah, which is the answer. Um,
So
but
it's just that.
yeah, that's what it
Oh my
wants.
God, so dumb. Right. So starting from the improved matching found in part B, use the maximum matching algorithm to obtain a complete matching. Oh, it's this. Sorry.
And h to 1, right? You've got to put h to 1 as well.
Um.
Oh, you did it already. Sorry, what's the lag? Apologies.
Oh no, it isn't that. So what the hell's figure 4 then? Just some random. Okay, so the matching algorithm. So we need to have. Right. Let me just draw this again. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right. Let's make sure I get this right. A down to 3. Why couldn't it have just been A, B, C, D, E? You know what I mean?
Yeah, I mean, yeah.
C to 5. And then we've got H to 1 that we put in there. And then we got R to 4. So basically what we do with the matching algorithm now, which is quite a nice one, you put J to 4, which means you need to cross out this one. And then where can you go with that? You can go up to 3, but then you need to cross out that one, which means you go across to there, which means you need to cross out that one. And then you can put H to 2, and thus we've obtained a matching. So that is matched with that one. We've got that one down to there, that one down to there, that one across, and that one up. So that is how you get the matching. Right, sorry about that. I stressed here because I just literally didn't know what it was asking me for.
No, reasonable.
Okay, so figure 5 shows a network of gas pipes that have to be inspected. The number on each arc represents the length in case of the pipe. The route of minimum length that traverses each pipe at least once starts and finishes at A and needs to be found. So this is like a traveling salesman type thing. So what kind of graph are we looking at here? We've got odd, odd, odd. So there must be another odd somewhere. So we've got an odd, we've got an odd, we've got an odd, and we've got an odd. So it's pretty obvious to me, because basically we have to turn this into a semi-Eulerian graph. We're okay with A. Oh no, we're starting and finishing at A, which means semi-Eulerian. What does that mean? That means you're allowed to have two odds as long as you start and finish on the odds, isn't it?
Something like that.
Yeah. So for example, like this is semi-Eulerian because you can traverse it, starting and finishing at the odds. But if you want to start and finish it at the same place, it has to be that everything is even. So that means we need to consider the pairs. So we either pair up AD and then CF, or we pair up AC, which means we have DF, or we do AF and CD. If we did A to D, then the shortest route there looks like 16. And then CF, the shortest route, looks like 8. AC, clearly 9. And then DF, my money's on this one, is 13. Don't think we can beat that. And then AF is 18. Or 17, actually. 17 for AF, which is big. And CD is 7, which is small. So that's 24, that's 24, that's 22. So AC and DF are the pairs. So basically the idea is by inserting some edges, we increase the degree of those so that they're now even. So we've added 9 there. And we also add 13 of DF, which means we double up on those. Like that. So we've now transformed it into an Eulerian graph, and we've added 9, we've added 5, and we've added 8 to the total weight. So the pipes that need to be traversed twice are AC, DG, and GF. Write down a possible shortest route inspection route, giving its length. Well, the length is 98 plus those numbers, so we can definitely do that, no problem. Where the hell's my calculator gone? So 98 plus 9 plus 5 plus 8 is 120. And as for a root, oh boy, are you really going to make me do this? So let's go A, B, F, G, D, and then back to A. So that's kind of a tour of the outside. I think this will work. So we've basically gone bump, 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 bump. And now if we go C, B, E, F, G, E. So we've gone C, B, E, F, G, back to E. God, I really hope this works. And then C, G, D, C, A. So it was from the E, which is now C, G, D, C, A. I'm not going to ask you to look at the mark scheme for that, James, because holy moly.
Yeah, it just says it gives what like they didn't bother either. They've given one example.
Right, okay, but it is 120. I hope.
Yeah, it's 120.
Okay.
I'd like to know how they actually marked it in practice.
Yeah, I know. I mean,
any like long string of letters they just
yeah,
tick, I reckon.
I think there's a lot of routes there that are valid. So determine the finishing point so that the length of the route is minimized. Oh, sorry. It is now decided to start the inspection route at D. So we can actually start there. The route must still traverse each pipe at least once, but may finish at any node. So this is the Eulerian thing coming in now, because if we're allowed to start and finish anywhere, then that means we can start at an odd node and finish at an odd node. There's no need to fix DF. That means it is going to be, we've saved 13. So it's going to be 120. I think 107 is the answer here, James.
No.
Well, I'm pretty sure it is.
No. Why do you want to finish at A?
Ah,
Sorry.
no, we do want to finish at 8. Yeah, because
Yeah.
that actually CF is 8, so 106.
Yeah, 106.
Because
Sorry, I blurted out the answer there.
no,
Apologies.
that's quite right. That's just like in a math lesson, that isn't it? Where it's like you ask a student a question but accidentally slip the answer into the question.
Yeah.
Okay, this has got Dijkstra's algorithm written all over it, or Dijkstra. Actually, I never know how you say that. So, Dijkstra's algorithm from A to H. Yeah, we remember this one, don't we? 25, 11. Well, this is 0, and it is confirmed to be 0. And then 27 across to there. You pick the smallest. That's guaranteed. And then that becomes 21. That
Just
becomes.
say your dad's heading out, so
All right.
ta-ra to Jim.
Okay.
Thanks for
Yeah.
joining us.
Absolutely. No worries. It must be like 1:30 over there. So. Yeah. Absolutely pleased that you. I have been reading. I've not been able to respond to them all, but I have been reading all of your comments, and I really do appreciate it. So thanks very much for staying up late to support me. Really means a lot. So thanks very much. Good night. That's Canadian time, so it is like 1:30 there, I think. So it's been a pretty good effort. Okay, where was I? So and then that's 21. That's confirmed now. So that is now 50, and this is now 64. Smallest one is now 24. That's already done. This one goes to 39, which is the smallest. This one pushes down to 49, and then 39 plus 53, which is going to be something. I can't even be bothered writing it down because it's going to be beaten. Oh well, come on, let's write it down. Come on, do the questions. This is what you're here to do. 92. It is definitely going to be beaten though. And then 49 is going to be 59 there, plus 30 is 79. And then 59 plus 12 is going to be 71. So, 71. You're muted again, James.
Yeah, I'm not saying anything.
Yeah, but is 71 the answer, the shortest route?
It is 71. Yeah.
Yeah, it's good to just have that absolutely.
Yeah. Sorry, apologies.
No,
71.
it's quite alright. Just because it is decision maths. I don't have the most amount of confidence in the world in what I'm doing here.
It's going pretty smoothly so far. So
A, C, D. Yeah, the advantage is it's quite easy as long as you know what you're doing. Explain how you determine your shortest route from your labeled diagram. Subtraction. You go backwards, so it's like 71 subtract 12 to get that one, and so on. I can't be bothered explaining that in more detail.
Yeah, I mean, you pretty much verbalized what it wants you to write, so I think that's fine by me.
The track between E and F is now closed for resurfacing. So this one is now closed. Find the shortest route from A to H. Well, 39. So if we're no longer allowed to use that, then we do get 92 there. But we could actually get there in 50 by another means. Yeah, if we take this route. So it actually is going to go up to 72. And we're going to go the other way. We're going to go A, B, E, G, H. How's that?
Yep.
Awesome. Oh, God. I don't like these. Complete the precedence table in the answer book. Guess who didn't print that out? I always make so many mistakes on these. So a precedence table, we've got kind of event, and then it's A, B, C, D, E, F is the letter after E. Alex, come on. G, H, I, J, K, L. And we've got like the dependencies or the prerequisites, I'm going to call them, or so A depends on nothing, B depends on nothing, C depends on A and B being complete, D also depends on, no, D just depends on B, E depends on A and B, F depends on B, as does G, and then H depends on C and D. Now I depends on C, D, and E. J is the same. K is dependent on FHI. And then L is dependent on all of the above and G. So F, G, H, I. So that's the precedence table there.
Perfect, yeah.
What a load of rubbish, because we're not going to use that for the rest of the question, I doubt. Complete diagram 1 in the answer book to show the early times and late times. I reckon, correct me if I'm wrong, it's going to be a duplicate of this graph, but where each vertex is just like a box to put some numbers in.
Yeah, it's just two numbers at each node.
Yeah, so the early time. So obviously, 0, 0. I'll just put the numbers here. So
Yeah, just write the numbers down.
yeah. Don't worry about it, James. I'll just write the numbers down.
Just write the numbers, yeah.
Just write the numbers down. So we can get here in 4. And we can get, oh God, how do you do this again? Now, we can only get there after we've done these two, which means we're on 7 plus 2 is 9. And now here, this is going to be 11. Oh no, it's not. It's going to be 12, sorry. Because D takes 5, which means 12 goes there. Sorry, they're making a mess of this. 12 there. Oh God. Let's do, which node next? Let's do node 6. So what's the earliest we can get there? We can either get there in 12 plus 4. Yeah, 16. G over to this node. It's either going to be 7 plus 4 or 16. Yeah, we can start that on 16. Now this one can either be started on 19, 21, or 22. So the earliest we can get there is 22. So I think 22 are the numbers at the end. Is that right?
At point 8, yeah.
Yeah. So that's saying that the fastest that this exercise can be completed is in 22. Now, as for the late times, I think
I
this...
do think I think you have a in point 2. Are you accounting for the dotty line?
Yeah, no, I'm not. Sorry.
Yeah.
Good point.
And I think that affects point 5 as well.
No, I don't think it does. Because that was always dependent on the 7 there, which I just overlooked that. No, that is right, I'm sure. That's still a 9 there because no, it's the fact that this is actually should be 12 here. It's dependent on this one, which is we can only get here in 12, so
Yeah.
that one can only be done at 12.
Exactly.
What a minefield. So now to get the late start times. So when's the latest we can start this one? Well, I think we have to start that one at 16. When's the latest we can start that one? Also at 12. The latest we can start this one is, I want to say 17, but it's not actually, because L is dependent on getting here in 16, so this is also 16. This is really weird because quite usually these numbers end up to be very different.
Yeah, but I mean, I think this is one of the reasons that. So
So it's so interconnected, isn't it? This one, so it's like
yeah, this is. I think this is one of the reasons that people make these diagrams, though, is because the answers can be completely counterintuitive.
yeah, except in
And
this case,
yeah,
which it's turning out really not to be because it's basically turning out that nothing can really be delayed. We have to get there in 16, which means we have to get this started at 12.
yeah, but I mean that's useful information, right? If you're running a project, like yeah.
Well, such a project manager, aren't you?
Well, I mean, literally.
Yeah, literally. Uh, Now I think this one can be maybe able to be delayed actually. If we start the processes here at 8, we're still fine. So is it 7, 8 at node 2?
Yes.
Because that is not affected in that. And I think all the other ones are just the same number.
Correct.
Bizarre. I've never seen anything like that. State the critical activities. Well, looks like all of them really. Um, A obviously has some wiggle room. So I'm going to list the ones that aren't critical. So A, so not all of these. A has wiggle, B doesn't. I think C has a bit of wiggle. So B is critical. So this is the actual answer. D, you can't wiggle that one around. E, that definitely has some wiggle room. Sorry, you can't wiggle D. You can wiggle E. F, I think you can delay F actually. G can definitely be delayed. H, absolutely not. That must be critical. And I get a feeling that all the rest of them. Oh, I is fine. J, K, and L. Okay, so my final answer to that is BDHJL.
Yes, correct.
Thank God. In the answer book, draw a cascade Gantt chart for the project. Oh God. So a Gantt chart. We've got 22. So let's do. That's as many lines as I can draw. I think it was 11 lines. So let's have 0, 2, 4, 6, 8, 10, 12, 16, 18, 20, 22. Perfect. Okay, now A. So we're going at 0. It takes 4. So this is A. But, oh God, how do you do this again?
Well, I don't know whether to give you a hint or just let you get on with it.
Well,
Um,
I think it's that. And then B takes 7.
so Kieran, I have to say one of my guilty secrets of taking maths exams, particularly at university, was any exam that used a Greek notation. Just immediately write let alpha equals A, beta equals B,
Oh yeah,
and crack on from there.
Xi, isn't it, that you used to hate?
Oh, that was the worst ones. The squiggles.
I actually disagree with what I've just done there because actually we can get BDHJL. Yeah, oh, this is how you do it because it's the critical path. So let's just get these in because they can't be delayed.
Yeah.
So let's just get them in. Yeah, it's all coming back to me now. I don't think this has come up in the last couple of ones that I've done. It's been several years since I've done this. So I feel like I've spent about 5 hours on this. What have I done wrong there? Oh, for God's
So, yeah,
sake,
Dave,
what have
I think you're on the case.
oh, and then we'll have L and then J done in parallel.
Yeah, exactly.
J. I'm just so bored of this. So A, B, like, what about C then? So C starts on 7,
Yeah.
lasts 1, 2, 3, 4, and can we delay it? Yes, we could. It's got one nudge of wiggle room. Okay, A, B, C, D, E. So E also starts there, lasts for 2, and we can push that all the way up to 12 if we need to. So something like that. F
Yeah.
also starts on 7, lasts for 5. I don't know how it's
Excellent.
presented in the answer book, but
No, no, it's exactly the way you're doing it. You're doing it spot on.
yeah, because I remember the way I visualize this is that C is like a slider, like on a music mixing desk. So
Yeah.
you can actually physically slot them around. This is how I visualized it in my brain. And then you can push it all the way up to 16 if you want to. G,
Yeah.
it's so tedious.
No, I know. And the thing is, in real life, so of course, you know,
You just get some
uh,
software to do it.
well, no, no. I mean, so the thing is, like, so obviously for the last couple of years, as you know, of course, Alex, but our audience doesn't necessarily. I've in my working life has been working on a very large public sector project, a multi-million-pound project, um, and indeed IT project. And you would think, this is the sort of thing that you ought to be doing. But the thing is that very often it's actually really hard to estimate the amount of time things will take. So
Yeah,
that's the first problem with it. It's very difficult to incorporate uncertainty into this methodology. And the second problem with it, of course, is this is fine if you know the requirements and the requirements are nailed down. Um, but in reality, you often don't, or they change, or you know that you've got a set of requirements, but you're pretty sure they're going to change. And I think that's why, really, particularly in software land, they favour these alternative approaches. This is sort of part of waterfall, really, as a methodology, and it's not really favoured anymore. Certainly not in software land. But yeah, that's a pretty good looking Gantt chart, and sometimes I wish I did work in an environment where this methodology would work, because I think it would make things a lot easier.
yeah. Well, like you say, the time taken to complete certain tasks, um, you know, it's very difficult to calculate.
Yeah, Dave's saying, in reality, this chart goes out the window in the first month of any large project, and yeah, that's certainly my experience.
Absolutely, yeah, absolutely.
um,
So, considering the activities that need to be done in that time, well, yeah, if we consider the number of activities that need to be completed in this slot here, so even if you slide, well, okay, um, so G 5, so G must always be happening at the same time as F, which must always be happening at the same time as D, or one of the criticals. And then C, I think, is always involved there as well. So I think wherever you draw that line. Oh no, you could draw it there. Ah, but then you've got E to worry about. Yeah, so either you... I'm not going to write this in full detail. So if you slide G over to there, and then you ask person C to work on person 2 to work on project G immediately after C, that's fine, except now you've created D, C, E, and F as a four tasks that need to be done in simultaneity. The other option is to slide F all the way over there, and then again, no matter where you put E, you're creating a 4 situation. Let's say that that's acceptable.
Yeah.
Right, please tell me this is the last goddamn question. So, a firm is planning to produce two types of radio, type A and type B. Market research suggests that 50 type A radios should be produced. The number of type A radios should be between 20% and 40% of the total number of radios produced. Holy moly. Each type A radio requires 3 switches. This is another linear programming question. Right, so 3A plus 2B must be less than or equal to 200. That deals with that. The profit on type A, so profit is equal to 15A plus 12B. That deals with that. At least A must be greater than or equal to 50. So that deals with the first constraint. The number of type A radios should be between 20% and 40% of the total number of radios produced. So 0.2 of A plus B must be less than or equal to A, which is less than or equal to 0.4 lots of A plus B. And that's that one. And I think that's it. Obviously, there's some tidy up we could do here, but I can't really be bothered. What do we think about that?
Yeah.
Seven marks for that. That's really bizarre.
Yeah.
I am being a bit. Come on, let's actually do this. So, well, if we times through by 5, then we get A plus B is less than or equal to 5A is less than or equal to 2A plus 2B. Yeah.
I mean, I'm going to be honest with you. You've written down pretty much everything in the scheme.
Right. Okay. Let's just stop there.
Yeah.
Because this is fine. If we really wanted to, 4A less than or equal to. Oh, I can't be bothered. That's it. That's fine.
Yeah.
Right. Okay. So that is the decision paper over with. I thought that might be a nice reprieve from some of like the intense algebra and calculus that we've been doing, but also what a waste of time. So, right, we've got a couple of options now because this might be the time to do the applied A-level paper, which is the mechanics and statistics.
Oh gosh.
I think we need to get that out of the way.
Yeah. Is this the new spec? Yeah.
Yeah.
So for people who are paying attention here,
And I'll be right back.
All right, see you in a sec. So for people who are paying attention here, we are just about to do paper number 20, which is going to be new specification A-level paper. And unlike in the old paper, so the 2010 era paper, where we had 6 modules, in the new era, they've rationalized it. And now that means that mechanics and statistics are all part of the same paper. So this is what they have to put up with these days. Mechanics and statistics in the same box. And I'm really curious to see what the statistics content here is like, because I wasn't a big fan of the old or the 2010 era statistics content. Like lots of really kind of uninspired null hypothesis significance testing and that kind of thing, which is not my favourite. But yes, I'm sorry, I must stop saying old for 2010. It's the previous specification, so it's the last but one specification kind of thing. So apologies for that. Yeah. Well, Michael, so the reason they have to mix them is because of this. They're forcing it into this reformed framework, and basically with the way that they have to schedule all of the exams for all courses into a single exam session, and the way that British sixth form exam timetables are set up nowadays, it's a fixed number of weeks in late May and early June, and it's 2 sessions a day. And it's just not possible for that reason to separate out the maths and stats papers into two shorter papers. So yeah, that's why they put them together. So it's not really for any particularly good reason. It's entirely for administrative reasons. But yeah, I agree. I think it is rough having to do them in the same spot. Okay. No, I do not believe it does have any. I'm almost certain there's not the Fisher information on there. I don't think there's going to be anything fun, but we'll see. Like I say, I'm not actually familiar with the contemporary specification, so I'm just pretty curious to see what we're going to get in here. And I think with the mechanics in this, we're going to be seeing the usual stuff. I think we're going to be seeing probably suvat. I think we're going to be seeing pulleys, force diagrams with pulleys. Probably some questions about momentum. I think probably not the rocket equation on this paper. I think that's probably in further maths. And I think probably not the coefficient of restitution. I think that will be in further maths as well. And I'm not sure about impulse. Probably further maths as well, I think. Maybe. Yeah, you see, Kieran, it's a really fascinating thing about randomness in computer games. And one game that I really love is the game Dicey Dungeons. But I'm always really curious about, particularly at the start of some of the fights in Dicey Dungeons, whether there's something going on just to make the game a little bit more fun by reducing the number of impossible situations. Situations where it's impossible to win. So it's a very curious subject, how that kind of pseudo probability gets used in video games. Kind of interesting. Yeah. And so for those who are just joining us, the overlay is not quite updated. We just actually finished paper 19. The paper that we're going to be doing is paper 20. We've been going for 19 hours, so we're bang on track here. But we got to get this through this next one nice and quickly.
Nice and quickly, James. Are you sure about that?
Well, we got it.
So
there is no try, only do. So XCOM lies about stats, does it? I did wonder.
I've heard this is true actually. Yeah. Are we in nerd talk?
Yeah. Well, we're talking about Hearthstone and some other bits and bobs. So yeah. Dicey Dungeons. Yeah, Dicey Dungeons, awesome, Dave. I really like it. Terry, I mean, I like all of Terry Kavanagh's stuff. He's just a solid guy.
Right. Sorry to interrupt.
No, yes, let's do this.
I'm gonna need your support with this one. You know me and the old applied maths. Absolutely miserable. Have you told everyone in the chat that you're the resident applied mathematician in the group?
No, I didn't mention that.
Well, I mean, it is kind of true. Well, only because you're slightly more applied than the rest of us.
Did you say this is mechanics and statistics mixed, though?
No, so it's got a mechanics section. So in your mark scheme, I think this is mark scheme 3A. So there's about 5 mechanics questions, and then about...
Oh, so it's not mixed. You gave me the impression that this was mixed these days, and I thought it was... I just gave the whole explanation about how it's mixed because of the way the exam sessions are, so it's not mixed after all.
No, it is mixed. No,
it is mixed.
It's okay. one paper, which is half mechanics, half stats.
Okay, it is mixed. Okay, exactly. Yeah, this is what I thought. Sorry, I really doubting myself there, but it's got 2 separate mark schemes. Okay, fair enough.
Yeah, the mark scheme.
Different people to mark them. That's
fine. I think that was. I literally just took the words out of my mouth. Right. So.
Okay, fine. Let's get on with it.
Let's get on with it. So, particle moves with constant acceleration. At time t0, it's moving with that velocity. Find the velocity. Well, v is equal to u plus a t, even in the land of vectors. So v is equal to 4, 0 plus 2 minus 3. So this is equal to 8 minus 6. I'm not using i's and j's and all that rubbish, so you can, forget that. So at time t equals 0, the position vector of p relative to the fixed origin. So we start at that. Find the position vector of p relative to the origin at time 3. So what we're doing here, s equals... This is going to tell us the position vector at t equals 3. So this is equal to initial times 3 plus half times 9 times 2 minus 3, 12, 0, plus equals plus 9 over 2 times minus 3, minus 3 over 2 there. So this is 21 minus 3 over 2. However, that's assuming that's kind of from the origin, isn't it? But we do start at 1, 1. So I think we need to translate this up. So 22 minus a half? Doesn't look right. You're on mute there, James.
I'm thinking.
Well, have you got the mark scheme?
I do.
But obviously it's wrong.
No, I'm like, so they actually haven't simplified it. So, I guess my thing is like the UT, right? You're missing the UT.
That's there.
Am I being thick here?
UT plus half AT squared. It will say the final answer somewhere, surely. It might express it.
Yeah, it does. And no,
Like that.
like, okay, but oh yeah, it's because no. Oh my God, I'm so sorry. Oh yeah, it's because the particle doesn't start from the origin, right?
Yeah, that's why I did that. I added 1.
Oh,
Or do we need to subtract 1?
no, you add it, yeah. Oh, what is going on here? I'm so sorry.
I can't see why.
Oh yeah. Nine times minus 3. That's the problem. So in the second line, where you do half times 9 times 2 minus 3, you've multiplied out the top but not the bottom with the 9.
I did it on the calculator.
Uh,
I must have mistyped. Yeah, it's 27 over 2. Of course it is. So minus 27 over 2. So that becomes minus 27 over 2. I knew it. It was really odd that the numbers came out like that. So then when we add 1 to that, minus 25 over 2.
yeah, there we go.
Friggin' hell, this doesn't bode well. That's supposed to be the settling in question. Oh
Sorry,
my
I didn't make it easy for you there.
Jesus. So small stone of mass 3m is attached to the end of one string. Initially, stone B of mass m is attached to the other. So it's rough plane, so that we do have friction. The plane is inclined to the horizontal at an angle alpha. where tan alpha equals 3/4. The string passes over a pulley that is fixed at the top of the plane. The part of the string for AP is parallel, yeah, blah blah blah. Coefficient of friction is a sixth. Stone A is released from rest and begins to move down the plane. Stones are models as particles. The pulley is small and smooth. The string is light and inextensible. Right, any more information you want to give me for this? Just this is ridiculous. Using the model, write down an equation of motion for A. Right, let's get the forces on. So this is 3mg. This is mg. We've got a bit of tension pulling up there, got a bit of tension pulling up there, and we've got some reaction force R, and this is all at an angle of alpha. Any other forces on there? Friction. So it moves down, which means it's got friction, let's call it F, up there.
Yeah.
Right. So what does it actually want? An equation of motion.
Yeah, it wants you to do exactly what you're doing. Just write down an equation based on the forces.
Yeah, I know, but
Like F equals ma.
yeah, I know. Just give me a minute.
Sorry.
So
Oh, you did ask.
I did. I kind of rhetorically because it's just like
Oh, sorry.
and
I did not realize it was a rhetorical question.
yeah, it's just like an equation of motion. Because there's a lot you could talk about there. But yeah, okay, let's just do it. So obviously, if arctan of 3/4 is that, then cos of that is 4/5. Cos alpha is 4/5, and sine alpha is 3/5 because it's a 3, 4, 5. So start a new page for this. So 3mg sine alpha minus f minus t is equal to ma. 3ma. Now F, that's friction, that is equal to 3mg cos alpha times mu. So this is half mg 4/5. So this is 2mg over 5. So that's that. And sine alpha we know is 3/5. So 9mg over 5. I still don't really know what it wants from me. 2mg over 5. Subtract
Are we still doing
t.
QA here?
Yeah.
Oh no, you've already got it. It's that 3mg sine alpha minus f minus t.
So no, I would have never referred to that as an equation of motion. So show that the acceleration is a tenth of g. So now we actually do need to solve for a. So I needed to do this work anyway. Like that, am I the only one thinking this? Like an equation of motion seems really ambiguous to me. But anyway, so we have got tension to work out now. Okay, well we can think about this one. So the forces on this, T minus mg is equal to ma. Because they slide together, they will slide with the same acceleration. I think this is right, isn't it?
Yep.
So that means T is equal to mg plus ma. So now 9mg take 2mg is 7mg over 5, subtract mg plus ma is equal to 3ma. So the m's die, and then we're left with subtract g, subtract a. So if we add an a over to the other side, we get 4a. So that's dealt with that. And then we've got 7/5 of g. So 7/5. Don't like having a 7 there. Subtract 1. No more 7. Divide by 4. A tenth. So yeah, so I kind of skipped a few steps there, but we do get 1/10 of g. Thank God. So sketch a velocity. Oh, for God's sake! Seriously? I mean, velocity over time. I mean, it moves with constant acceleration, so it's just going to do that, right?
Yeah.
Right. I suppose the gradient will be no one cares.
Yeah,
so,
no one cares.
So in reality, the string is not light. State how this would affect the working in part B.
Great question.
Well, I think it would introduce more mass. So you would like introduce more mass, therefore R would be bigger, therefore friction higher, that sort of thing.
Not quite.
Well, I mean, it is true because
it is true.
If you had some mass pulling down here, and certainly it would have an effect on this object there.
So what? I mean,
yeah.
So this
go
is
on.
a classic, and it affects the tension.
So the tension is not
different.
Tension is not the same. Yeah, got it.
Yeah.
I kind of forgot about that. Danny kind of forgot about the Iron Fleet. So I don't know why that popped into my head. Oh God, could you get any more classic than a pulley system and then a ladder resting on a wall? This is we're pulling out. This is like the old jazz standards, you know. What am I talking about? So let's start. Well, let's read the question first. So a beam AB has mass m and length 2a. The beam rests in equilibrium on rough horizontal ground, so we do have friction here, and with B against a smooth vertical wall, so no friction up there. The beam is inclined. Yeah, coefficient of friction between the beam and the ground is mu. This is one of these very abstract questions where you're not going to get any information. The beam is modeled as a uniform rod. So it is indeed uniform. So I can put on there mg, which is halfway up the beam. Show using the model that mu is at least half cot theta. I've got a good feeling about this. I think I know what I'm doing. So let's get the forces. We've got a reaction there, and we've got a reaction there. It wants to slide down, doesn't it? Which means the friction is pushing that way, which is obviously mu r again. Now, I think I know what I want to do. I'm just trying to check to see if it's not a terrible idea, because we don't want to do forces left equals forces right. That's the only way to get on mu there, because we don't really know anything about this. But I think we're going to do moments. So we're going to take moments about B. So certainly this is my intuition anyway. I think we've got a theta in there. So we've got mg cos theta. That's trying to get it to go. These are the anti-clockwise. And also friction acts anti-clockwise. with mu r sine theta. And then the only clockwise is this one. So what angle is that? Well, that's 90 minus theta in there. And then that, so this here is theta, isn't it? Yeah. So this is r cos theta. And it's in equilibrium, so they must be equal to each other.
Did you say what you're doing? Are you deliberately dropping the A?
Oh, God, yeah, good point. So this is A. Oh, God, yeah, because moments, you obviously have to times by the distance to each of these. So that mu r sine theta was the friction, and then times 2a. That, yeah, that was a good spot. But now we can divide through by A. However, the factors of 2 are going to be very much part of this equation, literally.
Yeah.
So let's just bring together what we've got here. So mg cos theta plus mu r sine theta is equal to r cos theta. Now I reckon we can sort r out. What is r? R must actually just be equal to mg because forces up equals forces down. So let's get mg in there. And in fact, mg dies all across the board there. So this is starting to come together. No, it isn't. I've lost the 2's again. Sorry. So 2, 2. So, sorry, let me just write that again. To 2 cos theta plus 2 mu sine theta. Making a hash of this, sorry. 2 cos theta. Because now, boom. And then mu is equal to half cot theta. However, we want an inequality there, don't we? Yeah, so this is like at minimum. We're saying equilibrium is is attained when mu equals that. So certainly when mu is bigger, we will still have equilibrium. So therefore mu is at least that. I think that's fair, isn't it? Because if you have if it's even more rough, then it's just going to prevent the beam from moving even so. Do you know what I mean?
Yes. You're using the fact that F has got to be, yeah, you're using that relationship between F and mu r. Yes, yeah.
Yeah, yeah, because mu represents how rough the surface is, and
Yeah.
we've said that if it's in equilibrium, it's that. But if it's even rougher, then it's still in equilibrium. So I think this is fair. Okay, so a horizontal force of magnitude kmg, where k is a constant, is now applied to the beam at A. And of course, they apply it at the part where the diagram is already as busy as possible. Which way is it going, actually? Are we pulling? The force acts in a direction which is perpendicular to the wall. So we're pushing down? Oh no, perpendicular to the wall. So we are pushing across and toward. Yeah, so it is this. Okay, given that tan theta is that, and mu is half, and the beam is now in limiting equilibrium, use the model to find the value of k. What the hell is k? Oh, k is the force here. So this is a kmg force that's coming in there. And now the tricky thing here is the friction, I think, actually reverses direction, because now if we're trying to push the beam in, friction is now going to act this way. That's cheeky, that actually. That's I'm glad I spotted that, because that's the sort of thing that I don't always spot. Okay, so let's just get this information down. We've got that tan theta is equal to 5/4, We've got that mu is equal to a half. I'm thinking we're going to do moments again here. I don't see a reason why not.
Sorry, I'm getting distracted. We're doing B. And yeah, I think we're doing moments again.
And again, moments about B as well. I don't see any reason to really change what we're doing here. I think this is going to access... It's going to give us access to K here. It's just weird that we're able to do the same thing twice. I'm hoping there's not some kind of sting in the tail here. So, the weight... Right, let's get the A's in here this time as well. So, A, mg cos theta is trying to get it to go anti-clockwise. The new force 2a kmg is trying to get it to go clockwise. And then the reaction force r cos theta times 2a is trying to get it to go clockwise. And then we've got this mu r, so plus 2a mu r. Well, that is theta, so this is sine theta, isn't it? Oh, kind of gone half the page there. Theta, so mu r, 2a mu r sine theta. I think that's the setup.
I think we lost. Whoa. I think we lost the sine theta to. I mean, I'm still waiting for the stream, obviously.
Oh yeah,
But
2a kmg. Yeah, sorry, I didn't resolve that. So that should be times sine theta. Yeah, good point.
yeah, and yeah.
Surely that's everything. So cancel the a's. And mg is equal to r still. So mg, r, r. So what have we actually got here? We've got cos theta plus 2k sine theta is equal to 2 cos theta plus sine theta, because mu, we are told, is actually 1/2. So k is equal to cos theta plus sine theta over 2 sine theta. Okay, and then we actually know what theta is, because it's just the, let's do it in degrees, although for this I don't think it'll matter. So it's the arctan of 5/4, and then we stick that in there. So cos of that plus sine of that over 2 sine of that. 9/10.
Yeah.
Oof. God, it's not easy, is it?
No.
It's just like how much, how big of a diagram do you want? You know, like how much. Oh, projectiles. I like these.
Oh, we do get projectiles in here.
So a small stone is projected with a speed of 65. The point O is 70 meters vertically above. Yeah, I really like asking these ones at the moment, where it's kind of going off a cliff edge or something. Point N is projected at alpha, where tan alpha equals. So that's another. That's a 5, 12, 13 triangle. That one, isn't it? Another Pythagorean triple. Sun hits the ground at point A. It's moving freely under gravity. Acceleration due to gravity is modelled as having magnitude 10. That's odd. Using the model, find the time taken for the stone to travel from 0 to A. So we want the time taken. Right, so obviously, well, not obvious, but the way we do this, I think, is just to consider the vertical component of this, because you're basically projecting it upwards with an initial velocity of 65 sine alpha. Your acceleration due to gravity is -10 for some reason in this question. Maybe it makes it easier to mark it. I don't know. It's weird. We are interested in t, and we know s will be -70. The displacement will be -70, so it's going to go up, but we want the point at which the displacement becomes -70. So I think this will work. So s equals ut plus half at squared. So -70 is equal to, right, so what is, so if I do arctan of 5/12 and then sine it, I think we'll get 12 over 13. No, it's the other one, 5 over 13. Unlucky. So 5t over 13 plus half times -10 times t squared. Okay. I don't really like this. Let's times everything through by 13. So it's 910 and divide by 5. So -182 is equal to t is equal to, so this actually is -10 over 2, but we're timesing through by 13 and we're dividing through by 5. Sorry, James, what?
Stupid question. Where did the 5/13ths come from? Sorry.
That's the initial velocity, 65 sine theta.
Because we know.
Yeah, just resolve it.
Oh, we just did all of this. Okay, sorry. My bad.
That's all right. Then times 13 and then divide by 5. So -13 t squared. So 13t squared subtract t subtract 182 is equal to 0. What an absolute nightmare. So into the calculator we go. All of that. So I get t as 3.78.
We've gone wrong somewhere.
Or -3.7.
Yeah, no. -70.
Oh, this doesn't look right.
Yeah. Can you check that 5/13ths? I'm sorry to be a pain.
So it's arctan of 5/12, and then we sine it.
Yeah.
That's 5/13ths.
Okay, and just the
I think
again,
it's this.
really dumb question.
No, I think just let me check this. 70 divided by 13. Oh, what am I doing? 70 times 13 divided by 5. Oh my god, I can't use my frigging calculator anymore. 70 times 13 divided by 5. Okay, so it is 182. Sorry, getting frustrated.
And I think
There's nothing wrong with this.
the 13. Oh yeah, 60. Yeah, we've lost the 65, right?
Oh, friggin' hell. Oh, and it's so much easier with 65 in there as well, because 65 divided by 13 is 5. Yeah.
And also, it's 130 t squared, right? Not 30. Yeah, because you multiplied out by 13.
No, I'm just starting again. -70
Yeah.
is equal to 65 times 5 over 13
Yeah.
t minus 5t squared. And
Yes.
now this is -70 is equal to 25t minus 5t squared, which we can divide through. We get -14 is equal to 5t, take t squared. So t squared, take 5t, take 14 is equal to 0. I wonder if that factorizes. minus 7 plus 2. Equals 0. So t is 7.
There we go.
Thank God. It's so frustrating. I hate getting to the end of like a really complicated question and you've made one little slip up really early on, and it's you know. Right, find the speed of the stone at the instant before it hits the ground at A. So now we're gonna go horizontally. So it travels, so it's 65 cos alpha is u. T we know to be 7. A we know to be 0. V we know to be... Oh, sorry, what am I talking about? The horizontal velocity will be 65 cos alpha because it doesn't change. It has no acceleration. So, 65 cos alpha... Right, I'm just going to make absolutely double plus clear. I know it's 12 over 13, but I'm going to just make absolutely certain. 5 divided by 12, and then cos it. 12 over 13 times by 65, so we get 60. So its horizontal component is 60. Its vertical component, however, we need to work out. So, well, I suppose it's just v equals u plus at. We can do with that, because we know the time now. So u plus at, that is, what was it? 65 times 5 over 13, so 25, plus 7 lots of negative 10. So 25 subtract 70 is minus 45.
Yep.
And then it's the speed that we're after. So root of 45 squared plus 60 squared. 75. One limitation of the model is that it ignores air resistance. State one other limitation of the model that could affect the result. Well, I'm sorry. G is not 10. I don't know why we use 10 throughout. Well, I mean, it did make the question a lot easier, so I'm glad of it. But it's G is not 10 is a perfectly valid limitation of the model, so I'm going to go with that.
Yeah.
Any others in there?
Shape of the stone.
Oh, right, because it's not a particle.
Yeah. G is not 10.
Yeah, it wouldn't actually be a particle. Yeah, Jazzly there in the comments. Yeah, so yeah, we had the golf ball question. Someone joked like, oh, it doesn't take the curvature of the Earth into account. And I was like, yeah, it doesn't take the Coriolis force into effect either.
Or relativity.
Yeah, relativity indeed. Yeah. Yeah, from the perspective of the particle, it didn't actually take as long to reach its target because it was moving relative to the ground. So, right. Can we please just use column notate? I hate these I and J nonsense. You don't even use I and J later. I use like E1 and E2. But I suppose that's more convenient for if you're going into higher dimensions. Right, so acceleration, A is just dv by dt. So this is 3 over 2 t to the negative 1/2 minus 2. Find the value of t at the instant when p is moving in the direction 1 minus 1. So if it's moving in that direction, that means its velocity is that. So v equals 3t to the half minus 2t equals 1 minus 1. So it looks like t is a half. No, this isn't all right. So 3t to the half minus 2t when it's moving in the direction Hmm. Having a bit of a brain fart here. Sorry, hold on. Find the value of t at the instant t is moving in the if it's moving in that direction. Oh, it's some multiple of that. So that, isn't it? Okay, so if 3 root t is lambda, and let's say 2t is equal to lambda, so we want basically 3 root t to equal, sorry, root t there, to equal 2t, because we set those equal. And then this is 9t is equal to 4t squared. So t equals 0, but we reject that. So we get 9 is equal to 4t. Yep, so t is equal to 9 over 4.
Sold.
And that's 2.25 if we prefer, which I don't, but we'll write it down anyway. Yeah, yeah, moving in the direction, yeah, it's some multiple of 1 minus 1. That was stupid. So at time t seconds, the position vector of p is r. Okay, good to know. When t equals 1, r equals minus j. Right, okay, so we know that r is just the integral of the velocity dt. So this is 3t to the 3 over 2 divided by 3 over 2 all over minus t squared plus cd, let's call it. I guess we can get a constant either way there. I can't imagine why it's necessary that the constants are the same. Right, let's just tidy this up. So I've got 2t, yeah, so that's 3 over 2 over minus t squared plus some constant vector here. So that is r. And now we've got some initial condition. So, oh, yeah, so t equals 1 implies r is equal to 0, negative 1. So, d minus 1. Come on, just behave yourself. Minus 1 plus d is equal to minus 1. So d is equal to 0. And when t is equal to 1 here, we get 2 plus c is equal to 0. So c equals negative 2. So I'm going to go with this. I'm going to go with 2t to the power 3 over 2, subtract 2 as the x component, and then minus t squared as the bottom component.
Okay. Yeah,
I'm
spot on.
I'm going to assume that's right. So yeah, find the exact distance from exact distance of p from O at the instant when p is moving with speed 10 meters per second. Yeesh. So speed, which is which is the square root of 3 root t all squared plus minus 2t all squared. So this is the square root of 9t plus 4t squared is equal to 10, which implies that 4t squared plus 9t subtract 100 is equal to 0. Right. Let's just get the calculator out for this. Because it's a 4, I don't like 4, because it could be 4 and 1, or it could be 2 and 2. It's probably going to be 4 and 1. So 4, 9, minus 100. what do we got? 4. So t is equal to 4, or something negative, so we reject the other solution. So t is equal to 4. Oh,
Yep.
right, and now we want the exact distance p from O. So if we stick 4 into here, this is going to be... Okay, let's just do it on the calculator. So 2 times that's the power of 3 over 2, subtract 2, 14, all over minus 16. So that's the position vector, but if we want the distance, it's the root of 14 squared plus 16 squared, which is 14 squared plus 16 squared, or rooted, is 2 root 113, or 21.26. Don't know what form it wants it in. The exact distance, I suppose the third form, 2 root 113.
2 root 113.
Smashed it. Alright, that was actually alright. That was the mechanics paper over with. Now, the dreaded statistics.
Yeah, I'm a bit worried about this.
Well, if you're worried, then I don't know how I should feel.
Yeah. Somebody was asking, does your calculator have the normal PDF and so on? I think it does, right?
No, it doesn't.
Oh, does it not?
It's got it. Well, it can find. It could do normal one way. It can't do inverse normal, which is actually becoming a huge problem, and it's another reason why my students keep laughing at me. Because I genuinely the other day came out with, oh yeah, back in my day we had the big tables, and then she was like, oh, you sound exactly like my dad when he used to say that he had tables for sine, cos, and tan. I'm like, oh god, I'm old now. Which is embarrassing. You're typing again, aren't you? Never mind. So,
Oh, sorry.
no, it's fine, don't worry. So, state one disadvantage of using quota sampling compared with simple random sampling. I don't know. It's not random. What would you say?
I mean, well, you can't use quota samples for inference.
Because it's not random.
Yeah, it doesn't have any good statistical properties.
Right. Should I write that? It doesn't have any good statistical properties.
Well, no, I mean the point is it doesn't
No, I know,
have the
I know.
necessary statistical properties to do inference. So.
Yeah, okay. So let's go with that. In a university, 8% of students are member of the dance club. A random sample of 36 students is taken from the university. The random variable x represents the number of these students who are members of the dance club. Using a suitable model for x, find those things. Okay, so I think x... So basically every time you pick up a student, they either success or fail, and a success is they are a member of the dance club, so it's binomial.
Yeah.
With 36 trials, each with a probability of 0.08. Okay, so the probability that x is 4, well, you have, again, I'm imagining going through this tree diagram, you're going to have this times this, and there are 36 choose 4 ways of doing it. So, calculator time. I think this is actually just like a standard formula that you get in the formula book, but I think about it in the combinatorial sort of way.
I mean, I would encourage anybody to memorize this, honestly. If you're doing probability courses in undergrad and so on, you should just memorize this.
So this is 0.167. It's quite low actually, but I suppose we are asking for a specific value. So in that case, it's quite high actually, really.
Yes.
And then the probability that x is greater than or equal to 7 is 1 minus the probability that x is less than or equal to 6. Now, the students these days, they have this on their calculator. You know, they have the less than. So this is the sum of I equals, because we could have 0 to n of 36 choose I 0.08 to the power of I times 0.92. So yeah, success to the probability of success to the power of the number of successes, probability of failure to the power of the number of failures, which is that. And my calculator can actually do this, because this is how I've been navigating my way around that. So if we do 36 choose x in the calculator multiplied by 0.08 to the power of x multiplied by 0.92 to the power of 36 subtract x, and this is all between 0 and 6. Okay, and let the calculator think for a minute. It really does take some time. So 0.9777 blah blah blah. So 1 minus that. Very low probability here. 0.022. Why is that low? Well, we're asking for more than 7. Well, yeah, we're asking for 7 or more to be members of the dance club when only 8% of them are even there. So I think this is reasonable that you get a very low probability there. Is it 0.022? Awesome, awesome. So the probability that a student is a member of the dance club and can dance the tango. Excuse me? Oh, only 40% of the university dance club members can dance the tango. So find the probability that a student is a member of the dance club and can dance the tango. Is that how you say it? Dance the tango.
I have no idea.
Asking the wrong person here, aren't I?
We've been tangoed.
Yeah, oh God, that's a blast from the past. Well, surely it's not just as easy as 8 over 100 times 40 over 100, is it? Or is it?
Why not? Yeah, I think it is.
Because yeah, they need to be in. So it's this and this. So
yeah, it's 1 mark.
It is 1 mark. So this is 0.032. I've literally never heard the phrase dance the tango in all my life. A random sample of 50 students is taken from the university. Find the probability that fewer than 3 of these students are members of the dance club and can dance the tango. If I hear the phrase dance the tango one more time, I'm going to lose it. I'm sorry, this is absolutely bizarre. Well, this is just like, let's call it y now. This is another binomial variable, n 50 attempts, but this time, because we have a lower probability because we're including the dance in the tango or whatever it is, so p y is less than 3 is what we're interested in there, isn't it? Fewer than 3, which is p y is less than or equal to 2. Okay. So I'm going to do it on the calculator again. I equals 0 to 2 of 50 choose I, 0.032 to the I times 1 minus that to the power of 50 minus I. Let's just get the calculator to do it. That's what we're paying it for. 50 choose X times 0.032 to the power of x times 1 minus 0.032 to the power 50 minus x. Probably no faster than actually just working out the 3 cases. There are only 3 situations here. There's the 0, the 1, and the 2 case. But this is 0.785. So that's what I get.
Yep.
And quite a high probability because it's quite probable that we would draw not very many, because it's quite rare that someone is a dance club member and can dance the tango. Right, let's move on from that.
Yeah, let's never talk about the tango again. Come on.
Okay, Mark took a random sample of 16 students from a school, and for each student recorded the number of letters X in their name, the number of letters Y in their... Oh, so X in their first name, so X in their last name, and Y in their first name. The results are shown in the scatter diagram here. So, describe the correlation between X and Y. It's a very tenuous negative correlation, I would say, there. I would almost go as far as to say no correlation, but I think it's just about negative enough. Let's call it a negative. I don't know whether it wants weak negative. Mark suggests that parents with long last names tend to give their children shorter first names. Use the scatter diagram to comment on Mark's suggestion. Yeah, I agree, because if we are going with this premise of negative, then it is true as one increases, other decreases. That's what a negative correlation is. The results from Mark's random sample of 16 observations are given in the table below. Oh my god, do not make me calculate Spearman's rank correlation coefficient. I've got a sick feeling that that's what it's going to make me do. Use your calculator to find the product moment correlation coefficient. Okay, so it's not Spearman's, but it's basically the same. I mean, what is the difference, really? Oh, God. Now, how do we do this? So, I think we do this in statistics mode, and in the A plus BX case, yeah, here this looks like it. So 3, 6, 8, 7, 5, 3, 11, 3, 4, 5, 4, 9, 7, 10, 6, 6. Moving on to Y. 7, 7, 4, 4, 6, 8, 5, 5, 8, 4, 7, 4, 5, 5, 6, 3, and done. Now, statistics, we'll be into regression. I think R minus 0.54.
Spot on.
That looks like a correlation coefficient.
Spot on.
Well, the calculator did most of the work, to be honest.
Well, I know, but I mean, come on. You know, that's some flashy calculator.
That is some flashy calculator. Yeah.
I enjoyed it.
Which this is higher than I thought it would be, actually. Look at that, because this is just a nonsense. I mean, would you really consider this to be a serious?
Well, listen, I've got strong feelings about correlation coefficients, and they're bad, so especially when your data is discrete.
As spurious as this. And I also think they are kind of, they're not linear, are they? Like...
Yeah, they're not linear. They've just got horrible properties all around.
Yeah.
I don't advise people to use them in practice.
Interesting. So, test whether or not there is evidence of a negative correlation between the number of letters in the last name and the number of letters in the first name. State your hypotheses clearly. Well, our null hypothesis is that the correlation... there's no correlation. And then the alternative hypothesis is that there is some negative correlation. I think this is right. Okay, now I need the formula book here, because this does have the statistical tables. So critical values for correlation coefficients, page 37. It's a whole book.
Is this really what they teach people to do? Hypothesis tests on the correlation coefficient. God almighty. I would never tell somebody to do this. I can't think of a scenario. Anyway, sorry, carry on.
What's the sample size? 16?
Oh god, I didn't even think of that. Even worse.
Yeah, I mean this is bad, isn't it?
It's poor.
I really hope it turns out that there's not enough evidence, because I think this is the only reasonable conclusion that someone should draw. Right. So the critical value, and I'm not talking about on a D20, for 16 is 0. Oh no, It is significant. So I think because 0.545 is greater than the critical value, then we do reject H naught. Is that right? There is evidence.
Oh, sorry, got distracted. There is evidence, yeah.
Unfortunately, because I was really hoping that there'd be a moral in that question which says don't do that janky level of attempted inference. Okay, Stav is studying the large data. Oh, right, the large data set. Right, we might have a problem here because I haven't actually studied the large data set. I've got no idea what it was back in 2015.
Okay, well, let's ditch it then.
Well, no, it looks like we're just calculating some means and standard deviations here. We might have a problem with D. Let's not lose hope just yet. Right, so okay, so we're coding the mean pressure using that formula. The data for all 30 days from Hern. Where the hell is Hern, James? Is that in the UK somewhere?
I have no idea.
Never heard of it. It's one of these villages that exist purely for the purposes of measuring the weather.
I've just looked it up, and it doesn't even. It says Hern, Bordon. I don't know where Bordon is either.
What the hell is that? Are we even British, James? State the units of the variable x. Well, it's pressure, so it's pascals, really, isn't it? What a very, very, very strange question to have on your A-level statistics paper. What is the units of pressure?
It's, okay. It's hectopascals in the large data
Oh,
set.
right. Okay. Even weirder. What if it? What
Yeah.
even is a hectopascal? Is that 100 pascals?
I have no idea. It just said, I'm just reading it out.
Well, hector. That's the Greek for 100.
Okay. Thank
Um,
you.
yeah. The hecaton kyres in Greek mythology, they're the 100-headed. Oh no, they have 100 hands and 200 heads. The hecaton kyres, like the first children of Gaia and Uranus. But anyway, don't get me started on that. So the mean pressure for these 30 days, well, it's the sum of the y's. I'm just hesitating here because we actually want x, don't we? The mean pressure is x. So actually, I think we need the sum of the y's plus 30 lots of that, because every time we add a y and then divide by 30, I think this is the answer. Because x is y plus 1010 is x. So every time we add the x values, we're taking the y and a copy of 1010. So we're going to eventually end up with the sum of all the y's plus 30 of these, 30 copies of that. That's what I think, anyway. So 214 plus 30 times that, all divided by 30. Please tell me we get 1017.13.
We surely do.
Awesome. I was worried about this. Okay, find the standard deviation. Oh God. So, standard deviation. Well, it is you basically do your value, subtract the mean squared, divided by, so it's the average of the distances to the mean, isn't it? Divided by 30 and then root that whole thing. However, there's another way to do it. which involves the information that we've actually got here. Because I think you can actually do this by doing, what do you do? The sum of the y squareds multiply, subtract the sum I think you subtract the mean squared. Help me out here, James. What's the, oh, it must be in the formula book. You must know your way around a standard deviation. You're muted again, by the way.
Oh, sorry. I mean, I just usually get R to do it right.
I knew you were going to say that.
But yeah, Jazzadly's just posted it.
Yeah, it's that. And then do we divide by 30 still?
Yeah. Well, you got to divide the
All by 30.
It's.
I've got a feeling that actually, because that's not exactly right, is it? You can't just square in like that. Yeah, this is variance, but we're going to square root it. So we don't divide by 30, is that what we're saying?
We definitely do the sum, and then.
Yeah. Well, it's 5912. Oh, wait a minute. We're also talking about y here, not x. So that's another problem to worry about. But actually, this is this. Yeah, this actually doesn't matter. They're going to have the same standard deviation because one is just shifted up from the other. So whatever the distribution of one of them is, you bump it up. The spread is still the same.
Yeah.
I think that's right. So that, and I'm going to subtract. Oh, I need to subtract the mean, which is 214 over 30 squared. And then root it.
Mm-hmm. You root it right at the end, yeah.
And we don't divide any of this by 30.
No, you gotta. So I think you do divide it by 30. Yeah, that 5912. You want to divide that by 30.
Yeah, because
yes, that's it. What you've just written. So that 5912, you've got to divide that by 30, and then the 214 by is within the thing.
Right. Okay. Yeah, I can't quite, because this is how I think about standard deviation, and I know that there's a way to do it like this, and I've never quite understood why that works. Because it's not how it works, is it? You can't just square that and you get that. I don't know. I've never actually done the algebra that actually shows that they are the same.
Yeah. So you basically that expression using that Jazzadly posted for the variance, you basically just have to mess around with that and some summation symbols, and you can kind of figure it out. But
yeah.
At this time in the morning, I'm past it, I'm afraid.
Yeah, that's probably fine. So this is 12.09.
Yeah.
Okay, now, this is the weird question that we might not be able to answer. So, Stav knows that in the UK, winds circulate in a clockwise direction around a region of high pressure, in an anti-clockwise direction around a region of low pressure. The table gives the daily mean pressure for 3 locations from the large data set. The cardinal wind directions. What the hell is going on? You may assume that these 3 locations were under a single region of pressure. Using your knowledge of the large data set, place each of these cardinal wind directions in the correct location in the table. So we're asking which way is the wind blowing at each of these, I'm sorry, Pascal's cardinal directions of the wind. Did the examiners just like get high and absolutely lose their minds when they wrote this question? What is going
Yeah.
on?
So yeah, I think.
Well, I think I can. Right. So where are all these places? Obviously, if we just draw the UK here. Heathrow. That's obviously like London, isn't it? Can we Google where Herne is?
Yeah, it's in Hampshire.
It's in Hampshire, so that's like south.
So yeah, it's like southwest of Heathrow.
So like south coast,
No,
or like here.
like obviously I can't see, but it's like southwest of Heathrow.
Okay, that's fine. And then I don't even know how you pronounce this one, but that looks like Scotland to me.
It is in Scotland, yeah.
Okay, so it looks like a kind of garlic sort of thing. Right, so this looks like it's going to be a region of high pressure because they're all bigger than the mean. So I guess that's high. I mean, I suppose the one standard deviation up from the mean, so it's actually significantly higher. So that means it's going to be a clockwise wind. This is absolutely insane. So a westerly wind blows from the west, northeasterly blows from the northeast, and then easterly blows from the east. So as long as I've got those the right way around. So I think I've got no idea what I'm doing, I'll be honest. But if I had to put money on it, I would say that Heathrow is northeast, and then Herne is east, and then this Scottish place, I can't pronounce it, Lucas or something, is west. But I have no confidence in that. I wouldn't put a lot of money on it. If you're talking, you're on mute. But
Oh, I'm so sorry. So you're spot on, and so you clearly didn't need to revise the large data set after all.
no, we just need to Google where those towns are. But what an absolutely I just honestly I feel like it's 8 in the morning. I've been doing this so long that I've actually strayed into some weird nightmare where I'm answering questions about the wind. Now, this looks like my kind of question. So,
Oh, hello, good morning. Is this where we dance the tango?
oh my God. Yeah, what was going on in that question? That was insane. God, it is 8:15. I really do need to crack on, actually. But hello, Ali. It's good to hear from you. God, I can't believe you were last year like 12 hours ago. That's mental. I've been sat here the whole time. So let me concentrate. So university magazine about green issues, one about equality, one about sports. Definitely sounds like a university magazine. A student at the college is selected at random. G, E, and S. Okay, got it. The proportion of students in the college who read exactly one of these magazines. Well, that's just the sum of those three there, isn't it? So 0.53, is it? I don't trust any of my arithmetic anymore. Yeah, 0.53. Shouldn't have died myself. Okay, no students read all three magazines. So that means P equals 0. And we know that P of G is 0.25. So that means that is 0.12. Again, just doing a double check it because I don't trust myself at all. Yeah, 0.12. Okay, given that the probability of S given E is 5/12, find the value of R. So the probability that S happens given that E has already happened. Well, we could do this this is S and E over probability of E. So the probability of them both happening is just R, and the probability that E happens is 0.48 plus R, and that is equal to 5/12. So we've got 12 6r minus 5r is equal to 0.48 times 5, which is 2.4. So r is equal to... I don't like this. 2.4 divided by 7. I was really expecting a nice answer there. I'm going to double check this. 12r. What is 5 times 0.4? I probably got that wrong. No, damn it, I didn't. Help me.
Sorry, I'm a little bit behind the stream. What's the answer you've got for R?
Horrible. 12 over 35, like 0.3428, blah, blah, blah. Doesn't look right, does it?
Let's see. Not quite.
Yeah, so let's just... I don't know why this is possibly... Why that could possibly be wrong. Oh, I've done the... This is... Okay, start again there. So this is R. The probability that E happens is 0.05 plus 0.09 is 0.14 plus R. I knew this was going to be a nicer answer, so I'm really hoping this time. So again, we get 12R minus 5R is equal to 5 times 0.14, which I'm not going to bother because this is 7R. When I divide by 7, I'm going to get 5 times... Alex, just seriously, stop trying to do everything in your head. Just use the goddamn calculator because you're going to make so many mistakes and you're going to get annoyed with yourself. So, blah, blah, blah. R is equal to 0.1. So, R is equal to 0.1. Yeah, that looks a lot better, doesn't it? And then T is just 1 minus the sum of all of them. So, 0.36 plus 0.12 plus 0.08 plus 0.05 plus 0.09 plus 0.1 equals 4/5, which means T is 0.2.
Yeah.
Determine whether or not the events S and E dash and G are independent. Ooh, okay. So probability of S and not E. So S happens and E doesn't happen. That's 0.48. Probability of G is 0.25. And the probability of S and not E and G, well, this is S happens, E doesn't happen, and G happens is 0.12. Yes, so they are independent because when you multiply those, you get that. And events are independent if and only if the probability that they both happen is the product of the probabilities that they happen individually.
Nice.
Okay, so here we go with this is the proper stats question now. The hypothesis test, normal distribution. So the heights of females from a country are normally distributed with mean 166.5 and standard deviation 6.1. Given that 1% of females from this country are shorter than K, find the value of K. Right. So, let's say the heights are normally distributed with mean 166.5 and well, it's variance that you put there, I think, actually, isn't it? So 6.1 squared. Right. So we basically want x such that p of x is 0.01. However, my calculator only does for the standard normal distribution. So if we do k minus 166.5 over sigma, that is the value that we're looking for. And again, my calculator doesn't do inverse normal. So let's do stats, single variable. So what do we think will have a probability that's low like that? Like -1? Oh no, we have to go way lower than that. -2, -2.5, -2.25. So that's a bit, so -2.8, -2.3. Let's say minus, I think this is good enough. So -2.325. So if we multiply that, if we do -2.325 multiplied by 6.1, and then add 166.5, 152.3. Okay, now B, find the proportion of females from this country with heights between 150 and 175. So, again, we're going to do 150 minus 166.5 over 6.1. And we're going to do 175 minus 166.5 over 6.1. So 150, no, let's put it in 150. So this is going to give us our Z values. I think is the correct term. You say Z value, James?
James will be back with coffee shortly.
Oh, okay, fair enough. 175. That's 1.39. So if I do go back into stats mode, single variable, stats. Sorry, what? So P of 1.39 is so P of that is 0.918, and then probability of -2.7. Oof, very low. Don't like that. Because basically what we're doing is we've got the normal distribution, we've got like 175, and we've got 150. I suppose we have said that 1% of people are shorter than that, so we should expect a very small number here. So if I do 0.918, because I want this area here, I take all the area, and then I strip away this area. So I take 0.918 and I subtract 0.003 to give me 0.915.
Yeah.
Awesome. Fantastic. Wow. I'm actually holding my own against this statistics paper. I thought this would be the confrontation of the ages.
Yes, this was supposed to be your Waterloo, wasn't it?
Oh, yeah, it really was. But it's going all right. I even managed to blunder my way through that that wind direction question, and we've danced the tango on the way as well. So what on earth is going on?
I never liked learning statistics, but they were always okay.
Yeah. So find the probability that her height is more than 160. So a female from this country is chosen at random and chose from those with heights between 150 and 175. Okay, so it's the probability that the height is more than 160 given that the other thing that has already happened. visualize this one. So 160 is about there. So we want this. So I think we're going to find that, and then we're going to multiply by the previous, and then we're going to divide by the previous answer. So let's do 1 minus the probability that h is less than 160. So that's an h, by the way. Oh god, so 160 subtract 166.5, all divided by 6.1. So minus that. Divided by 0.915. Is the answer 0.936?
No.
Oh, so conditional probability, we have to do h is greater than 160, and it's between the previous case, all divided by the probability of the previous case. So I need to do probability that h. I'm very scared about the time. This is taking me so long. Oh god, I'm not gonna be able to do it. I can't do this. It's taking ages. I'm quickly losing confidence here. I can't do it. I'm just getting everything wrong.
You're on the right track. So it's like you were saying. It's classic conditional probability.
So I need to do 160, 175. I need that, and then divide by the previous answer.
Yes.
Friggin' hell, it's just going on and on and on. I can't handle it anymore. It's just like...
There's one more after this. I feel a bit like Harry Potter in that scene where he's making Dumbledore drink the stuff from the Horcrux.
Oh my god.
There's only
Just
one
more.
You got to keep drinking, Professor. That's only one more statistics question.
So 175 take 1665. If I had a bloody calculator that could actually do this without having to do this every friggin' time, it would be so much easier. But because nowadays you just type in your mean, your standard deviation, it does it all for you.
Well, listen, if you want to open Wolfram, I don't think anyone's going to hold it against you.
I wouldn't have Wolfram. 1.39. So mean is there. So let's do P 1.39 and we'll subtract P of 1 minus 1.066, and that will give us this slice, and then we'll divide by 0.915, yeah?
Yep.
Divided by 0.915. Please tell me it's 0.846.
Yeah.
Thank God. Okay.
Great victory.
And it's not even the end of the question. Okay, the heights of the females from a different country. Okay, this is a hypothesis test. start a new piece of paper here. Heights of females from a different country are normally distributed with standard deviation 7.4. Mia believes that the mean height of females from this country is less than that. Okay, so H0, the mu of this country is in fact equal to that, but she thinks that it's less. Mia takes a random sample of 50, so it's normal 50 with 7.4. Ooh, is it? We divide by 50 here, don't we? Because it's a sample. I think that's what we do. A 50 student and finds the mean to be 164.6. So we're basically saying, what is the probability that the mean would be that under the assumption that the mean is actually that? That's the way I think about this. So if it is the case, so if it's the case that it is 166.5, then we can calculate the probability of this by doing this nonsense again over 7.4. I'm sure you do this because it's a sample. So the standard deviation is 7.4 over 50. And that gives us our z value. Now, comp 164.6 take 166.5 over
7.4 over root 50 squared, right?
Oh, sorry, it's root 50. Yeah, that's it. You divide by the I knew there was something funky about that. Thanks, well spotted.
Yeah, no worries.
The statistics is really paying off there, James. Minus 1.816. So if we do p of that, which I know is so 3, 1, blah blah blah, minus 1.816, we get 0.03, which I think is less than 0.05, so it is significant. So reject H0.
Smooth.
That's how I think about it. I don't know if that's the right way to think about it, but I think if you assume that the mean is that, what is the probability that we roll a mean of that in our sample? And the probability of rolling a mean of that is 3%, which is pretty significant.
Spot on.
It took me a long time to really get that. Right, well, this looks fascinating, I have to say. What on earth is this doing? So, a random variable x has the following probability distribution. A and B are integers with a less than b less than c. I think I'm going to like this question. All the probabilities are greater than 0. Well, I think that's a given anyway, isn't it, right? Probabilities are greater than 0. Find the value of A, the value of B, the value of C. Well, I'll put money on it. I bet it's 2, 3, and 6. I'll put money on that. Yeah, I can see it. I can see what's going to happen, because the only thing we can do is we can add them together, and then you collapse them into log ABC and set it equal to 1. That's the only thing you can reasonably do, and then therefore you get ABC is equal to 36. Now, I suppose we could have 1. We need to just be careful here. Can this be 1? Well, log base 36 of 1 is 0. And all the probabilities are greater than 0. That's why it tells us that they're greater than 0. So we can't have a 1. Now, 36 is 2 squared times 3 squared. So, could there be anything else? Could we have a 4? And then a 9? No. It's that. And then B. Find the probability that x1 equals... the independent random variables x1 and x2 have the same distribution as x, right? So they all follow this relationship. So the probability that they're the same Well, you have to, yeah, so it's just going to be log 36, because you could get AA, you could get BB, you could get CC, so it's going to be log 30 base 36 of 2 times log base, let's just say squared, and all the rest. So let's just do it on the calculator. Get back in proper mode. Log 36 of 2. Sorry, James, I'm being disparaging towards statistics by referring to it as proper mode. Log base of 3 squared. Log. So either I've made a huge goof with that first question. You didn't say it was right, but you also didn't say it was wrong.
You're spot on here. Sorry.
So 0.381.
Yeah, spot on. And it's what a great question. It's almost like a Key Stage 3 Sats question, but on with the material from this. It's like really nice reasoning kind of question.
Yeah, that was good actually. This was yeah. Yeah, well, it was that's a perfect way of describing it actually, because this was like a bit of pure vibes, where it was just logarithms, and God, my brain just did that. I don't know how I just saw it, and I thought it's gonna be that.
From the book.
It's one from the book.
All right, are you taking a brief break now?
Well, a very brief break, but I need to come back soon because
Yeah, I get that.
we've got how long? 3.5 hours.
3.5 hours, yeah.
Now, I've got 2 GCSE papers, which are old school GCSE, and we know that they are an absolute joke. So, we've got those, and we do have a further IGCSE paper, which apparently takes 2.5 hours. But it is IGCSE, so I don't know why it's 2.5 hours.
We've got 3 papers left, right?
Nope. 4.
Oh yeah, 21, 22, 23, 24. Yeah, okay.
Is that right?
Yeah.
We just did yeah.
We just did number 20.
Yeah. So I'm looking through this.
Okay.
There's only 11 questions. I mean, we're gonna have to do it, and then we'll blitz the GCSE, and then I've got the UKMT paper, which is scheduled to take an hour, but we can always cut that short if we need to, I suppose. So this is another IGCSE paper. I'm just gonna grab a little bit of breakfast, I guess. Is what you would call it. I'll be back in just about. I really don't want to break too long here because I'm anxious about the time. I'll be back in a sec.
All right, see you in a minute. I love all the positive comments, guys. It's massively appreciated. He is reading chat, so he might not respond to everything, but he's certainly reading it. So thank you, Tahara, Casper, Emily, Kieran for the encouragement. Runstar Homer, holy ravioli indeed. Holy ravioli indeed. So yeah. So Ollie, how do you feel about hypothesis testing?
I sort of think it's a good thing. I haven't done it in a while, but
I'm not sure it is a good thing anymore.
What's wrong with hypothesis testing?
I don't know. I feel like it's very dependent on. It's just so dependent on the assumptions in practice, I think, and also, you end up with like multiple comparisons. People never in practice. People never get multiple comparisons right, or rarely. I don't know. I'm not a big fan.
I mean, it has like a use case, but
yeah. I mean, if you're doing particle physics, or you're, I mean, I guess if you're doing a really classic clinical trial, but I mean, yeah, I don't know. It's a lot better to look at the data. Look,
sure.
Let's draw some, QQ plots and all that kind of thing.
Absolutely.
yeah, I feel like the most sane stats course we did at Manchester was Practical Statistics 1, which had all the kind of non-parametric methods and stuff. And even in that course, he was saying, yeah, some of these, he did have Kolmogorov-Smirnov in there, which is like, again, I don't like that. So it is like, well, it does make my heart sink a little bit in that stats paper where they've got really small samples and they're saying, yeah, let's do all these hypothesis tests, and oh, isn't it a good laugh? I'm not.
Yeah, I mean,
It's not for me.
I
It's
can
not for
give
me.
you a vague idea that may or may not be true at the end of the day.
Yeah, no, I'm not keen. But yeah, okay. How and the so for people, we should do the little blurb about people who are just joining us. People who are just joining us. We are about to do paper 21 out of 24. We are at nearly 21 hours in, so we're pretty pressed for time at this point. And I think what we're going to do is we're going to do 2 more GCSE papers, old spec, pretty straightforward, and this IGCSE paper. And then right at the end, as a special treat, the UK Mathematics Trust are kindly letting us use one of their maths challenge papers. The UKMT is a charity that kind of promotes maths education, really. And the maths challenge is a special paper which kind of gives a different kind of side to maths than you get in the GCSE papers. And just as a reminder for international folks, GCSE papers, kids take these when they are 16. And in the UK, maths is compulsory to 16, so almost everybody has to take a GCSE paper. It's optional to 18, so people only take A-level maths if they're kind of looking to go to university usually and do some kind of numerate subject. But anyway, I can see Alex is back, so I think I'll stop blathering, and we're about to get in to an IGCSE paper, International Specification of GCSE.
I think you missed your calling, James, as like a low key radio presenter. And here's Alex Villas again. I just want to tell you, good luck. We're all counting on you. What did I say? He bloody loves that phrase.
Yeah. So Kieran, I think we did one further maths paper
Yeah, we did.
earlier
Yeah,
in the evening.
yeah, and it took me about 3 hours as well.
Oh goodness. Okay, I did wonder.
It was tough.
So
They're hard papers. There's no two ways about it.
so while you're cracking on with the first few of this, we'll do a bit more chat and banter because I reckon these first few questions are not going to be that interesting.
Well, you say that.
So Charles Dudley. So GCSE, so the curriculum in the UK is structured a bit differently. So I know in the US, it's like there's like Algebra 1, Algebra 2, and then they have geometry as a separate thing and all this kind of thing. That's not really how it's just maths. And so the GCSE kind of covers algebra up to quadratics, no calculus. It covers sort of basics of trigonometry, kind of up to the cosine rule. It covers kind of classic geometry up to circle theorems. It covers statistics up to mean, median, and mode, but not including the standard deviation. But it does include histograms and the commutative distribution function. And it also covers kind of transformations, transformations of shapes in 2D, volume, surface area, scale factors, that kind of thing. Yeah. So I think Kieran's right. Like the most challenging parts are the trig and the algebra.
Oh,
So
we've got some matrices here, guys. So the first few questions weren't going to be interesting. What's going on here? Are you seeing this?
I do love a good matrix.
Well, so do I, Ollie. So do I. It caught me by surprise, actually. Right, so a bit of matrix multiplication. So negative 12 plus 4 is minus 8. Minus 3 plus 2 is minus 1. 20 subtract 6 is 14. And 5 subtract 3 is 2. So that's AB. So then part B, we're saying that AB subtract C. So if we do that and then subtract C, we get minus 12 minus 8. 20, and then 12, and we're saying that that is some multiple of minus 3, minus 2, 5, 3. I think lambda is 4, yeah? Well, that was interesting.
Yeah, and I was going to say, like, with the GCSE, the I stands for international, and this is a spec that really has been developed for exam boards to sell to international schools.
Yeah.
And the main difference used to be that it had functions in, but clearly it's got matrices as well.
Well, it's got a bit of calculus in as well.
Oh, does it?
Yeah.
Yeah.
So only basic, but it is there, and an absolutely deadly circle theorems question, which I said if we've got time, I'll show you that question. I was stuck on this for, it must have been about half an hour, and yeah, I just couldn't. And again, as we said, usually circle theorems are like my bread and butter. Right. So it's using this funky N of notation. Who was it that used to do it? I think it was Yuri at UOM who used to write it like that. Oh no, he used that notation, hash A, for like the cardinality of A, which is just about standard enough, I would say. So 8 into... God, we got a lot of stuff going on here. Right. So this is 8 subtract x. This is 7 subtract x. This is 13 subtract x. God, this is messy actually. I was looking forward to this one because I love a good Venn diagram, but take 8, take 13 is 16. And then that x will cancel with that one, and that x will cancel with that one. So I think we actually just get 16 out here. Yeah, 16 plus 8 plus 13 is the 37, and then yeah, that just does boil down to one x there. And that will happen for all of them actually, so this is a little bit nice. So 8 plus 7, 28, subtract that, I think this is going to be 13. Just check that, yeah, because we pick up two negative, yeah, the x's die there, so we basically pick up, yeah, I'm happy with that. And then we got 20, so that is 9. Using this information, complete the Venn diagram to show the number of elements in each appropriate set. Using your Venn diagram, write an equation in x. Hence, find the value of x. So, we know that they all have to add up to 60. So, 16 plus 13 plus 9 plus 4 plus 7 plus 13 plus 8 is 70. And then how many x's do we have? We've got negative 2x is equal to 60, so I think x is 5. What do we think about that? Don't think you got the mark schemes for the GCSE, do you? So I just have to trust that I've done it right.
Well, that or we could pay attention.
Well, yeah, that would be good as well, actually. But no, it's fine. No, I do really appreciate you keeping everyone entertained in the chat and everything, because I just can't right now. So the curve C has that, where that, and it passes through that. Write down an equation in A and B. So y equals ax squared plus b. -1 is equal to a plus b. Given that c also passes through the point with that, write down a second equation in a and b. 23 is equal to 9a plus b. Solve. I think this has been the most popular thing I've done. Well, popular is maybe not the right word, but this is the most like thing that I've done all day, is solve simultaneous equations. There's been an uncanny amount of them that have popped up. So -32 is equal to 8b. Therefore, b is equal to -4. Just double checking everything on this bloody calculator because a take 4 is equal to -1. Therefore, a is 3. Let's just double check that that works with that one. So if I take 9 3s and take 4, I do indeed get 23. So I'm happy that that's the answer. Boom, boom. Using your values of a and b, write down the range of the function. So we've got f of x is equal to 3x squared subtract 4. So it's from -4 upwards, right? -4 to infinity. Let's write it like that. Because the lowest that that could possibly be is 0. And again with the silence. Very unnerving.
Ols, are you still with us?
I'm still with you.
Okay.
I am 29 seconds behind.
Oh right. Oh, sorry. It's my bad. I shouldn't place the expectation that yeah, 45, 55. I'm sure some people in the chat will correct me if I'm wrong. Anyway, some incredibly astute commenters.
Yeah, some of the commenters have been amazing this year. Really great.
25 times 30, 750. 33 times 45. Well, yeah, because it's usually just my mates who are watching, who, I don't mean them any disrespect, but they're not mathematicians. So 1125. Okay, so an estimate for me. I hate these. It's just snooze fest. So that's the sum divided by 100. That's an estimate of the mean for 46.2. Does that look right? Yeah, I can believe that. Seems like it's weighted a bit. I would have thought it was a bit higher than that actually, but let's not worry about it. Find the probability that the speed recorded for this. Oh, I have a bad habit of like not reading this first sentence. The speed limit for vehicles at this point on the road is 50 k's. One of these 100 vehicles is chosen at random. Find the probability that the speed recorded for this vehicle is greater than the speed of this the speed limit. So 50 and up is 37 out of 100. I think that's it. That's fine. Emily, you are incredibly helpful. And I didn't mean for what I said to be a disparaging thing. I genuinely probably wouldn't have had the confidence to put that video out, my most recent video just describing my mental health history. I probably wouldn't have had the confidence to put that out without your help with that script. So I do really appreciate it. Emily is it a psychologist? I always get it the wrong way around. I think you're a psychologist, rather than a psychiatrist, which I know is like not the right thing to say. Oh god, we're doing a histogram as well as all of this nonsense. So.
Yay! Yes.
Yay!
Oh, shut up, James. No one cares. So the class width is 20, 20, 10, 10, 30. It's just an absolute drag. Who cares? Right, so the scale has been determined by this one. I'm having a brain fart here. 20 times that is equal to 25. So 25 divided by 20 is 1.25. So that is 1. That's the scale. 1, 2, 3, 4. Let's do 2. So let's do 5 divided by 20. That's 0.25 there. 33 divided by 10 is 3.3. What? So we're going to 1, 2, 3, 4 there. So 3.3. One, 2, 3, and a bit. It's going to be like there. So something about there. And that's only got a width of 10. Oh, and then 2.2. And then half. All right, yeah, you happy now, James?
Immeasurably.
I'll find a way to measure it. Just going to write this one actually. Oh, I can see this big. You can see that big circles question through the paper there. I don't know if you can see that. Simplify fully. Well, we've got the old. The old what? What is that? X minus 7 and plus 4. Nope, minus 4 plus 7. And then the bottom one is x squared plus 6x plus 9 minus 16.
Oh, nice.
Is minus
So, Kieran,
7.
you're actually touching on a good point there. So we should just say as well, as a health warning, any sort of actual school students watching this, don't fill in your exams in this way. Use a pencil and ruler, show you're working.
Oh, yeah.
If you answer them like Alex, you probably won't get full credit.
But yeah, that's an understatement. I did say this at the start of the stream, and I'm sure you were all there.
Yeah.
18 hours ago. Yeah, I did make those points, but obviously, people join at different times. Yeah, if you are a student, absolutely categorically do not do. This is I'm demonstrating the exact opposite way to answer exams, which is just to rush through them. So, I don't think it was a difference of 2 squares, was it? Oh, it was. Interesting. Didn't spot that. Yeah, well spotted. I like that. So, this looks like the kind of circle questions I can get into. So, ABCDE is a circle with center O and diameter AD. And then bunch of info. Alright, so angle AEC it wants. Well, 80, because it's a cyclic quadrilateral. And opposite angles in a cyclic quadrilateral add up to 180. And then AEQ, I'm going to label that as 80 because I'm completely going to need it later. That's just 62 because it's opposite the alternate segment theorem. And then giving reasons, show that OAE equals, so O to A to E is 28. Right. That whole angle there is 38. Because we've got the angles in a triangle, or equivalently the angles in a straight line. Just wondering how we're going to get our hands on 28. Ah. No. Nope. 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 Gosh, I've never struggled so hard with circle theorems. This is ridiculous. Do we get any more information that I've not used?
Can you move your hand?
This is usually like what I'm really, really good at. I've just lost all confidence in myself. Anyone watching this is just gonna think I'm a fucking idiot.
They absolutely are not going to think that. CAP, we know.
Oh, are we given that?
No. Oh God, I'm an idiot. Sorry. No, we don't. No, we know AEC, and we know.
Don't. Yeah.
Yeah, we know PAE. So I think we know CAP.
No, I'm not seeing it.
Okay.
We don't actually know that. That's what we're trying to show.
We're doing part C. We're looking for EPA, yeah?
Nope.
Oh, sorry.
I think I need to like. Need to draw some more lines in here. So what can we? I think I'm looking at this. I'm looking at this. OE. Now what can we? Because this is 124, and then this is a nice. Yeah, this is it, isn't it? If we do 180, take 124, and then divide it by 2, 28. There you go. Because that's an isosceles triangle. So that must be 28, and that must be 28.
Nailed it.
Yeah, not easy because you have to start drawing clever constructions and stuff like that. Sure, there's other ways of doing it. Right, so find the size in degrees of EPA. So now EPA. So this is the thing that we are interested in. Right. Oh, we know that. Yeah. So I'm going to change colors just to make this diagram clearer, mostly for my own benefit. Actually, that is a radius, which means this here is a right angle. This here is 180 subtract 124, which is 56, which means add that to 90, take it away from 180, we get 34.
Sweet.
Nice.
So
Again,
just read up.
like I said, usually it's like the thing that I'm best at.
Well, you have been doing it for 20 hours, which is the point that people are making in the chat. So I will just read some of these out. Angelo says, "You can do this." Emily Haythornthwaite definitely does not think you're an idiot. And Casper's saying, 21 hours, brain farts are fine, etc., etc. So the consensus is clear.
All right. Proof by consensus, is it?
Yeah, absolutely.
Are you gonna do it? Are you gonna do a hypothesis test? Is it a significant reason to believe that I'm not an idiot? 80 times 192.
Thank you very much to Bard for the £10 as well.
Yes, awesome. Also, we should thank you to You're Still At It, You Mad Lad. I wonder who that was. Is it a Johnny, perhaps? But thank you very much. Right, the manager of a golf shop. Oh, this is your kind of question, James. Bought X identical golf balls at a total cost of that to sell during a tournament. Write down an expression in terms of X for the price the manager paid for the for one golf ball. So 480 divided by X. Easy enough. Okay, the selling price of a golf ball was such that the profit made when the golf ball was sold was $2.50. Find as a single fraction an expression in the terms of X for the selling price in dollars of one golf ball. So we bought it for... We bought one golf ball for that much, didn't we? And then sold for 480 over X plus 2.5. Yeah, so it's that actually, that's just it. D. At the end of the tournament, 16 of the golf balls had not been sold, and the total selling price is that. Write down an equation for X. So we sold that. We sold them at that price, and we sold 480. So we sold 464 of them at that price, and we made $544. Show that your equation in part D simplifies to that. Right. Ooh, nope, I don't like this. Nope, something very wrong here because we're not going to get a quadratic. At the end of the tournament, 16 goals were not being sold. So how is this not correct? I'm at a loss here because I've taken... It must be that this isn't correct. But one golf ball... I also should convert that to a single fraction. Oh, maybe when I do that. So that 480 over X. So this is 480 plus 2.5x over X. Even so, it's not going to create a quadratic, which is a big problem. I'm not seeing it, guys. I'm not seeing it. Because you paid that much. selling price was such that the profit made was that. So he needs to sell it for 480 over X, what he paid for it, and then still gain £2.50. I'm convinced that this is right, but it can't be. You got any ideas? I'm struggling here.
Yeah, I'm looking through it.
Just so sick of this now. Anyone in the chat? I'm at a total loss. Total loss. I need to have an X up here, but that isn't right.
Ugh. Not 464 golf balls sold, but X minus 16.
What? No, we saw.
No, X is the selling price. Yeah, no. So yeah, guys, 464 is like he bought 400 and it's X identical golf balls at a total cost of 480. So how are you using? Yeah. So the 16 golf balls that have not been sold, it's not like 480 minus 16, because the 480 is a dollar value. Yeah, so it's a different expression that's needed for that 464, basically.
Oh yeah. Oh God. Yeah.
God, I can't believe that took me so long to see. Thank you to Tony, IP Tony, Slice Music, and Nordlock.
So X is the number of balls. Yeah, I think I muddled these up in my head. I thought 480 was the number of balls, and X was the like the cost. So X is the number of balls.
No, X is the selling price.
No, X is the number of balls. He bought X identical golf balls.
Oh my God, I'm so sorry. I'm an idiot. Yes.
Oh my
He
God.
bought X identical golf balls. Yes. So I'm such an idiot. I'm so
No, don't. I mean, you're talking to B, who's been staring at the same frigging question for half an hour now.
We can do it.
So that I'm still happy with that. Question B: find as a single fraction an expression in terms of X for the selling price. So I'm still convinced that is still 480 over X plus 2.5.
Yeah, I think that's right.
Which is that it is one single fraction. Now this using all the information. So at the end of the tournament, we have not sold 16, so it's that, and we multiply by the cost. So this is what we're selling them for, and we make 544. So do we think it's that x minus 16 times 480 plus 2.5x over x equals 554?
Yeah. So it's X minus 16. Yeah.
Now,
Thanks, guys.
Thank you. Yeah, thanks very much. I just I'm not in the right frame of mind anymore. I've lost it. I was flying, and all of a sudden, it's golf, which is just a nightmare. Right, show that it simplifies to that. So x minus 16, 480 plus 2.5 x is equal to 544 x. 2.5 x squared. Right, let's calculate this. So minus 16 times 2.5 plus 480, 440, plus 440x, and then 16 times 480, minus 7680 is equal to 544x. So let's start a new piece of paper. I love this because like we actually factorized, well, we expanded. We know the factorization of the thing that it ends up as, which is really cool. There's a nice kind of through line in this question. So if I do 440 subtract 544, I get 104. That's good because we need 208 at some point. So 2.5 x squared subtract 104x subtract that horrible thing, and then times the whole thing by 2. 5x squared take 208x. Yeah, there it is. 15360 is equal to 0, which is the exact same thing as we had before. So we know how it factorizes. So using part A or otherwise, and I'm going to opt not to do the otherwise. So we know that this becomes 5x plus 192, x minus 80. Reject kind of a negative amount of golf balls, so x is equal to 80. Friggin' hell, it's not even hard. I just stalled.
Well, me and Ollie couldn't see it either, so you know.
Yeah,
I know, but
converting from the question to the algebra quickly is not always easy.
yeah, but I think like you're looking at my answer, assuming I've done some certain parts correct that I haven't. So yeah.
I'll be casting a more critical eye.
Yeah, I think so. I think that's probably best. Okay, I think this is going to be identical to the question that we did earlier, but it just looks like it's been scaffolded a bit. So OAB is triangle. Okay, we've got OA, which is 2A. We've got AB, which is B. Right. Oh, I just yawned. I just yawned for the first time. I'm getting tired. So the point E is the midpoint of OA. So that's the midpoint. And ABC is a straight line such that AB to BC. Oh, AB to AC is 4 to 5. Oh, just stop it. You don't need to make it so annoying. So AB to AC is equal to 4/5. 5 AB is equal to 4 AC. So this is 5 to 4 actually, isn't it? No. Is that 5 to 4 there?
Should be to go from A to C. Yep.
No, it's wrong. I can't even do this.
Uh,
I can't even do this. AB to AC, 4 to 5. 5AB equals 4AC. If we say that AB is 1, then AC... Why? It just doesn't make sense. How can that be? How can 5 of that equal 4 of that? Because if... So we're saying for every 1 that is, this is 5 quarters, which means this is 1 quarter, which means this is in the ratio 4 to 1. Of course it is. How else could it possibly be anything else, you stupid idiot? Right. So, O to B is 2A plus B. A to C is 5 quarters of B. Lowercase b. E to C is A plus, and then to get from, so we've gone from E to A, and then we need to go from A to C, which is A plus 5 quarters of B. Mixing up my underlines and my arrows, sorry. Oh, so, right, OD is equal to mu OB, where mu is a scalar, I agree. Sorry, Elliot.
Yeah, sorry. Have you got AB as 4?
Yeah.
Yeah, okay, good.
Yeah. So, running on an expression OD in terms of mu A and B, well, OB was 2A plus B, so OD is equal to mu 2A plus B. ED is lambda, yeah, it says I suspected. It's going to be a lot like that question I did before, but this is just, it's just helping you put the pieces together yourself. So, OD, so to get from O to D, you wanted to go A plus ED, which is lambda EC, which is A plus 5 quarters of B. Find the value of lambda and the value of mu. Okay, there we go. There it is. So, from these here, we know that mu 2A plus B is equal to A plus lambda A plus 5 quarters of B. So, 2 mu A plus mu B.
Sorry. I have EC is 9 quarters B. Is that right? Because it's divided by 4 and then times by 5 plus 4.
Sorry, for what? For EC?
Yeah.
Well, no, I was pretty happy with that because it is the ratio 4 to 1.
Yeah, because I also got the same, Ollie, it's AB to AC that's in the ratio 4 to 5.
Yeah, not AB to BC. That was a mistake that I was making because I wanted to say 4 to 5 there.
Okay.
Yeah.
So yeah, so I think we're okay.
But yeah, good, because that's why I got angry at that, because that's just made it unnecessarily complicated. Because it's always in these questions it's AB to BC. Okay, now this is plus 5 lambda over 4, lots of b. Right, so it's time for the old simultaneous equations again. How many of them am I going to do? So mu is equal to 5 lambda over 4. In other words, 4 mu equals 5 lambda. This is telling us that, let's do it that way, 4 mu is equal to 2 plus 2 lambda. And so we can equate 2 plus 2 lambda equals 5 lambda. Therefore, lambda is equal to 2/3. And therefore, mu is equal to 5/4 of that, which is 10 over 12, which is 5/6. So lambda is 2/3. Now let's just check to see if that makes sense. I think lambda was supposed to be less than 1, because we're basically taking, lambda was this one, wasn't it? EC, but then scale it by 2/3. That looks about right. And then mu OD is mu of OB. Yeah, that looks like 5/6 as well. So I think this is fine. Okay, now the area of the triangle OAD is 20 square units. OAD. What? Where's that come from? So the area of that is 20. Find the area of the triangle ADB. OAD is 20. So what's the area? It's this triangle that we're actually wanting to find the area of, given that that is 20. Oh my god. I'll be back in a sec. I need the loo.
See you shortly. So Ollie, I think we've got to be looking at similar triangles here, right? Somehow. And it's gonna be a matter of seeing it from the information that we've got about the sides in terms of vector. I don't know. I feel about as zonked as he is, I think.
I'm also struggling.
Well, we're relying on you for this one.
No.
Okay.
Let's see.
AOB, yeah, that's what. No, AO. How to find the area of AOB?
ADB.
I know. I think Angelo is saying like if you can find AOB. Dear me, that coffee's done nothing. That's a good point, Harriet, although I don't think that's what they're expecting for 2 marks. Okay, find the area of A or B and subtract 1, 2.
Sure. Maths is fun.
Yeah, I think that's it, Nordlock. I think that's what they're expecting, some sort of similarity argument.
Oh, I understand. Yeah, if you can get the if you can compare the size of the vectors, then
Oh yeah.
and they are similar.
2 marks. It's cruel, isn't it? Oh, pencil's coming up O. No, D's in the middle. Pencil's covering up O. Anyway, folks, just a reminder, we're doing this all for charity. Although, yeah. So this is for Mind, UK mental health charity, a really awesome organisation. So thank you very much, folks, for your support of that. It's lovely to have so many people watching this year. This is the 3rd year we've done this, but we've never had such a great audience. So it's really wonderful. So thanks for coming. And yeah, just in the middle of this IGCSE paper, which really is on the home straight. Like, I think once we are done with this, we just have 2 old GCSE papers, which are really pretty straightforward. So if we can get through this, then we're there, I think.
Yeah, if we can get through this. So.
Oh, hello.
Hello. You're right. So this. I got nothing.
So
It's got to be
you could
something
use
to do with
similar
like
triangles.
yeah, it's got to be something to do with similarity. But for 20 mark for 2 marks, what are they expecting it just to drop out again here? So it's not clear. I just don't even feel like I've highlighted the right triangles. ADB. They wanted me to find the area of that.
Can we show that they're similar?
I mean, they don't even look similar. But I, I've got absolutely nothing. The only thing I can think of is to start busting out the cosine rule. Start putting lengths on these. Use the 20 as a kind of scaling thing, but for 20 marks, you're not expected to do that, surely.
I agree. Do we know anything about? Have we got AD?
Yeah.
What is AD?
Well, if we don't have it, we can have it.
Yeah.
I don't think we do actually. There's nothing. There is nothing.
We have.
They're not. I mean, they certainly don't look similar, do they? I mean, they might be.
The diagram is not accurately drawn.
No, I know it. I know it's not accurately drawn, but I'm gonna come back to it because I've got absolutely nothing. Like, not even the slightest. Apart from the cosine rule idea, which is just so stupid because it's like you're not expected to do that for 2 marks. Right. Let's just try and get through this because this is doing my head in. Show that the size of each interior angle of a regular pentagon is right. So if we do 180 times 3 over 5, we get 108. In figure 3, this is a regular pentagon with sides of length 10. The midpoints of ED and yeah. So find the length of AG. So we want to find that, don't we? So we know that is 108. Do we know it's equilateral? No. Jesus. This paper's suddenly come extremely hard. Oh, it's cosine rule. Sorry. So that's 10. Yeah, so, Jesus. Right, let's just try and get through this then. So this is the square root of 10 squared plus 5 squared minus 2 lots of 10 lots of 5 cos 108. 12. 12.5. Find the size of angle GAB, which is that. Sine, let's call it theta. Theta is equal to 5 sine 180, 108 over this thing that we've got on our calculator here. So 5 sine 108 divided by that is 0.38. So shift sign equals 22.38. Let's say 22.4 degrees. And then the area in centimeters squared of triangle GAF. So GAF. So by symmetry, that's also theta. So if we times that by 2, do 108, subtract that, then we get 63.2 degrees. And then by symmetry, this is also x. So half 0.5 times 12.5 times 12.5 sine 63.2 is equal to that. So area is 69.7 centimeters squared. The area of the pentagon is that. The region R consists of the point inside the pentagon but outside triangle gaff. So it's basically, yeah, all of that stuff. So calculate the area of R as a percent. Well, the area is 172. Subtract 69.7. That's the area of region R. As a percentage of that, we just divide by 172, and we get 59.5%. Okay. That's that vectors question. Lost where I'm up to. What question was that? That was 10. Because that was so 10 is the one I've just done. 9 is this vectors one. I'm just set that to one side. Picture bonuses in a moment or two. Question 11 is, where the friggin' hell is it? There. So figure 4 shows a firework, which is made of a circular cone on top of a right circular cylinder. Both radius r. The height of the cylinder is 20. Height of the cone is h. So this is what they call in big H. Write down an expression for big H in terms of h. So we're saying h is equal to small h minus 20. The volume of the cone is v. Write down a formula for v in terms of r and h. So volume of the cone is third pi r squared small h. What? Am I losing my mind, or is it just literally asking me to write down the equation that's stated there? Write down a formula for v in terms of r and h. Am I losing my mind here?
I don't think you are. It's 1 mark.
Yeah, but it's literally there. There's something wrong with that. I don't believe it.
Well, it wants you to sub. Does it not want you to sub h minus 20 or whatever?
No, because it wants it in terms of r and small h. That's what I mean. I think if it wanted it as a big H, I would understand that, but it doesn't say that.
Well, big H is small h minus 20, right? And the area, the volume of the, so V is the volume of the cone. The volume of the cone is 1/3 pi r squared big H, right?
Oh yes, there we go. So I was losing my mind. I knew it. So a third r squared h minus 20. So it's that, isn't it?
Oh god, finally one I can actually help with.
Friggin' hell. I've lost it. I've really lost my mojo in the last hour or so.
But that is understandable.
I don't know what's happened to me. I was like full of energy, and I started this paper, and it was that golf question that did me in. I've never been the same since. Right. Show that the volume is actually that. So I guess we're going to substitute in h equals 32 minus r. So v equals 1/3. We're not going to get anything that looks remotely like that. No, I suppose we will actually. 1/3 r squared 32 minus r minus 20, which is 12 minus r. No. Like I said, not even remotely like that. because I've just there's a pi there, so we need a pi. Like I said, not even remotely the same. There's absolutely nowhere near. They're nowhere near each other. Oh wait, yeah they are. It's pi 12. Yeah, fold the r squared inside. So that's 4r squared subtract r cubed over 3. Yeah, that's right. Friggin' hell, I can't even see like 2 steps ahead anymore. Right, D. For the curve with equation that, complete the following table. I mean, it's just all over the place, this. If you want to find the volume, let me find the volume. Just give me something to work with. 4 equals 4 times that squared, subtract 1/3 of that cubed. On the grid opposite, plot the points from your completed table and join them to form a smooth curve. Absolute bonkers. What is going on here? So 0, 0, 2, 13. 4, what's 128 over 3? 42. 672. In the meantime, is anyone anywhere near close in the chat of doing that vectors question? Because it's ticking over in the back of my head, and I've just got nothing.
Mark scheme. So we're working.
Like I'm not even. Yeah, it's not often that I look at a question and I'm like, just 0. 66. 12 is 0. So it looks something like that. Very, very strange. The volume of the cone is 80 pi. Use your graph to find to one decimal place 2 possible values of r. So many bits of friggin' paper, I can't find anything. So volume is pi 4r squared subtract r cubed over 3. So we want it at 80, not 80 pi, 80. So something around that. So something like 7 and 9.2. Something around that. Using the 2 values of r found in F, the difference between the volumes of the 2 fireworks is D. Find the value of d to the nearest 100. So, the volume of the cylinder is pi r squared times 20. So the two volumes, they both gave 80. So for 7 squared, pi times 7 squared times 20. No, pi times 7 squared times 20, subtract 80. That area is absolutely massive. That volume even. About 3,000. And about 5,000. That one was wrong. So those are the two approximate values of d. Right, it's just that vectors question now. And I've
Okay.
put me out of my misery.
So it's we can take the value of mu, and it's basically a comparison between the area of 20, which is the whole OAD, which is OAD over the area of ADB is equal to mu over 1 minus mu. Does that make sense?
No, not at all.
Is it just to do with like the proportion?
Yeah, so I think the piece that we're missing is how do we assert that they're similar?
Yeah, because for me, you can't just say it.
Because as soon as we agree that they're similar, we can use mu to figure out the answer. I mean, if we have a lot of sides here, right? Because we got AB, we got OA, and we got OB and OD. So, and DB really. So the only side that we don't have is AD. If we could write down the expressions of all the 6 sides that are under consideration, can we use that to establish that they're similar? The two triangles?
This is stupid.
Yeah.
This is not worth 2 marks.
No.
No, I still don't agree with it. I don't even care if it's in the mark scheme. This isn't right.
Okay. Well, yeah.
Sorry, I'm getting really cranky about this because this is just ridiculous.
I mean, I think Y Wong has got the same idea that we've got.
I don't believe that is what it says.
Yeah, I mean, it doesn't justify the similarity. That's the weird thing about it. Listen, let's perhaps put a pin in this one.
I just don't get it. And a total loss with it.
With the base OD and DB, the height is the same. So just compare the bases. That's what Andreas Torser is saying.
Not following. Base OD. So he's saying OD times the height there. And DB times the height. Is that what he's saying?
Mm.
Someone's phone's buzzing.
Yeah, it's me. I'm sorry.
OB is 2A plus B, which has a length of root 5. So are we saying root 5 times the height is 20? Is that what we're trying to say? Well, because we're not even... Because these are basis vectors, but... I don't really know if this works. And then dB, what was dB? What was dB?
Thank you, Zoomies, for the £10, and thank you to Ross and Rosen for the £20.
That's Rasheen. Yeah, thanks very much, guys. Really appreciate it. Thank you. I know I'm getting very grumpy and very cranky and very irritable, and this is absolutely destroying all of the last shred of confidence I ever have that I could ever do this, but I cannot figure this out.
Sorry, I just spotted there were a couple of more. Thank you, Chadwick and Marv, for the £10 as well.
Yeah, huge thank you to Chadwick and Marv. Thank you very much. We can't calculate the length of any of these sides because we don't know like what A and B are. Like they're just kind of random vectors, aren't they? Am I talking a different language to everybody else? Do you know what I mean? Like,
I don't quite. I don't quite get why they are similar.
well, even without the similarity, using this approach.
Well, they have the same height with a different base. So half BH and
Yeah.
B1 and B2 are proportional. So does it not?
Oh, I see.
And we know the proportionality between B1 and B2.
Yeah, okay, yeah.
Which, to be honest, is one of those things that once you realise it, seems really obvious, but
No,
actually it is not obvious at all.
It isn't even obvious. This is what's annoying me. I want it to be obvious. I want it to click. I want it to be, oh yeah, of course that's how you get your 2 marks. But it isn't.
No, it's really not. It's cruel.
Where is OB on here? 2A plus B and OD is that. So what is DB?
Can you put one in terms of the other?
Hold on. Oh, for God's sake! I'm absolutely lost.
Do you have the calculation for mu still?
Yeah, it's up here. I'm just not seeing how to use it. So mu, are we saying is a... Right, so we're saying that OD is mu of OB. So we're saying that the area of that big triangle is 5/6. So area of the big triangle is 5/6 of the... So triangle OAD is 5/6 of triangle OAB. And we know that that is 20. So 20 times 6 divided by 5. So we're saying the big triangle is 24. So are we saying that the other triangle has an area of 4? Is that what we're saying?
I think that,
That's
yeah,
what we're
that's right.
saying.
Right, okay, I get it.
Boy, oh boy. The thrill of maths.
Thrill. My God. Well, for saying that it had us 3 stumped, and it had the chat, because I saw a lot of things in the chat there that I actually don't know if I particularly agree with, but you know, it really did stump us there.
It did. Yeah, Dave, I think that's the way of saying it. The triangle's altitude is in common.
Yeah.
Yeah.
That was the right way. That's the
key insight.
that's
Yeah.
the way that made it click for me.
Oh, gosh.
So
Amazing.
right.
Well, I'd love to be a teacher who has to teach that. Crikey, blimey.
Unbelievable.
Well, anyway, on to the next one.
On to the next one. Right,
And this time, it's old GCSE, right?
it's all GCSE. So
Oh, we could do these in our sleep.
wait, you say that. Now, this is actually a nice surprise here, because I said at the start that these are all exam papers that I've never actually seen in full before, which wasn't strictly speaking true, because these are the exam papers that I actually did as a GCSE student all the way back in 2008. So these are literally the exams I did for my GCSEs. So I think it'll be really interesting to see what's in here. The only question I remember is got something to do with similarity of 3D shapes, and I was trying to explain it to my mate on the way home, and he didn't get it. And looking back, very clearly was trying to get me to shut up because he didn't get the question right, and I kept trying to explain it to him, and he didn't want to think about the fact that he didn't get the question right. So this is I bet I don't remember a single other thing about it. So I'm going to go onto the green pen. Recommended time 1 hour 45 minutes. We've got to do it in much less than that. Okay, so this is non-calculator as well, actually.
Yeah, I'm going to check out, but I'm going to come back for the end.
Yeah, so. Okay, no worries.
See you later on.
Yeah, thanks a lot, James. See you later. Right, okay, we really just need to focus here and get through these as quickly as possible. So, if I can finish by 11, it's fine. It doesn't really matter if I don't, but there's something I want to do for the last hour. So, Jacob makes 24 pancakes. So we need to times by everything by 3, so 900 mils of milk. So it's 12, so we need to times everything by 1.5, so that's 180 grams of flour. What did I have? I had my draw stack. Certainly don't remember doing that question. Oh god, I've just seen a stem and leaf diagram. I can't believe that's on there. So part-time job, £5.40 per hour, 24 hours. So 24 times £5.40. Oh god, I wish I could use a calculator. So that's, I wonder if I can do it in a clever sort of way. That's 12 times 10.8, so that's 108 plus another 2160. So that's 1, 1, 2, 9, 60. Doesn't feel right.
Looks good.
Looks good. Okay. So here are the ages. Oh God, I can't believe we've got a stem and leaf on here. So 35, 23. So 23 looks like the smallest. So 23, 27, 30. Oh, there's a 28 there as well. 31, 34, 35, 36, 40, 1, 2, 4, 5, 5, and then 50, 0, 2, 3. The key is that e.g. 2, 3 equals 23. Absolutely bizarre that we used to teach that. Okay, using the information. Oh, I remember these sorts. You don't get any of these anymore. So we obviously times that by 10. We've divided that by 10. And now, so 163.2 divided by 4.8 equals 34. If we times by 1/10, we need to times that by, so that's 3.4. Three-dimensional grid. Write down the letter with the coordinates 2, 1, 0 is S. Coordinates of point P are 2, 1, minus 3. This rule is used to work out the total cost in pounds for hiring a carpet cleaner. So you take n, you multiply by 4, and you add 6. So n is 3 in this case. Write down an expression. Oh, 4n plus 6. Kind of answered the previous question in there. Okay. Surface area. So area of that triangle there is 6. We've got 2 of those. Area of the slope is 35. Area of the base is 28. Area of the back is 21. So that's 49. 12 plus 35 plus 49. So that's 47 plus 49, which is 100 less 3, 4, which is 96. Work out an estimate for that. 300 times 10 divided by 0.5 is equal to 3,000 divided by 0.5, which equals 6,000. Here's a four-sided spinner. Work out the probability 0.4. Yep, 1, 2, 3, 4. We had it easy, Ollie. So 20 PQ d to the power 4, 12a minus 28. Expand and simplify that. 7n plus 9. T cubed m squared. In the space below, use a ruler and compasses to construct an equilateral triangle. Ooh, interesting. So you must show all the construction lines. So if we take that and we take that, then this will yield a equilateral triangle because that is equidistant to that. Okay, minus 2 is less than or equal to x and is less than 3. So x could be minus 2, minus 1, 0, 1, or 2. Write down the reciprocal of 4. That is a quarter. Work that out. So that is 14 over 5. Subtract 4 plus 3 is 7 over 4. which is equal to 56 subtract 35 over 20, which is 21 over 20, which if you prefer is 1 over 1 and a 20th. Explain why, because 4 and a third is equal to 4.3 recurring, not 4.3 exactly. Okay, so rotate triangle P 180 degrees about minus 1, 1. So da-da, 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 like that. Label the new triangle A. Translate that by 6 minus 1. 1, 2, 3, 4, 5. Oh, triangle P. 1, 2, 3, 4, 5, 6. Doop. Ba-doop. Ba-doop. And we'll label that triangle B. Reflect Q in the line y equals x. So 1, 2, 3, 4, 5. So if you go 1, 2, 3, 4, 5, 2 across and up like that, and label the new triangle C. There we go. So 3x squared minus 5xy. Factorize that. Oh, I remember this question. This was one of the questions I couldn't do. I remember I turned round, I was infuriated. I just had a brain fart. I couldn't remember what the difference of two squares was. Oops. Yep, someone's just pointed out. Yeah, I was supposed to translate that down by 1 as well. Apologies. So it's that one. It's a good job I did it in pencil, isn't it? B. Yeah, I remember that question because I couldn't work it out in the exam. I just kind of missed the difference of two squares thing. And the first thing I did when they collected all the papers, I turned around and I asked the guy, "How the hell did you factorize 15bx squared minus 36?" And then he told me the answer, and I was like, instantly I was kicking myself. So lower quartile 10, and then the median is 30, and the maximum is 55. I will make mistakes, guys, so just a heads up on that, because I'm really trying to get through these as quickly as possible. Okay, use the information in the table to complete the box plot. Use the information in the box plot to complete the table. That's fine. Write 6.4 times 10 to the 4 as an ordinary number. So 6, 4, and a bunch of zeros. 1, 2, 3, 4. Write that in standard form. 3.9 times 10 to the power of 1, 2, 3. And write that in standard form. Well, it's going to be 2.5 times 10 to the 6. It goes down because it donates one of its tens into there. Okay, the dreaded circle theorems question. So x is 140, angles at the center equals twice the angle at the circumference. Work out the size of angle y. Oh yeah, cyclic quadrilateral, so 110, because opposite angles in a cyclic quadrilateral add up to 180 degrees. Yeah, ordinary number just means a number that's not in standard form. Okay, 3x is equal to 9, therefore x is equal to 3, therefore this is equal to 9, therefore y is equal to 2. Let's just check it with that top one. 2 times 3 is 6, minus 2. Subtract 6 is 0, 3 plus 6 is 9. Yeah, so x is 3, y equals negative 2. So x is equal to 2. So 2 squared is 4. Take 8 plus 2. Looks like negative 2 to me. and then by symmetry, we know those because a parabola is symmetric about its minimum point or maximum point. So 2 minus 2 minus 1 2 7. Okay, we'll try and draw this smoothly as possible. And then up there as well. Nice parabola. Only one true parabola. Okay, 0.2, 0.4, 0.4. Work out the probability that both will pass. So that's 0.8 times 0.6 is 0.48. Work out the probability that only one of them will pass. So it could be pass, fail, which is 0.32 by the looks of things, or it could be fail, pass, which is 0.12, so 0.44. Make B the subject of that. AB minus 5A is equal to 2 minus 7B. So we're going to have 2 plus 5A all divided by A plus 7, I think, there. Yeah, whip that over, take the B out, divide, done. Rationalize the denominator of that, root 3 over 3. Expand this, so we've got 2 plus 1 root 3 plus 2 root 3 plus 3 root 3 plus 3 is equal to 5 plus 3 root 3. This is it. This is the question. I knew it. I knew it was like some non-standard 3D shape, and I know that all you needed to do was like to use the properties of the fact that the scale factor squared gives you the relationship between the surface areas of things. I can't believe I remember that. It really stuck with me. I didn't remember what the exact shape was, but I definitely remember that this was a thing. So they're mathematically similar with scale factor 2. The surface area of shape A is 80. So we need to do 80 times 2 squared, which is 320. And then the volume of shape B is 600. So to get to the volume of shape A, we need to divide by 2 cubed, which is 600 divided by 8, which is 300 divided by 4, which is 150 divided by 2, which is 75. Let's do it that way. ABC is a parallelogram. Yeah, it is a frustum. You're right. Yeah, I just remember it was like not a shape that you naturally need to know how to like calculate the area of. Because like that was my mate's problem. It's like, oh, you didn't have like enough information on it to actually calculate it. It's like, well, actually, you don't need to calculate it. If you're watching this, I'm really sorry that I'm kind of singling you out as someone who doesn't know how to answer the question. So we've got another dreaded vectors question. So find MB. So that's just half of A, surely. And then MN. Half A subtract half C. Show that CA is parallel to MN. So CA is C minus A, MN. So let's phrase it like that. CA is equal to C minus A, which is equal to 2 lots of a half A minus half C, which is equal to 2 MN. Therefore, they are parallel because one is a multiple of the other. Difference of 2 cones, I like it. Okay, So this looks like an interesting question. Cylinder has base radius x and height 2x. The cone is like that. They are equal in volume. So the cylinder has pi x squared times 2x as its volume, and this one has pi x squared times the height divided by 3. Find h in terms of x. So let's scrub out a pi, let's scrub out an x squared. We want h is equal to 6x. Simpler than what it looked at, actually. Okay, last question. So, diagram shows part of the curve with that equation. So, yeah, we're going to translate this plus 2 over there. So, 4, 3. And then we're going to bump it up there. So, it's 2, 6. And then simplify fully. This is going to be x minus 2, x plus 3 over. I'm getting feeling about x minus 2. Oh, no. Yeah, x minus 2, x minus 5. And then x plus 3 over x minus 5. And I'm done. Right.
Awesome.
Amazing how easy it is. Like, in our day, boy, obviously, it was scaled differently. So, like, to get an A star in our day, you needed, like, 90, I think higher than 90%. You needed, like, a very high mark. Nowadays you can get a grade 9 with well, grade 9 is still tough, but like you can access grade 7, grade 8, that sort of territory with a lower mark. I'll just be right back one more time. I'm just gonna need to back for.
Yeah, it just occurred to me that that's probably the one that I did as well. It was, I remember the sphere to the cone question. Or the cylinders to the cone. I don't remember which one it was now. But yeah, that's fast.
I didn't remember a single question on that. That is the GCSE paper that I also sat.
Yeah.
Didn't have any memory of any of those questions.
Yeah, no, it was only once he said that, oh, I remember this, and I was like, wait, so then I took this. Yeah. And then, yeah, I do remember like the conversion question, well, effectively, but to do with the equal volumes. I think that was 2008. Yeah.
Possibly.
Yeah.
What was
This was the Edexcel one.
Oh, that's Edexcel. That would be why I don't remember any of the questions. I think I did AQA.
There you go.
Ah, yes, it was the advanced paper too. No, I advanced.
Very good.
I think they did the 2007 paper one as well. I think they just gave it to us, see how well we did. I don't think I did particularly well though.
It's like a mock, presumably.
Yeah,
I was gonna say.
a year early. So we did the year 11 GCSE paper in year 10. And then we had another go at it in 2008.
Oh, right, okay. Yes, which feels like that seems like cheating. No, it's
I think it's fairly common these days. James, you probably will know better than me, but I've seen there's a lot more schools that do that now.
The year 10s get to practice at the same time as the year 11s. It's not a bad idea.
Well, now
Maybe.
that SATs, now that stats actually, stats in year 9 were no longer a thing. That gave schools more ability to do the GCSE stuff earlier within year 9. So that
makes
then
sense.
shifted everything down a year, or at least half a year.
Yeah, you can start learning the chunkier stuff sooner.
Yeah, that makes a lot of sense, Motag. I remember long division as being like the one thing that I got really good at, and then I forgot how to do it, and then someone asked me to do it again, and I'm like, I have no idea how to do this. So long divisions. I think that the next time that I had to do that was like long division of polynomials in year 2 of university.
Oh Lord.
Do you remember that?
No, I don't remember that. Oh dear.
Hey, thank you, James. £100 donation. Fantastic. Thank you so much. Remember, all of this money is going to benefit Mind, which is the National Association of Mental Health within the United Kingdom. All donations are absolutely fantastically appreciated. Well, we've just finished paper 23 of 24, so we've got one more to go. We're making very good time. We've got an hour and a half left. I believe if you stick around, Alex might have a little bit of a surprise for us.
I don't know whether it's a surprise or not.
Hello.
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 I'm back.
All right. Hello, Dan.
You just had and also thank you for the donation, £10 of Anonymous as well. I missed that one. Thank you so much for that. Really appreciate it.
Yeah, awesome. Ross and Machine. Yeah, Ross just sent me a really adorable picture of his eldest child watching the TV with me on it. It's very cute. I was saying I hope it's her earliest memory.
I think it might be.
I mean, it's unforgettable, right?
I agree, 100%.
So.
/S.
Nice. God, that feels like about 5 days ago when that happened. It honestly does. Like, I can't believe Cremo was on the call at one point. It feels like so long ago. It's really really weird what it does to you, like when you don't sleep. So yeah, thanks Anonymous for the £10. Is that our James in the £100 there?
Who can say?
Who can say? Well, if it is, thank you. And if it's not, well, thank you anyway. Right, so similar sort of deal with this. I think we're just gonna hammer through this one because I managed to do that last one in pretty decent time. Thanks for joining again, Dan. Good to have you here. Let's see it through to the finish. We just did paper number 22. Now we're doing paper number 23, just to clarify the numbering there. So there's 2 more to go. So we've got the so after this we're going to do the UKMT Maths Challenge paper, which I'll tell you more about once we get there. For now, let's just try and fly through this one with as few mistakes as possible. And I believe this is the calculator paper. So I have come armed with my calculator. Whew. Come on, keep it together. 5 over 12. Okay, and write down the probability that takes the pen that is not black. Okay, use your calculator to work that out. 22.4 times 14.5 over 8.5 times 3.2. Write down all the figures on your calculator display. 11.94117647. Silly question. A weather station is 1,800 meters above sea level. Estimate the mean July midday temperature for this weather station. Sorry. What? What is going on? Oh, we're starting here. It's like when you you fall asleep halfway through the film and then you wake up. It's like, what's going on? I was totally lost for a second there. So the scatter graph shows information for some weather stations. Okay, so this height versus mean midday temperature. So we need to plot these points. So 1,000 meets 20, and 500 meets 22, which is there. Negative correlation, and we want a line of best fit. So let's go for something. It's easier with a transparent ruler, but something like that. That'll do. Never has to be too precise. Okay, now what's going on? So a weather station is 1,800 meters above sea level. So we are 5, 6, 7, 8. So we are there, which is there, which is 11.5. At another weather station, the mean July midday temperature is 18. So, go back to there. So that's about 1,000 and, I don't know, about 1,000. It's not going to be far off. Okay, AB is parallel to, so write down the value of y, 58, because it's an alternate angle. Give a reason, because it's an alternate angle. Wow, that is not even close to the spelling of alternate. Let's see if I can just salvage that. So if I delete those and delete that E there, then that now says alternate. What is happening to me? So here is the front elevation, the side elevation, and the plan of a 3D shape. In the sketch below, draw draw a sketch. So this is like a cube with a square-based pyramid balanced above it. So let's see if we can just draw something like that. I think that'll do. So it looks like kind of like a house. Here are the first five terms, first four terms of our arithmetic sequence. So it's 3n plus 2. It has a solution. Oh, trial and improvement. Who remembers that? So not on the spec anymore, actually. This is something that they removed. So if we do, because it is rubbish, 2.5 cubed plus 2 lots of, in fact, let me do it properly. If I type in 2.5, then that cubed plus 2 of that. So 2.5 goes to 20. So let's try 2.75. That's 26.297. So a little bit lower. What did I say? 2.7. What was that? 2.74. Wait, we only need to find it to one decimal place, don't we? So 2.7, because once we round it off, yeah. Or should we say 2.8?
2.7 sounds good.
Yeah. I mean, it's just a kind of silly exercise, really. 60 students take a science test. It's marked out of 50. Another frequency polygon. Again, I've never seen so many of them. I've seen 2. I think we agreed that it would look like this. Not entirely certain, to be honest, because again, we don't teach this anymore. So kind of just forgotten it. I think it's also just extremely useless as a means of representing data. I don't know if James agrees, as our resident statistician. Well, actually, Dan, you do a lot of data representation, don't you?
Yeah, a little bit. I'm trying to find a way to make this work. Like, what information would I need in order for me to intuitively think that this is the right one?
Yeah, it's bizarre. I mean, nothing. Right, so this is telling us 5x is equal to plus 60 is equal to 360. 5x equals to 300, which means x is equal to 60. Oh, sorry. So that's your equation. And see, these questions are so much on the easy side. You accidentally answered too many of them. So the ratio of British cards to foreign cards is 2 to the 7. and they sell 45 cars. That adds up to 9, so we need to times these 5, so that's 10. A car tyre costs £80 plus VAT. Well, you can tell this is an old paper. Look at that, VAT at 17.5%. Work out the total cost of the tyre. So 80 times 1.175. And this depreciates by 20%. So 12,000 times 0.8 to the power of 2 equals 7,680. Wow, huge loss of value on that car. Almost as bad as mine. No car is as bad as my car. Okay. 2a plus 4c. S equals half at squared. Where have I seen that before? That is displacement with a constant acceleration with initial velocity 0. It's funny how they slip these in. So half times a quarter times 9, that's 9/8. Factorize that. Expand and simplify. Factorize. Oh, I've used y, but if I say let x equal y and then carry on with the question, I'm not changing it. A shop sells mobile phones. The table shows the number of phones, blah, 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 blah. Work out the percentage increase in the number of mobile phones in April versus May. So that's 6 phones. That's an increase of of 7.06%. Work out the 3-month moving averages for the information in the table. First one has been worked out for you. I don't know what that is. Is that the average of the first 3? And then you slide it along? Yeah, that's what it means, isn't it?
Yeah, that's right.
Yeah, come on. I need your financial acumen here. Yeah, that is right, isn't it? Where have I seen that recently? Did 3 Blue 1 Brown sort of do a video about that? Do you watch him?
Yeah, I do. I can't recall if that was part of his latest video.
Well, I haven't actually seen his latest one, but I think his video on convolutions and like the central limit theorem, that had a lot of like, obviously gorgeous animations as always, but like this, the kind of sliding, moving average, and that was his intuitive kind of explanation of what a convolution represented. Pretty cool, actually. I do like that, those kind of retextualizations that really do, give you a different kind of grounding for what it represents. Yeah, because that's what it was about. It's like smoothing data. Yeah, that sort of thing. He tweeted about my live stream, actually. Really nice of him to do that. Okay, so volume of the cylinder. Give your answer to 3. Well, it's just going to be 16 pi, 160 pi, isn't it? So 160 pi, which is 502.3 because we're rounding up. The cylinder is made out of wood. The density is 0.6. So can I just check that? Pi times 4 squared times 10. Yeah, that is right. Work out the mass of the cylinder. Well, M is equal to rho V. So that's 0.6 lots of the volume which we worked out in the previous part. So if I times that by 0.6 and then 302 to 3 significant figures. ABC is a right angled triangle. Work out the area of the triangle, 28. Work out the length of AC. So the old Pythag, so it's just the root of 7 squared plus 8 squared. So root of 49 plus 64 is root 113. To 2 decimal places is 10.63. Easy. Alright. Oh, and now this is continuing on from question 14. DEF is another right angle triangle. 32, 46, and Y. Okay, so Y is the arctangent of 32 over 46. So arctan 32 over 46. 34.8 degrees. Okay, triangle A reflected in the x-axis. Boom, 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 to give triangle B. And then triangle B is reflected in the line x equals 1 to give triangle C. So, boom, boom, boom. Describe the single transformation. So, this one, rotation, 108 degrees, about, I'm thinking that point there, about 1, 0. Yeah, I enjoyed this video on the central limit theorem, because I'm one of those stereotypical mathematicians who really just does not get or like statistics, much to James's chagrin. But yeah. So what is that? That's going to be 2 times 2 times 113. Now, is 113 prime? It looks prime, doesn't it? 113, come on. How could it not be? It would need to be divisible by... It's not divisible by 7.
7 would be the best chance you got.
Yeah, and in fact, I think it would have to be 7, and it isn't.
Yeah.
So because it's
how did you get 113?
Oh yeah, that's the more important point, Ollie. Yeah, because yeah, for some reason I was reading this as 452. Well, because it's yeah, it's 126, 63. So it's 2 squared times 63, which is 2 squared times 3 squared times 7. So I don't know why I'm not just using my calculator for this. I used to be rapid at prime factorizations. Yeah, so that's it. Okay, he thinks of two numbers. Highest common factor of my two numbers is 3. Lowest common multiple is 45. What two numbers am I thinking of? What do we think? 3 and 15? No, absolutely not, because then the lowest common multiple... Right, so let's actually think about it. So it must be 3 times... Because 45 is 3 times 3 times 5. So it's 3 times something. I think if we take 2 times 3... No, you can't have 2. 9 and 5... No. Come on. Come on, brain. The two numbers must have a 3 in them. 9 and 15. Highest common factor of 9 and 15 is 3, isn't it? Yeah, sorry. I was a bit of a meltdown there.
James, were they the numbers that you were thinking of? We're just checking in the chat.
All right. Oh, God. I'm actually really quite tired now.
Power through.
Yeah.
Yeah, you're there.
1.51 times 10 to the power 26 times it by 20. And we get 3.02 times 10 to the 27. Can't be 3 and 15. That was my first thought, because then the lowest common multiple would be 15 itself. Would 3 and 45 work?
Yes.
Yes. Yeah, that also works. Yeah, James. Yeah, you're catching up there. Yeah. Yeah, because you could take, yeah. It's a good question, actually. Yeah, which two numbers could James... Oh, I've just got the joke. Sorry, I've only... Sorry, Dan, I was a bit slow on the uptake there. So I didn't realize it was James was the name mentioned in the question. So y has to be bigger than that, and x has to be bigger than that, and y is less than or equal to minus x plus 6. So if we draw this 45-degree, y is got to be less. So this
Thank you to Preston for the £40 as well. Thank you very much.
Preston, what would I do without you? Thank you very much, Preston. Really, really appreciate it. Right. Calculate the area of the sector. So it's pi lots of 13 squared. And then 150 times 360. So 150 over 360 times pi times 13 squared, which is 221 to 3 significant figures. They love 3 significant figures, don't they? Q is directly proportional to 1 over t squared. So that means that qt squared is equal to k. 8.5 times 16 is equal to k. So 8.5 times 16. So k equals 136. We want a formula for q. So 136 over t squared. Calculate the value of q when t is 5. So it's 136 over 25. 5.44.
Thank you again, Preston, for another £40.
Oh wow! Thanks so much. That's awesome, Preston. Thanks so much. I'm wondering if he's got something up his sleeve here. I haven't quite worked it out yet, because last year, no pressure, Preston, if you haven't done this, but last year he said like this amazing speech which made reference to like one of our favorite albums that we listen to. So I'm just wondering if there's something to this. So only Preston could make a donation, and it would make me suspicious. Like, what's going on? Like,
So, is there anyone here who can teach me calculus, or at least Pythagoras? as I fear I'm lost and cannot numerate again. Just counting in the afternoon, but something doesn't add up too. Questions create long equations, turning numbers into letters. I try to simplify and cancel out on either side. A logic in the algebra, a riddle staring back at me. It's maths.
Yeah, love it. So yeah, I'd be amazed if anyone else gets the reference, but I knew I knew I knew there'd be something. Just absolute legend. So good. Um, well, James, can you believe it? It's another history. Yeah, thanks so much, Preston. That's really made me smile, actually. Um, so 1,000 times something is 16. So that there is 0.016. Is that what we're saying?
I think so.
So 1, 2, 3, 4. So I guess this here. Oh, this is awful. 0.04, 0.08, 0.01, 0.0. I think I've even got these wrong. 0.12. I think there should be an extra 0 in there. 0.004, 0.008. This is horrible. So 2,000, 2,000, 2,000, 4,000. So we've got this one. That's the frequency density. So if we times it by 1,000, that's 20. We've got this one as well. This is like 0.01. Times that by 2,000, we get 20 again. Yeah, that makes sense. It's the same area. Now this one, 16 divided by 2,000, 0.008. So it's there. Um, 0.006. Sorry, that's that one. $12, and then 8 divided by 4,000. For there. Wow, what a very tedious question that was. Okay, Katie drove for 238 miles. Oh, what have I done wrong now? Come on. Which one? 1,000. That should be 18, should it?
Yeah.
I don't see how. Because
Because it's only like half a block as opposed to like a full. So it's like 0.016 plus 0.002.
no, I don't agree. It's got a height of 0.02 and a width of 1,000.
I think that's a height of 0.018.
Oh yes, you're right. You're right. So that is 0.018. Thank you. Couldn't spot it there.
Thanks, chat.
Y Wong to the rescue again. He's been extremely helpful. A couple of questions I was really stuck on. Really helpful. Right. Katie drove for 238 miles. Correct the nearest mile. She used 238 litres of petrol. Correct the nearest tenth of a litre. Work out the upper bound for the petrol consumption. So this will be given by the upper bound by the lower bound. So the upper bound for the number of miles traveled is 238.5. The lower bound for the number of liters of fuel used is 27.25. So that's 238.5. 8.75. Show that this equation can be rearranged to give that. Well, 5x subtract 5 is equal to, don't try and do every step in your head because you'll make a mistake. That is equal to 8. Take 6x plus 4x, take 2x, subtract 3x squared. Take that over. Plus 7x, and then minus 5 subtract 8 is subtract 13. That's 113 as required. Now solve. All good there. Now this is a triangle. Right, so 15 squared is equal to 10 squared plus 12 squared minus 2, lots of 10, lots of 20, cos, let's call that theta. So theta is equal to the arc cos of, if we just do the old switcheroo there, we're going to get arc cos of 10 squared plus 12 squared minus 15 squared all over 2 times 10 times 20. I'm expecting a normal angle here, like maybe 70 degrees or something like that. So not that. Oh yeah. 12. Thanks guys. I'm actually like starting to close my eyes and like as if I'm slightly going to, oh, what now? Plus 85.5 degrees. That looks plausible. Final question of the paper. Okay, we've got an exponential curve here. That's interesting. Don't really see that. See those at this stage. Calculate the value of k and the value of a. So 7 is equal to ka, and now 175 is equal to ka cubed. So if we take that one and divide it by that one, 175 divided by 7, sorry, is 25. So 25 is equal to a squared, which means a is 5, and a is 0, which means we don't need to consider a equals negative 5. And that means k equals 7/5. Sorry, k equals 7/5. So k equals 5. 5 times 7/5. I got those the wrong way around. Yeah, that's it. That's the answer. Okay. So. Awesome. Gosh, I am tired. Oh, and it's past 11 o'clock. Yeah, because what I wanted to do was we're going to do the final paper now. I'm just going to get straight into it because I think I do need the loo actually because I've been drinking a whole lot of water. So just to give you a brief synopsis about this. So this is the UKMT Maths Challenge. So this is the UK Mathematics Trust. They are a charity who they make challenging papers based on the kind of school like kind of main curriculum, but in you know, just kind of novel and sort of interesting spins on the sort of things that you're going to be learning at school. So the interesting thing about I absolutely adore these papers. I used to love doing them as a student, and I used to love setting them to my students as a teacher, because the great thing about this is, so it's like there's 3 levels. This is the intermediate level, so this is set at the same level as the papers that we've just like been looking at, the GCSE. However, it'll start very easy. You know, don't get me wrong. There'll be some gimmies on there, but the questions quickly become actually pretty challenging and more like puzzle kind of questions, not like Olympiad level questions, that sort of question, but like they become very interesting and very difficult, but they don't require any new mathematics. That's what I love about them. They take the maths that you already know, but apply them in very interesting ways. So I'm excited to do this. Now, my plan for this was actually, because this is 60 minutes, what you're supposed to do as a student is you're supposed to kind of go through the paper. It's split up into a couple of sections. The later sections actually have negative marking because it's multiple choice. What I was going to do is I was going to give myself 60 minutes and I would do the paper as if I was actually sitting it and then see what score I would get. And even though it's a paper that's meant for 16-year-olds, and I am a more experienced mathematician, I am sat here having been awake for probably 26 hours now, and I've been doing maths non-stop for the last 23. So I'm not at my best, let's say, as you've all seen, which has been a little bit embarrassing at times. I apologize for that. So that's what I was planning to do. So maybe we'll do that, but I'll maybe just give myself like 45 minutes. So if you want to get on that stopwatch, Ollie, I'm just going to nip to the loo. So I'll be back in just one moment, and then this will be the final paper. Let me update the exam counter now, because we are on the last one. Thank you so much, everybody who's joined me for this. It's been epic. I think this has been my favorite one, actually. The first one was good because I don't know, it was just kind of new, it was fresh. Last year was awful. I hated it. I was so tired. It hit like 11 p.m. and I just immediately crashed, and I looked at the clock. I'm like, oh my god, I've got like 13 hours to go. Whereas today, I've been like full of energy right up until about 2-3 hours ago. When I did that IGCSE paper, that really just took all the wind out of my sails. I don't really know what went wrong with that one. Just a couple of questions. I'd say it was that golf question, wasn't it? So this is a UK MT intermediate paper. Thanks, James, for sharing those links. I think it's really important that people go and check them out. Like I said, they are a charity, so feel free to make a donation, etc. So yeah, if you want to play along with this, don't write your answers in the comments, because I do want to just like, this is just for fun really. I'm going to answer it and see how far I can get in like that 45 minutes. Maybe you play along as well, and then we'll have Dan or Ollie at the end. We'll go through the answers and you can mark your own. Just be aware that some of the questions are marked negatively, so sometimes it's better not to answer at all than to mark the wrong answer on a bit of a guess. So this is a UK MT intermediate. I must extend my huge thanks to the UK Mathematics Trust for allowing me to use these papers. It's really generous of them, because usually it's kind of just like a in school sorts of thing. So they do. So the papers, they do sell. If you're interested in this style of question, they do sell books that contain like all the past problems, and they're genuinely really. I've actually got a couple of them, and they're actually really good. And I think they're good like training of like, you don't have to learn anything new, you're just learning new ways to apply it. That's the best way that I can describe it. If you want to get good at that kind of problem solving, but based on the content that you should already be familiar with, it's really good. It's really good for that. So I'll be back in just a minute, and then we'll get into it. Last paper.
Let's go.
Hype, hype, hype. I'm
This is really good.
massively up for this.
I'm very excited for the UK Maths Challenge. I loved these. These were so much fun.
So good. We should say, for those who are interested, in the UK, this is our feeder exam, first level feeder exam to the Olympiad. So if you get a score in the top 8,000, well, if you get a score in the top 1,500, you go straight into one of the Olympiads in the UK. If you get a score in the top 8,000, you can participate in the kangaroo papers, which I think are European regional papers. So yeah, that's to set this in context. This is the way that in the UK we find people to participate in the Olympiads. And yeah, so what a great 24 hours. It's nice to have some statistics. Have we had statistics on here before? I don't think we did. So I was happy to see that. I saw a bit of the sets, numbers, and functions paper. That was fun as well.
Well, I'm gonna have to rewatch that.
Oh, you want to rewatch that bit?
I've not seen it yet, so I'm gonna save that for later.
We've renamed variables a few times. I enjoyed that. I feel like we had to do a lot of vectors this year. I feel like we did a lot of that. Yeah, Casper, you have to be in the top 8,000 on this paper to participate in the kangaroo. So I feel like we did a lot more. I feel like we've done a lot of histograms as well. I feel like we've been doing a histogram every like 2 or 3 hours. Yeah, we've done a lot of histograms as well. Yeah.
I do love Alex's reaction every time.
Yeah.
Another one.
Oh. Dan, you got any highlights? Well, maybe he's dropped off as well for a couple of minutes.
Just looking at some of these comments about the kangaroo. So the kangaroo are usually like to enter the kangaroo you need a sufficiently high UKMT score. So this is like the first stage of like the British competitions. Did you ever make it that far, either of you?
I did kangaroo.
I got to the kangaroo. Yeah.
Yeah.
And then I did really badly. Like the kangaroo paper is, funnily enough, a lot harder.
Yeah, it is. It is. Yeah, I think that was exactly what happened to me as well. Because I don't think I was particularly special at maths at that age, and certainly didn't have the motivation for it. Because I think you do actually need to prepare and actually take it seriously if you want to do well on it.
Sure. But it did give me a lot of confidence getting to do the kangaroo paper. It was useful.
Yeah, that's nice. Yeah, that's part of it, I think, isn't it? All right, let's do this. 45 minutes on the clock, please. Have you got the stopwatch there, Ollie?
Yep.
I don't have any paper left. I've used all of my paper, so let me just grab a handful there. Okay, and this will take us to midday. I'm looking forward to this, actually. I enjoy these. So, here we go. 60 minutes is what you usually get. So, I'll just say, just in case anyone does want to play along, 5 marks for any of the questions answered correctly from questions 1 to 15, 6 marks awarded for questions 16 to 25. However, at 16 to 20, you lose a mark for an incorrect answer, and 25 to 25, 21 to 25, you lose 2 marks. So that's how the scoring works. So let's start that clock. And here we go. All right, well, they start pretty easy, don't they? So I also don't know how people are going to play along, actually, because I'm going to be selecting a lot of the answers. So also, this is non-calculator. So use of calculators and measuring instruments are forbidden, just in case anyone was about to bust out the measuring instruments. So how many hours in 6 minutes? Looks like 0.1 to me. My recipe for apple crumble uses 100 grams of flour, blah, blah, blah. 2.5. Right, so you're making 200 grams. And then 2.5 times that, so 500 grams. Okay, in the Caribbean, loggerhead turtles lay 3 million eggs in 20,000 nests. So 3 million in 20,000 is 150. Workers digging a tunnel for an underground railway complete 5 meters of tunnel on a typical day. (2,000 meters) 5. So that's 400. So just over a year. Let's go with that. Which of the following has the same value as that? Ooh, okay. It can only be one of those two. And I think it has to be this one, doesn't it? Because if you decrease that one by 6, decrease that one by 6, the difference is still going to be the same. Yeah, and that is way off, so that one. What is 20% of... so let's do a fifth multiplied by 15 over 4, which is... cancels 3/4. A function machine does the 4 operations shown in that order. Iris inputs a positive number and the output is also a positive integer. What is the smallest positive number? Well, if you put in, if the output is 1, because these are all decreasing, so yeah, 1 plus 10 times 3 is 33, 43, so 132 I'm getting. Nope, 129. What is the difference between 40% and 50% of 60 and 50% and 60% of 70? So 40% and 50% of 60 is 40% of 30, which is 12. And then this is 42, 21, so the difference is 9. The number x is greater than 2022, which is the smallest of the following. I love questions like this. So this is 2022 plus epsilon, let's say. So that's okay. Well, it can't be that one because C is bigger than A for sure. And D is smaller than B for sure. And E is even smaller than... Oh no, we're looking for the smallest. Sorry. So it can't be A. It could be... so it can't be C, sorry. It could be A. Can't be that one. Can't be that one. It's between these two. Oof. I think it's got to be E, isn't it? Big fat denominator. Yeah, happy with that. So 100 rectangles are arranged edge to edge in a continuation of the pattern shown. Each one measures 3 by 1. What is the perimeter? Oh, I love these. So that's 3, 3, 1. 2, 2, 1. It's 12. Each pair contributes 12. So 12 times 50. But we've got the 3 at the end there. But I think here so that's 603, but actually we don't get that at the end, so that's 601, but we do get that at the end, so that's 602, I think it's 602. In a janky, that's very janky how I've done that. Okay, Universal Magazine of Knowledge and Pleasure. Wow, sounds like a magazine for me, to be honest. Ask the following question. What number is it that whose quarter shall be 9 more than the whole? Is it that? So the quarter is, yeah. A shape shown is made up of 3 similar right-angle triangles. Oh, how did they come up with these beautiful diagrams? What is the area of the shape? Well, 2 squared plus 2 squared, this is 4 plus 4 is 8, so this is root 8, and then root 8 squared, that's 4, and that's 4. That's so cool. So that has an area of 2 times 2 over 2 is 4. Root 8 times root 8 is 8 over 2 is 4. 4 times 4 is 16 over 2 is 8. So add them all up, 14. How many sets of 3 consecutive integers are there in which the sum of the 3 integers equals their product? Well, 1, 2, 3 works. You add that many times and you get 6. And I imagine it might not ever work again. What about minus 1, minus 2, minus 3? Because it doesn't specify that they're positive. You add them up, times them. So that's 2. And I suspect it doesn't happen again. 2, 3, 4. Yeah, that's massive compared to the sum. So I'm going to say 2 for that. In a number pyramid, each cell above the bottom row contains the sum of each cell above the bottom row contains the sum really below. The 3 numbers on the second row are all equal. So A, 2A, 2A, 4A, and half A, half A, half A, half A. The first statement looks not necessarily half A actually. Could be, yeah, that you get A and... Okay, so it's not the case that the bottom row must contain at least 1 0. The third row contains at least 1 0. Definitely not necessarily the case. The top number is a multiple of 3. Nope. Top number is a multiple of 4. I do agree with that. I do agree with that because of how this is worked out. So D. God, I feel so sick. Struggling. Reflection in the line L transforms the point with 5, 3 into the point with coordinates 1, -1. What is half of that? Half it. Yep, I'm happy with that. Alright, looks like a bit of sphere packing here. Again, something I'm hoping to talk about soon in an upcoming video. It's all connected, all the Steiner systems and everything like that. So the first figure shows 4 touching circles, radius 1 in horizontal row held together by an outer band. It's surely got to be that first one. Because that's the length of y, and then the radius 1, so you're adding 2, so yeah, it's got to be that first one. Dick Turnip sold his horse Slack Bess fantastic names, for £56. The percentage profit he made was numerically the same as the cost in pounds of his horse. What was the cost of the horse? Oh my god, so tired. Well, we could do this algebra. I'm actually just like do a bit of trial and error here, because it's got to be one of these 5 answers. So, if it was £36, then his profit would be 10. Oh god, I'm really struggling here. I've suddenly become very tired. I mean, I didn't get the reference, James. Don't get this. This percentage profit he made was numerically the same as the cost in pounds of his horse. So 40, yeah. So if it was like £40, for example, we want 40%. So 10 over 36. Don't think that works. 40. Then he would make £16 profit over the 40, which is yeah. So it's 40. All right. So now we're on to these are the like challenging questions. These back page ones. Gosh, I'm so tired. I know we're kind of doing this under test conditions, guys, but could you give me a little back and forth or something?
Sure.
I'm really flagging. I think I need some, I need Dan Reeve to wind me up or something.
Some hype.
Some hype, yeah.
I do think in some of these they expect you
go.
to exploit the fact that there's 5 answers, right?
Yeah, I think that is very much part of the strategy. I think, because that's something I used to train kids to do. Like, if we were trying to get them to do this challenge, then yeah, if you don't spot a good way of doing it, then trial and error is an acceptable option. The worst part about the trial and error is sometimes time, yeah, and sometimes if you've misunderstood the question, you can spend your time doing all 5 of them and none of them work, which is what you get to the end and you think, well, okay, the answer's none of them. But yeah, time is obviously the like you need to judge when is a good time. Okay. This is interesting, isn't it? What is that theta there? 12 pi all the way around. And then 12 pi times theta over 360 is equal to 10. So that, and the area is pi r squared. $30. Not easy. Well, that wasn't easy.
Yeah, that's a fun one.
Plus, I'm in that stage now where I am like, sometimes if I close my eyes a little bit too much, I genuinely like fall asleep for a split second. This is happening last year. Oh, God, I just feel awful now. It always happens. It's always the stomach's always the first to go because I just start to feel very nauseous.
Well, you've still got quite a few questions to go, and you've got what 23
minutes to do six.
About halfway through the time.
That's correct. 23 and a half.
Yeah,
well,
six questions to go. Although these are the actual tricky ones now. So Arun.
I love these median and clever median and mode questions. It's just my absolute favourite.
I like them as well, actually. That was one of my favourite starter activities, actually.
Yeah.
It's a good one. So the mode is 2 more than the median, and the mean is 2 less than the median. What is the largest possible value of the range of his 5 integers? Oh my God. Okay, this one's actually quite hard though. Oof. So we've got our median there. So the mode is 2 more than the median. It must be n plus 2, n plus 2. Has to be the case, right? And then the mean is 2 less than the median. So when we add them all together, divide by 5, we get m minus 2. Um, Yes. Not quite seeing how to do this. So
What is your n again?
m was just like the median. That's the one in the middle. So we've got, yeah, 3m. Let's call this m minus something, m minus something. So in total we get 5m. This has got to be a multiple of 5 is the thing. So I'm really tempted to say that. M minus 5, m minus... I'm avoiding doing this, but I think it might be the time. So right, what have we got here? We've got 5m plus 4 minus a minus b all divided by 5 is equal to m. The mean is 2 less. So that means 5m a is equal to m is equal to 5m minus 10. So a plus b is equal to 14. So I don't think it could be that. Oh, it could. M minus 1, m minus 14. Then, sorry, 13. Then there's a range of 15 there. So for example, what if we chose like 14, 13, 1, m plus 2 is 16, and then 16 again. Range is 15. So we're testing if we can possibly have a range. The mode is 2 more than the median. And let's just check this. These should have a mean of 12. Yeah, so it is possible. D 15 is the answer that I'm going to go with there. Whew. Tricky. Or maybe it wasn't. I reckon you might have a better way of doing that one, James. The diagram shows a shaded semicircle of diameter 4. So by Thales' theorem, that's 90. We've got, and that's 2 because it's radius, 2 because it's the radius of the big one. And then if we go straight down, it's 1 and 1. Okay, so area of the big thing is 4 pi, because it's 2 squared, it's 4 pi r squared, and then area of the shaded is 4 pi subtract. So I think I've deduced that it's I've got a radius of 1 there, so it's subtract pi, so it's 3 pi. That's the area of the shaded. What fraction of the larger semicircle? So 3/4. Damn it, that isn't one of the answers. Oh. must have been wrong about this inference that I made here. But, oh no, oh god, I've not divided any of these by 2, so that's 2 pi. And then area of the shaded bit is going to be 2 pi minus pi by 2, which is equal to 3 pi by 2. So if I do 3 pi by 2 as a fraction, is equal to 3/4 again.
What's the radius of your inner?
Yeah, I actually don't know that this is 1. Yeah, I've just spotted that. Well, I do know it's 1. Yeah, I do know it's 1. Getting 3/4. It's not the answer.
So if you do Pythagoras's with to double check that one.
Oh yeah. One squared plus 1 squared equals 2. It doesn't equal 2 squared. Oh god. Oh god, I'm actually dozing off yet. So it's x squared plus x squared is equal to 2 squared. That's the point. So it's root 2, isn't it? So pi r squared pi times root 2 squared is equal to 2 pi, but we're dividing it all by 2. So that. I was really hoping that we get a root 2 involved. So we just get pi. That's the area, I think, of that thing there. Oh god, I'm just going to get back to where I started. So the area shaded. So is it a half? Yeah, it's a half. I'm not going to finish this, am I? Or maybe I just have a look and see what questions it looks like I can do.
Yeah, I think you should pick your favourite from the last 4.
Oh, they all look good though, don't they? Pete's pies cost an integer number of pounds. Alright, this looks good. A cherry pie costs the same as 2 apple pies. A blueberry pie costs the same as 2 damson pies. A cherry pie and 2 damson pies cost the same as an apple pie and 2 blueberry pies. Paul buys 1 of each type of pie. So he spends A plus B plus C plus D. So
Now I want a pie.
Yeah, always. A plus 2D plus C plus D. We've used that. I was looking at using that, but I don't. Why do I want C involved? Oh God, I know how to do this kind of question. I'm just not falling out yet. B is 2D. C equals A plus 2D. Oh, I need to plug my headphones in. Oh, come on, I should be able to do this. Oh, come on. I just can't freaking see it. Maybe there. Right, so I think I'm getting that the total cost is 9D. That means it has to be a multiple of 9. So I think it's that. Obviously, it's a bit risky to bet on that. But I think it's worth the bet. Pretty sure. I mean, the fact that it came out to be a multiple of 9 and there's only one multiple of 9 in there, I think that's quite tasty. Right.
It's
Alvita.
like damson pies.
Quite tasty indeed. Planning a garden patio to be made from identical square paving stones.
Oh yeah, I like these ones as well.
Struggling to picture this. So, planning a garden patio to be made from identical square paving stones laid out in a rectangle like x by y, measuring x number of stones and y number of stones. She finds out that when she adds a border of width 1 stone around the patio, so basically adding a layer, around it, okay, the area of the border is equal to the original area of the patio. Oh, yes. So the new area I think is x plus 2, y plus 2. So this is the border. So it's like that's now an x plus 2 by a y plus 2, but we need to delete the innards, which is xy, and we're now saying that this is equal to the original area of xy. I think this is it. So xy plus 2y plus 2x plus 4, subtract 2y is equal xy. I think it's 2y by xy. So they die. And then 2y plus 2x plus 4 is equal to xy. Now, how many possible values for x are there? Again, I'm just not seeing how to do it. Like, could x be 1, for example? So then you get... Why don't we get our hands on y? 4 minus x1, 0. X 2 minus x is equal to what's happened here? That's a y. So this is an integer, then y plus 4 divided by x divided by y minus 2 . So y could be 3, for example. Y could be 4. Can't be 5. Be 6. Don't think y can be odd. So it could be 7. 14 plus 19, no. Could it be 8? No. Could it be 9? No. 9, 10, 11, 12. I'm thinking 3, but well, 3 isn't one of the options. So are we going to commit? I think I've maybe missed one. I think it's more likely that I've missed one. I would say 4. I
have 1 minute remaining.
I'm gonna circle 4. That's midday. I think I will stop there because I'm not gonna get into another question. Oh,
Well done.
Amazing.
right, done. Oh my god.
Nicely done. Same again tomorrow.
You've been waiting 24 hours to say that, haven't you? Oh my god.
Oh, we love to see it. We love to see it.
That is a seed of a lemon. So, oh my god, suddenly feel incredibly tired. I wonder why. Right. So, let's hear the verdict then. What's the score? Did you play along?
Okay.
Or did you tot up as I went?
I didn't tot up as we went, so let's have a quick look through that. Or I can announce them out and
Yeah, go on.
And give yourself some ticks. All right. So for number 1, we've got B, which is a 0.1.
Yeah.
For 2, it's A, 0.5 kilograms. For 3, it's B, 150. D, 4 is D, which is 400, just over 1 year.
Yeah.
5 is C. Yep. And D, 6 is D, 3.4. 7 is E, which is, what was it, 129?
129, yeah.
8 is A, 21. Required difference is 9, yep. 9 is E, largest denominator, 2022 over x plus 1.
Yeah, that took a minute, that one. I was least confident about that.
Yes, they went along the lines of eliminating A and C.
Yeah,
and then
that's
the
how,
remaining 3 fractions.
yeah, that's how I did it. Yeah, because some of them are literally clearly larger or smaller than the others.
10 is C, perimeter of 602. 11 is E, which is negative 12.
Okay, good.
And then 12 is A, the area of the shape is 14. 13 is C.
Oh no.
There are 3 sets.
Oh,
of
minus
consecutive
101.
integers. I'm afraid so, yeah.
Of course. Bloody hell, it's so obvious, isn't it? Jesus. Right, so I didn't get that
at
one.
least you didn't lose a point for it.
No, I didn't. No.
Okay. 14 is D.
D for delta.
Exactly so.
Yeah.
15 is E, which you got.
Okay. So that's the end of like the first section. So I got 14 times 5 out of that. God, this is like a math question in itself, isn't it? Which is 70 marks.
Cool. 16 is D, 2 to the 4043.
Yeah.
17 is C.
Okay, so they're the same length, are they?
Yes, the 2 bands have the same length.
Oh, the bands. Of course. Yeah, I just misunderstood. I thought it like literally meant the length of the object. I was just I was very that makes way more sense, and that's a much more interesting question. So
okay, good.
Yeah, because you basically
I nearly said something. I was like, I'm pretty sure he's not doing the right thing here. But
yeah,
okay.
yeah, forget it. So that
18 is. You're right. It's a negative 1 point, isn't it? Okay. But onwards. 18 is B. Slack best cost £40. 19 is A. The area is 30. Which you did get, didn't you?
Yeah.
And then 20 is D. Largest possible range of values is 15. And 21 is B, which you did get, I believe.
Yeah, and this is the type of question that I think of when I think of these challenge papers, which is like these interesting shape arrangements. You know, like that one, and what was that one with the beautiful like nested. Well, they weren't nested, but this, these kind of triangles that are growing
Yes,
inside. It's just so cool.
They're very cool.
Okay, now I didn't actually answer 22 or 23, so I don't get penalized there.
Oh, thank you, Charlie Vane, for the 99. Well, now what is RON? For the 99.99 RON.
What is Ron?
I do not know, but thank you very much all the same.
Romanian Lou.
All right, brilliant. Well, however much that's worth, I thank you very, 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 very kindly for that.
And
that's
also
that's
thank
awesome.
you to Pi Squared for the £9.87.
Excellent work. And thank you for Seth for the £5. That's awesome. All right, so thank you so much, guys. It's awesome, actually. I think with the super chats, we might actually be approaching 4,000 here, which is absolutely fantastic.
Awesome.
Okay, so just for the viewers, in case they attempted these questions.
Yes, if you attempted 22, then the answer would be D. Do I explain the method for this, or shall I crack on?
No, I think let's just get rid of. Let's just go through the rest of the answers.
Right, move on. 23 is E. So 8 minus 4 root 3.
Yeah, I think I can see how this one. This is the one I would have done if I had a bit more time.
Yes, it's quite an interesting one. 24 is B. Yes, so you got it exactly right. You got the multiple of 9, and then only 18 satisfies the requirement.
Yeah, the only reason I was worried about that is because it could have been an 11. If it was actually supposed to boil down to 11, that 22 stands out there, and that's a good distractor actually, because it's like it's a tempting weird number, isn't it?
Yeah.
Okay.
Yeah, if you can get there, then maybe you'll find a way.
Yeah, and I'll be honest, I kind of gambled on this.
And then 25 is C. Yep. So yeah, you did all of the equations right, and then it's just working out multiple different values for x, y, and x minus 2 and y minus 2, and you got 2 of the 4.
It was a bit of a bodge, really. Yeah, well, I ended up getting 3 answers, and they did work. So I'm like, well, it can't be these, and I don't think there's many more, so I'll go for that one. So it's a bit of a risk.
Yes. There are eight solutions in total, but 4 have negative numbers for the x's and y's. So yeah.
Perfect.
Exactly so. Well done.
All right, so and then another 6 here, another 6 here, so that actually makes 7 lots of 6, which is 42, and then I lost 1 mark, so 111. That looks like. Again,
marvelous.
I'm so done with doing maths for at least.
That's the last sum that you're going to have to do today.
And it's wrong as well. No, it is right. So 111, which I think is a pretty decent score. Obviously, I'm kind of cheating a little bit because this is not a paper that's designed for. It is designed for 16-year-olds. But I think you'll appreciate even as experienced mathematicians, they're not easy, are they?
No, they are not.
You've got to think about them, and the fact that you've got 60 minutes, which it adds pressure. But I just, like I said before, I absolutely adore these papers. Okay, so.
And thank you to Safe for the £5.
Yeah, awesome. Yeah, that's really good. Yeah, all right. Well, I think that about does it. Well,
and relax.
Yeah, I did it. I enjoyed it. I know I got frustrated at times, and I know that there were a few moments of just like sometimes you get to the end of the question. You know it's wrong, and then you think, I've got to do that all again, because there's no way I'm going to find my mistake in there. So there's a couple of frustrations there, and then there's a bit of frustration with the... oh God, there's some like properly difficult questions. If James is still on the line, I'd love to actually talk to him about this this paper from the IGCSE. Are you still there, James?
I am here. I mean, I'm not sure we want to talk about that IGCSE paper anymore. But what were they playing at, honestly?
Well, no, I'm talking about the other IGCSE paper.
Oh, the other one was the other one terrible as well.
Well, it had a very fiendish question on it.
Oh goodness.
I will take a moment to just like pause and celebrate, by the way, but because this is classic me, isn't it? Like you achieve something and then you immediately criticize yourself for getting frustrated and like looking back on all the failures. This is like literally this is iconic, Alex. So this is it was this one here, which you probably can't really see very well.
Well, I got to wait for it to come up, and just while I'm doing that, my final thoughts, if you're asking me, is it's a great day for maths. It's a great day for mental health, and it's a great day for the Another Roof community, I think.
Yeah, absolutely.
So
Yeah. No, I'm absolutely thrilled at the number of people who stuck with me throughout the whole throughout the whole thing there. More than I expected, to be honest, because we were trying to judge this, weren't we? It's like 35k. But live streams, they never really do huge numbers. And it's not really about that, you know. I think we had
no, not at all.
We had like number. Yeah, we did have the perfect number because it was like it wasn't totally overwhelming in the chat. It wasn't like constant streams, but it was also there was enough there that there was someone called Kat who I owe an absolutely enormous thank you to because
Kat's here with us. Kat's with us.
Oh, that's
thank you, Kat.
Yeah, that's absolutely awesome because they really helped me in the degree level paper on the number theory questions. I think Wong, I hope I'm pronouncing that right. They just laughing at that comment. It's so true, and actually this is just circling back to mental health. Like this is genuinely something I have to work on, like actively improving my self-talk as they call it, where it's like actually don't just constantly find the faults in everything that you've done. This is like when I started as a teacher, for example, like my mentor, she would like sit down with me after a lesson observation and say, oh, what did you think of that lesson? Well, I did that wrong and that kid was messing about and this was wrong. And then she was like, well, actually 31 kids were on task for the entire time. You gave a really good explanation there. Like I really struggle to find positives in my own stuff, and it can lead to a lot of like just a lot of mental rubbish. So yeah, huge thank you to Kat for helping with those number theory questions, because there were two questions there that I don't think I could have done without them. Y Wong, thank you very much for your contributions as well. There were a few. I feel I'm a bit embarrassed that I can't remember the names, but there was someone. Oh God, they were with us like nearly the entire time. I haven't seen them in the chat for a while. It was a name that started with like a CH. They were like on the ball, like clinically. They were like checking all of my work, really on the ball, and that was really good to have as a kind of constant kind of sanity check. And it was and plenty of other people as well. Sorry, I can't remember everybody's names, but I really did appreciate the comments, the insights, the questions, the corrections, everything like that along those lines. So thank you for from the bottom of my heart, thank you for that, and for all the donations as well. I'm sure Mind will be really appreciative for all of the donations that we've managed to provide. I promise that all the super chat money I will send over to them. And yeah, all good stuff. So
thank you, Peter, for the £50 getting in there right at the end. Thank you very much.
Incredible. That's it's actually just like a little bit overwhelming now. It's incredible. I was anxious that we weren't even going to make it to that target, and then we got there very quickly. Bagley, of course, which is £1,000, just absolutely unbelievable. Thank you so much for that. I know it's a topic that's near and dear to many of our hearts, so I'm really glad that you were willing to support that. I don't know, James, do you want to look at this question?
I've looked at it.
I've
looked at it.
It was tough. It was tough.
I mean, you can just see from the number of variables that you've written on there.
Yeah,
that
exactly.
We were having some fun.
Yeah. Well, let's call this angle beta, and then this one gamma, and then this one alpha, and then it's just like it's a total mess.
Absolutely wonderful. Let's never do an IGCSE paper if we do this again.
Well, they're usually easy. Like, I don't know what the hell was going on here. Like,
IGCSE boycott from now on.
Yeah, bizarre.
Okay, good.
All right, well, shall we wrap up here? So.
Yes, and thank you, Adam Creamer, obviously Ollie, and Dan as well.
Oh, well, you stole my moment there, James. I was just about to.
Sorry.
Yeah.
We were just about to say that.
Yeah, because I was just thinking, like, definitely the last thing I want to do is to thank is to thank you three and to thank Creamer, of course, for giving up your time again to help me out with this. I genuinely this time could not have done it without you, because all of the chat and everything like that, I literally just could not keep up with it myself. I kept glancing up from time to time, but it was just like too much to keep track of while I was trying to concentrate. And it really did come down to the wire this time as well. Like we cut that last one short, really. So it was like, I really did need to concentrate on it. Whereas in the previous years, I finished like an hour early, so I don't really know what happened. It's those IGCSE papers. Ghosty Ocean, thank you very much for that. While I've got you, Ghosty, I don't know if I'm going to be streaming Blasphemous tonight. I've usually got a stream at like 10 p.m. tonight, which is in like 10 hours time. I might do. I don't know. So for people who don't know, I do stream on Twitch some like video games. I usually play like Metroidvanias, things like that. So if you want to follow me on there, that'd be cool. I think I'm probably going to go and lie down. So yeah, enormous thank you to you three. I really do appreciate it. And thank you to everybody who joined, thank you to everybody who donated. I think that's the end. So any final comments?
Well done.
Yeah, well done.
Yeah, well done, mate.
Really fun day, this one.
Top job.
All right.
Perfect.
All right.